Dr. El-Sali.
Dr. El-Sali, you are muted.
Good morning, everyone, and welcome to the 190th meeting of the Vaccine and Related Biological Products Advisory Committee meeting. During topic 1 of this meeting, we will be discussing and making recommendations on the selection of strains for influenza virus vaccine for the 2026 Southern Hemisphere influenza season. I'd like to welcome the members, the participants, and the public viewing the meeting. I would like also to remind my colleagues on the committee that during the Q&A portions of the meeting to use the raise your hand function, so I know that you have a question, and then I will call up on your name. You will go live on camera and then take it from there. Next, I would like to introduce Ms. Cecily Rees, who is the designated federal officer for the meeting today. Ms. Rees.
Thank you, Dr. El-Sali. My name is Cecily Rees, and it is my honor to serve as the designated federal officer for today's 190th meeting of the Vaccines and Related Biological Products Advisory Committee. On behalf of the U.S. Food and Drug Administration, the Center for Biologics Evaluation and Research, and the committee, I'm pleased to welcome everyone to today's virtual meeting. I would like to extend my sincere appreciation to all those who made today's meeting possible, beginning with our Center leadership, Dr. Vinay Prasad, Center Director, his deputies, and the dedicated staff who provide ongoing guidance and support. I would also like to thank the Office of Vaccines Research and Review, led by Dr. David Caslow and his deputy, for their continued leadership and countless hours their teams have devoted to preparing for today's meeting. My gratitude also goes to our phenomenal ethics and integrity team and the disclosure team, on detail to the Office of Shared Services, whose vigilance and readiness to act on short notice are truly commendable. And of course, a very special thanks to our virtual conference center audiovisual team, who are often the last to receive materials, but the first to arrive each morning, ensuring every technical aspect runs seamlessly. To each and every one of you, thank you for your professionalism, dedication, and teamwork. FDA extends its sincere appreciation to the members for their continued dedication and support of this committee. We ask a great deal of them, stepping away from their demanding roles to contribute their expertise here. Their service helps the FDA fulfill its mission, and we are truly grateful for their time, insight, and commitment. And last but certainly not least, we extend our sincere appreciation to our chairperson, Dr. Hannah El-Sali, for her strong leadership and steadfast commitment to this committee. Chairing an FDA advisory committee is not an everyday responsibility, and it requires exceptional dedication, preparation, and judgment. We truly are grateful to Dr. El-Sali's continued guidance, professionalism, and service to the agency, the committee, and the public we serve. I will now read information regarding the press and media. For press and media questions, please direct press and media questions for today's meeting to the HHS press room at hhs.gov. Thank you. hhs.gov/press-room/index.html or 202-690-6343. The transcriptionists for today's meeting are Ms. Virginia Diaz and Ms. Mayra Agrullo. Okay, next slide, please. We will begin today's meeting by taking a formal roll call for the members. When I call your name, please turn on your camera and mute yourself and introduce yourself by stating your first and last name, organization, expertise, or role. And when finished, you may turn your camera off so we may proceed to the next person. Please see the displayed slide in which we will begin with the chairperson, Dr. Hannah El-Sali.
Good morning. My name is Hana El-Sadi. I'm a professor of molecular virology and microbiology at Baylor College of Medicine. My research focuses on clinical vaccine development.
Thank you, Dr. El-Sadi. Dr. Bernstein?
Good morning. My name is Hank Bernstein, and I'm a professor of pediatrics at the Zucker School of Medicine at Hofstra Northwell in New York and a pediatrician at Cohen Children's Medical Center. I'm a general pediatrician with expertise in vaccination and vaccine policy. Good morning.
Thank you, Dr. Bernstein. Dr. Durbin?
Yes, my name's Dr. Anna Durbin. I'm a professor of international health at the Johns Hopkins Bloomberg School of Public Health. I'm an adult infectious diseases physician. My research specializes in vaccine development and evaluation. Thank you.
Thank you, Dr. Durbin. And we have our non-voting alternate industry representative, Dr. Kolmar.
Hi, good morning. I'm Jim Colmer, a pediatrician by training and Scientific Associate Vice President, Global Regulatory Affairs and Clinical Safety, Vaccine Infectious Disease at Merck & Co.
Thank you, Dr. Kolmar. Captain Meyer?
Good morning. My name is Sarah Meyer. I'm a medical officer at the Centers for Disease Control and Prevention. I'm also a pediatrician, and my specialty is in vaccines.
Thank you, Captain Meyer. Dr. Monto?
I'm Arnold Monto. I'm at the University of Michigan School of Public Health in Ann Arbor, and I am a respiratory infectious disease epidemiology with interest in vaccines and antivirals.
Thank you, Dr. Thank you, Dr. Monto. Dr. Omer?
Hi, I'm Saad Omar. I'm the Dean of the Peter O'Donnell Jr. School of Public Health at UT Southwestern in Dallas. My work focuses on interventional and observational studies of vaccines and infectious diseases.
Thank you, Dr. Omer. Dr. Perlman?
Hi, I'm Stanley Perlman. I'm a pediatric infectious disease specialist. My research interest is in coronaviruses, and I work at the University of Iowa.
Thank you, Dr. Perlman. Dr. Portnoy?
Good morning. I'm Dr. Jay Portnoy. I'm a professor of pediatrics at the University of Missouri School of Medicine, and I'm an allergist immunologist at Children's Mercy Hospital in Kansas City, Missouri.
Thank you, Dr. Portnoy. Dr. Rubin?
Hi, I'm Eric Rubin. I'm at Harvard and the Brigham and Women's Hospital and the New England Journal of Medicine. I'm an infectious disease physician, and my lab studies tuberculosis.
Thank you, Dr. Rubin. I will now read the conflict of interest statement for topic 1. The FDA is convening today's meeting of the Vaccines and Related Biological Products Advisory Committee, also known as VRBPAC, under the Federal Advisory Committee Act, FACA, of 1972. The VRBPAC will meet in open session to discuss and make recommendations on the strain selection for the influenza virus vaccines for the 2026 Southern Hemisphere influenza season. With the exception of the industry representative, the members of the committee are either special or regular government employees and are subject to federal conflict of interest laws and regulations. Accordingly, FDA has reviewed the financial interests of the committee members for compliance with federal ethics and conflict of interest laws. We have screened the members for potential conflicts of interest related to today's meeting agenda, both their own interests and both their own interests and those that are imputed to them, including those of their spouses, minor children, and employers. Based on the agenda for today's meeting and all financial interests reported by committee members, FDA has determined that all members of this committee are in compliance with federal ethics and conflict of interest laws. And as a result, no conflict of interest waivers under 18 U.S.C. 208 have been issued in connection with this meeting. Dr. Archana Chatterjee has been recused from the meeting based on today's agenda and her financial interests analyzed by FDA. James Colmar of Merck & Company is participating in the meeting as non-voting industry representative, acting on behalf of regulated industry. Consistent with Commissioner McCurry's April 17th, 2025 statement, FDA is only including the industry representatives in advisory committee meetings where required by statute. FDA is required to include an industry representative in today's meeting under 21 USC 355N3C. Industry representatives are not appointed as special government employees, nor are they regular government employees. Industry representatives serve as non-voting members of the committee. Non-voting industry representatives represent all regulated industry and not any particular association, company, product, or ingredient, and bring general industry perspective to the committee. Under FDA regulations, although a non-voting member serves in a representative capacity, the non-voting member shall exercise restraint in performing such functions and may not engage in unseemly advocacy or attempt to exert undue influence over the other members of the committee. Dr. J. Portnoy is serving as the consumer representative for this committee. Consumer representatives are appointed special government employees and are screened and cleared prior to participating in a meeting. They are voting members of the committee. There are speakers and guest speakers at today's meeting who will give a presentation to the committee, answer questions from the committee, and hand the meeting back over to the chair. They will not participate in committee deliberations, render advice to FDA, or vote. The speakers and guest speakers participating in this meeting are presenting the views of their professional societies and not their personal views. The following speaker and guest speakers have been screened and cleared to participate in today's meeting: Dr. Rebecca Condor and Dr. Thomas Platts-Mills. In the interest of transparency, FDA asks that speakers and guest speakers disclose any personal financial involvement with a firm, product, or other entity affected by the committee's discussions to allow the audience and the committee to objectively evaluate their presentation. Today's speaker and guest speakers have not reported any such relevant interests. FDA asks that all other participants, including the open public hearing speakers, advise the committee of any financial relationships that they have with any affected firms, its products, and if known, its direct competitors. We would like to remind the members that if the discussions involve any products or firms not already on the agenda for which an FDA participant has a personal or imputed financial interest, the participant needs to inform the DFO and exclude themselves from the discussion, and their exclusion will be noted for the record. Thank you. Dr. El-Sali, I now turn the meeting back over to you to commence the open public hearing for session 1.
Thank you, Cicely. Next on the agenda is the open public hearing session. I will read the announcement. Welcome to the open public hearing session. Please note that both the FDA and the public believe in a transparent process for information gathering and decision making. To ensure such transparency at the open public hearing session of the advisory committee meeting, FDA believes that it is important to understand the context of an individual's presentation. For this reason, FDA encourages you, the open public hearing speaker, at the beginning of your written or oral statement, to advise the committee of any financial relationship that you may have with the sponsor, its product, and if known, its direct competitors. For example, if this financial information may include the sponsor's payment of expenses in connection with your participation in this meeting. Likewise, FDA encourages you at the beginning of your statement to advise the committee if you do not have any such financial relationships. If you choose not to address this issue of financial relationships at the beginning of your statement, it will not preclude you from speaking. My understanding is that there are no one registered for the open public hearing session. Is that correct, Cicely?
That is correct.
Okay, so that concludes the session of the open public hearing. Next, we will turn to Dr. David Caslow. Dr. David Caslow is the Director of the Office of Vaccines Research and Review at CBER FDA. Dr. Caslow will give the introduction to VRBPAC meeting today. Dr. Caslow?
Great. Thank you, Dr. El-Sali. So good morning and welcome to the 190th meeting of VRBPAC. The Office of Vaccines Research and Review is particularly thankful to the FDA staff and to you, VRBPAC members, for the opportunity to hold this meeting in the context of a lapse in appropriations. Today's meeting addresses the timely need to consider updates to the 2026 Southern Hemisphere seasonal influenza vaccine formula and modernization of certain aspects of the chemistry, manufacturing, and control, or CMC, of allergenic products. Next slide, please. For topic 1, we propose a single voting question. I'm sorry, that is... Sorry, yes, thank you. Okay, so we asked VRBPAC to consider 2 topics today. Topic 1 focuses on the selection for the 2026 Southern Hemisphere seasonal influenza vaccines, and topic 2 comprises a proposed comprehensive modernization strategy for allergenic extract standardization that is really meant to fill a 25-year technology gap in our current regulation of these products. Next slide, please. So for topic 1, Dr. Jerry Weir will provide an overview of seasonal influenza vaccine strain selection process for the Southern Hemisphere influenza season. And Dr. Rebecca Condor will present the global seasonal influenza virus surveillance and characterization that really underpin the recommended strain selections for the 2026 Southern Hemisphere influenza season. The committee will then be asked to discuss those findings and recommendations, and that discussion will be followed by a vote on the specific strain recommendations for trivalent formulations, which are shown on the next slide. So for topic 1, we propose a single voting question this time for the composition of egg-based only trivalent 2026 Southern Hemisphere influenza vaccines, noting that the recommendation is to update the 2 influenza A subtypes, but not the influenza B type compared with last year's Southern Hemisphere formula. Next slide, please. Topic 2 addresses our proposal to modernize our allergenic standardization program based on the extraordinary advancements in science and technology over the last 25 years, particularly in allergenic protein characterization and associated analytical technologies. Next slide, please. As described in detail in the briefing document, we propose 4 initiatives. The first 2 initiatives focus on those allergenic products that have a major specific allergen in the extract. Proposed initiative 1 focuses on updating major allergen potency standardization for cat dander and pelt extracts, as well as short ragweed pollen extracts, while proposed initiative 2 focuses on expanding that major allergen extract standardization approach to food allergens and additional environmental allergens. The last 2 initiatives are focused on allergenics comprised of complex extracts with multiple major allergens. Proposed initiative 3 focuses on characterizing complex extracts using modern liquid chromatography and tandem mass spec technologies. And proposed initiative 4 uses that LC-MS technology to optimize the source material for house dust mite extracts. Next slide, please. So when proposing topic 2, we were asked by some why this allergenic topic is being discussed at a VRBPAC meeting. And as many of you know, there was a parallel advisory committee referred to as APAC that served for 40 years as the place to take allergenic product discussions. Given the frequency of APAC meetings, the last of which occurred almost 4 years ago, it was decided in the most recent rechartering of VRBPAC that the scope of VRBPAC would be expanded to incorporate allergenic products. So to support today's allergen standardization discussion, we have 4 temporary voting members joining today's meeting. These temporary voting members bring specialized expertise in allergy, immunology, and allergen extract development, and their participation ensures the necessary scientific expertise is brought to bear on topic 2 today. So let me take this opportunity to thank our 4 topic 2 temporary voting members for joining VRBPAC for topic 2 today. Next slide. So the agenda for topic 2, so after our VRBPAC chair calls the meeting to order after a 30-minute lunch break, we will have 2 presentations by FDA. The first by Dr. Ron Rabin, who will encompass the first 2 proposed initiatives on updating major allergen potency standardization, replacing the mid-20th century radial immunodiffusion technology with 21st century ELISA and aptamer-based enzymatic assays. The second presentation by Drs. Ron Rabin and Brad Strader will cover the other 2 proposed initiatives that focus on the use of liquid chromatography tandem mass spec to measure potencies in complex extracts with multiple major allergens and its application to optimizing the source material for house dust mite extracts. We will then turn to 2 external speakers. The first by Dr. Thomas Platts-Mills, who will present on approaches to allergen standardization related to dust mites, followed by Ms. Trina Repp, who will provide an industry perspective. We will then ask the committee to discuss topic 2 recommendations and then vote on the 4 questions shown on the next slide. Again, the first 2 voting questions focus on those allergenic products that have a major specific allergen in the extract, with question 1 focused on moving away from that mid-20th century technology for mass concentration measurements of cat hair and pelt and short ragweed pollen extracts. Question 2 expands on that template for mass concentrations of major allergens to include food and environmental major allergens. While voting questions 3 and 4 focus on the last 2 proposed initiatives directed at those allergenic products that are complex extracts with multiple major allergens and the use of that liquid chromatography coupled with tandem mass spec. Next slide, please. So that concludes the introduction to today's convening of VRBPAC. Let me thank you for your attention, and I will turn the meeting back to you, Chair Dr. El-Sali.
Yeah, thank you, Dr. Kaslow. I'd like to invite the committee members, should they have a question, to use the raise hand function. If they have any questions. Okay.
That was clear.
There are no questions. Thank you, Dr. Kaslow.
Okay, thank you. Thanks again.
Next on the agenda is Dr. Weir. Dr. Jerry Weir is the director at the Division of Viral Products, Office of Vaccine Research and Review, CBER FDA. Dr. Weir will give the introduction to seasonal influenza vaccine strain selection, Southern Hemisphere 2026. Dr. Weir?
Thank you and good morning. As Dr. El-Sali said, I'm going to give an introduction. It's going to be brief, have just a little bit of background before we get into the topic. You can go to the next slide. Okay, so what's the purpose of today's VRBPAC committee discussion? It is to make recommendations for the strains of influenza A, H1N1 and H3N2, and influenza B viruses to be included in the 2026 Southern Hemisphere formula of influenza vaccines licensed in the United States. We meet about this time every year in October to do this for the following Southern Hemisphere. And the reason is because since 2016, there are 2 U.S. vaccine manufacturers who have been approved to produce Southern Hemisphere formulations of their influenza vaccines. These are Sanofi Fluzone and Seqirus Aflurio, the trade names. Notably, both of these vaccines are produced in eggs, and that's why we will focus in our discussion and voting question only on the egg formula for these vaccines. Now, the strain recommendation, as I said, we do this every year. The strain recommendation and supplement approval for Southern Hemisphere formulations follow the Northern Hemisphere process, which we do in the spring every year. And it uses multiple types and sources of data, including recent influenza virus surveillance and epidemiology data, genetic and antigenic characteristics of recent virus isolates, the serological responses to current vaccines, and of course, the availability of candidate vaccine strains and reagents. The next 2 slides, I'm going to give you just a little bit of background of where we've been recently. Next slide. Okay, so in March, in fact, in March 13th of this year, we made a recommendation for the Northern Hemisphere vaccine formulation. This is, of course, the vaccine that is now on the market and out for use in the Northern Hemisphere and in the U.S. But in March, the FDA recommended only trivalent formulations for the 2025-26 influenza virus vaccines in the U.S., and the following strain compositions were recommended. For the influenza A H1N1, an A Victoria 4897 2022 H1N1 PDM09-like virus was recommended for egg-based vaccines. An A Wisconsin 67 2022 H1N1 PDM09-like virus was recommended for cell or recombinant-based vaccines. For the influenza A H3N2 component, an A Croatia 10136RV 2023 H3N2-like virus was recommended for egg-based vaccines, and an A District of Columbia 27 2023 H3N2-like virus was recommended for cell recombinant-based vaccines. For the influenza B component of the vaccines, a B Austria 1359417 2021-like virus, which is from the B Victoria lineage, was recommended. And this recommendation has actually not changed in a couple of years now. Okay, so if you go to the next slide, you see what's happened more recently. This is the most recent global recommendations for the Southern Hemisphere influenza vaccines for 2026. In other words, next summer, our summer, next Southern Hemisphere winter. There was a WHO recommendation made at the end of September, 9/26/2025. At this meeting, both CDC and FDA participated. And the upshot of that meeting was that they recommended that trivalent egg-based vaccines for use in the Southern Hemisphere contain an A Missouri 11 2025 H1N1 PDM09-like virus, an A Singapore GP20238 2024 H3N2-like virus, and again a B Austria 1359417 2021 B Victoria lineage virus. And as I said, since the only 2 licensed U.S. manufacturers for Southern Hemisphere formulations are egg-based, that is what we will start our discussion on and vote. And as Dr. Kaslow already said, the question will reflect this recommendation. Next slide. So the committee will discuss, and then this will be the voting question. Again, it's the same composition I read in the last one, but we will be asking the committee for the composition of egg-based trivalent 2026 Southern Hemisphere formulations of influenza vaccines. Does the committee recommend the following? An A Missouri 11 2025 H1N1 PDM09-like virus, an A Singapore GP20238 2024 H3N2-like virus, and a B Austria 1359417 2021 B Victoria lineage-like virus. So that's the introduction. You'll hear much more detail from Dr. Condor about where we got, how everyone got to this point, but I'm happy to take any questions if any are needed. Over.
Thank you, Dr. Weir. Please use the raise hand function if you have a question to Dr. Weir. Well, I have more of a clarifying question, or more of a curiosity, really. You indicated that for the Southern Hemisphere, we will be looking at the egg-based vaccines for production because 2 manufacturers in the US are suppliers to the Southern Hemisphere. I don't see that recombinant vaccine is on the, is being distributed to the Southern Hemisphere, although the manufacturer Sanofi, is the supplier there. And we are seeing now data, whether it's from the randomized trial last year in the 50 to 64-year-old and some data in older individuals that it may be a bit more efficacious. Is it a regulatory issue that it's not going to the Southern Hemisphere, or?
No, it's not a regulatory issue. I mean, we only deal with the companies that come in and ask to license a Southern Hemisphere formula. Others could do it. It's just their choice. And then we evaluate the data, make sure that they are capable of doing it, and make sure that we take the steps so that one doesn't confuse Southern Hemisphere formulation and Northern Hemisphere. So no, this is really on the manufacturers to decide what they want to do as far as U.S. licensure, what they want to pursue.
Got it. Thank you. I do not see any raised hand in the chat.
Dr. Portnoy has his hands up on my screen.
Okay, let me see. Why am I not seeing it? Oh, here we are. Yes, I'm sorry. I was on the wrong. Yes, Dr. Portnoy. Sorry for that.
Yeah. Good morning. Yeah. Last year there were actually a quadrivalent vaccine also with the B Yamagata, and I remember the committee discussed removing that because the Yamagata vaccine was extinct. I was just wondering, how did that discussion go, and what led to the conclusion that we should no longer develop a quadrivalent vaccine?
Well, you probably remember, since you were part of some of this, this committee discussed for a period of a couple of years and recommended that the U.S. not include a fourth component, which was B Yamagata, and that's what we've been doing for the U.S. now for at least 2 years. Dr. Condor can tell you what went on at the discussion at the WHO, but I did notice that they no longer recommended that fourth strain there either. So I think that it's finally just gradually made the point that it just really doesn't exist any longer, and manufacturers everywhere have started taking it out, not just in the U.S. But she can elaborate on that when she speaks.
You finally concluded that it really is extinct.
Well, it hasn't been detected now for, I think we're up to 4 years or so, but yes, it's been a while now.
That's pretty good. Okay, thank you.
Sure.
No other questions. Thank you so much, Dr. Weir.
Thank you.
I'd like to introduce now Dr. Rebecca Condor. Dr. Rebecca Condor is the Interim Director, WHO Collaborating Center for Surveillance, Epidemiology, and Control of Influenza, Lead Genomic Analysis Team, Virology Surveillance and Diagnosis Branch, VSDB, Influenza Division, National Center for Immunizations and Respiratory Diseases at the CDC. Dr. Condor will give an discussion of the global seasonal influenza virus surveillance and characterization. Dr. Condor.
Good morning. Thank you very much for that nice introduction. And thank you to the FDA for inviting me to present on this topic to the VRBPAC committee. As the chairperson said, I will be discussing the global influenza surveillance and characterization that was deliberated to come up with the 2026 Southern Hemisphere vaccine recommendation for the vaccine virus. And so we'll go to the next slide. So the global recommendations occurred in September, as Dr. Weir mentioned, and this was held in Sapporo, Japan, hosted by the Japan Institute for Health Security and chaired by Dr. Hideki Hasegawa at the National Institute of Infectious Diseases. And in that recommendation for the 2026 Southern Hemisphere influenza season, the trivalent egg-based vaccines included recommendations for an A Missouri 11, 2025 H1N1 PDM09-like virus, an A Singapore GP 2023-8 2024 H3N2-like virus, and a B Austria 1359417 2021 B Victoria-like lineage virus. And as mentioned, recommendations for the global recommendations also included trivalent recommendations for cell, recombinant, or nucleic acid-based vaccines. And those include an A Missouri 11 2025-like, H1N1 PDM09-like, and A Sydney 1359 2024 for H3N2, and continues to have B Austria 1359417 2021 for the B Victoria lineage. Now, as mentioned, there were updates for the H1 and the H3 component compared to the 2025 Southern Hemisphere and the current 2025-2026 Northern Hemisphere vaccine viruses. And we'll be able just to give a highlight of the information that was presented that led to these recommendations. So bear with me that I won't have time to present all of the data. Next slide, please. So for more detailed information, I've listed links to the publications from the vaccine composition meeting, as well as additional information. And what I won't be able to talk about was the presented and discussed during the consultation was the summary and antigenic characteristics of zoonotic influenza A viruses and development of candidate vaccine viruses for pandemic preparedness. Now, there was a lot of the data presented, and however, no new development of candidate vaccine viruses was recommended. And as that the current viruses in development or candidate vaccine viruses in development seemed appropriate for the information available. Also included are links to the available candidate vaccine viruses and reagents for both the seasonal and the zoonotic influenza virus vaccines. Okay, next slide, please. This shows a global circulation of influenza viruses detected through the Global Influenza Surveillance and Response System since 2022, including both Northern Hemisphere and Southern Hemisphere activities. And the colors represent the influenza A in the shades of teal, and then subtyped into either H1N1 PDM09 in the lighter teal and H3N2 in the darker teal. And then also detections of influenza B viruses in a dark orange and a brighter orange for B Victoria and a light orange for B Yamagata. What you'll see is the absence of a light orange B Yamagata lineage because through the GISRIS network, we have not detected influenza B Yamagata lineage wild type viruses in circulation after March of 2020. So looking at the 2025 to 2026 seasons that we'll be discussing here, we can see that the square in red highlights the data available in this reporting period since February 1st, 2025 through the end of August 2025. In GISRIS, we can see a predominance of influenza A detected during this time period in both the Northern and Southern Hemisphere. However, when we look at the type and subtype, we saw a predominance of influenza H1N1 PDM09, but co-circulation in some regions of H3N2. And I'll get into a little bit more details where there might have been some regional differences. In terms of influenza B Victoria, we can see co-circulation during the Northern Hemisphere and small numbers of co-circulation during the Southern Hemisphere season. Next slide, please. This map shows the influenza activity and the global distribution of type and subtype. And I will get into more details of the specific detection of type and subtype in each section. And then again, encompasses the information from February 1st, 2025 through the end of August 2025. Here we can see influenza percent positivity filled in yellow. And we can see that many areas globally saw influenza activity. And then looking at the pie charts, you can see a distribution of influenza A subtypes and B detections during this time period. We'll kind of focus on the Southern Hemisphere countries and regions, and we'll first start off with South America. And in South America, you can see influenza positivity mainly in the southern part. And this, again, was dominated by influenza A, H1N1, PDM09. And looking at parts of Africa, in West and East Africa, it was predominantly H1N1, PDM09. However, in the southern part of Africa, you can see an H3N2 predominant epidemic. In parts of Asia, we had a mixture of influenza A and B co-circulating. And when looking at the influenza A, in some parts of Asia, H3N2 was more likely predominating. However, in other parts, H1N1 PDM09 was predominantly detected. In Oceania, especially in Australia, the influenza season was predominated by influenza A, H1N1, PDM09, with very small levels of H3N2, but co-circulation in some areas of influenza B, Victoria. Okay, next slide, please. Now I'll give a brief update on the virus characterization of H1N1s leading to the update in the vaccine recommendation. Next slide, please. This map shows the influenza H1N1 detection levels globally since February, and highlighting what I previously showed, that in South America, it was predominantly in H1N1 PDM09 activity. In parts of Africa, especially West Africa, and in parts of East Africa, H1N1 predominated. And then also in parts of East Asia, especially in China, H1N1 in this time period predominated, and as well as parts of Oceania, especially in Australia and New Zealand. Next slide, please. This is a large phylogenetic tree of the H1N1 PDM09 hemagglutinin gene and looks at data encompassing years the end of 2023 through the end of August in 2025. And what we can show on the large phylogenetic tree on the left is the genetic diversity. And on the right shows the location of the virus sequence and color-coded with the map on the left. So those from North America will be in dark blue, South America in teal, Africa in orange, Europe in green, Russia in maroon, Middle East in purple, and East and Southeast Asia in red, and Oceania in pink. And this is the same color that I'll be using in the other types and subtypes. And this can show us our regional differences in the viruses that were detected each season and trends in changing of the viral clade dynamics and geographic locations. So when we look at the phylogenetic tree for H1N1s, since the end of 2023, viruses have belonged to our 5A2A clade in the hemagglutinin. And for the last couple of seasons, the virus recommended for the vaccine has belonged to the 5A2A1 subclade, and that is the A Wisconsin 67 2022-like or the A Victoria 4897 2022-like vaccine virus. And what we've seen since those recommendations is co-circulation of hemagglutinins that belong to either a 5A2A subclade. Those include those at the bottom of the tree, labeled in the newer updated subclade nomenclature of either C.1.8 or C.1.9, or viruses belonging to the 5A2A1 clade and its subclades labeled in D, and that's D1 through 5. So what we can see at the very change in the 24 to 25 season is that we had co-circulation of both 5A2A and 5A2A1 globally, but we had regional differences in that outside of the Americas, it was predominantly a 5A2A viruses that circulated. However, since the beginning of 2025, you can see the number of tick marks under the 5A2A C.1.9.3 subclade have disappeared. And instead, the viruses circulating since February of 2025 have been predominantly from the 5A2A1 D.3, or now more commonly called the D.3.1 subclade. So we've seen a replacement of viruses from the 5A2A with the 5A2A1 D.3.1 subclade. Next slide, please. We can look at this in another geographic view, looking at the diversity plot over time by geographic region. And again, splitting up the hemagglutinin of the viruses sequenced by the different clade and subclade nomenclature I just mentioned. And what you can see for all regions where there's sequence data available for this time period, we can see the emergence and the eventual overtake of viruses from the 5A2A1 D.3.1 subclade. Okay, next slide, please. Another visualization shows that change in viral clade dynamics by location, where the Americas on the left continued to have co-circulation of both 5A2A and 5A2A1, whereas globally in the eastern part of the globe, 5A2A viruses predominated, and that was before January 2025. And then the next slide. Again, repeating in places with detections of influenza H1N1 PDM09 since February, the predominance of this 5A2A1 D.3.1 subclade. Okay, next slide, please. This summarizes the antigenic analysis of H1N1 PDM09 viruses in hemagglutinin inhibition assays. And in this assays, we use a naive ferret post-infection model. And these ferrets are infected with the egg or cell-grown vaccine reference viruses and this is for the 2025 Southern Hemisphere vaccine viruses. And as mentioned previously, the cell-based was the A Wisconsin 67 2022-like from 5A2A1, and the egg-based was A Victoria 4897 2022-like. Now, looking across the GISRIS collaborating centers, we can see that the vast majority of sera in this assay to the vaccine viruses recognized the viruses tested quite well. Again, using that post-infection ferret antisera in a naive ferret antisera model. This tells us that there are antibodies to the vaccine that will recognize the circulating virus as well. Next slide, please. This shows an integrated genotype and phenotype analysis created by CDC, showing the results of our ferret antisera HI against the circulating diversity. And so we can see the phylogenetic tree. In this case, we have the 5A2A1 viruses at the top section of the tree, and you can see the D.3.1 in the purple bar representing a good majority of the viruses tested and sequenced during this time period. And at the bottom, you can see viruses from the 5A2A subclade represented by mainly the C.1.9.3 subclade. When we look at the results of our ferret antisera, we can see good recognition of all viruses with this ferret antisera. And the very small number had particular substitutions that we've seen previously in the ferret model to show reductions. So mainly in site SA or SB. Okay, let's go to the next slide, please. What I wanted to show is an additional analysis that's run in our hemagglutinin inhibition. Previously, we just reported against the vaccine viruses, but in our analysis, we include reference viruses that represent the other circulating viruses, clades, and in this case, viruses from C.1.9, C.1.9.3, and then additional 5A2A1 viruses from the D.3.1 subclade represented here in the HI assay with ferret antisera raised to the cell-grown A Missouri 11 2025, in addition to the vaccine viruses previously mentioned. And the trend in many of the collaborating centers has been that although the ferret antisera raised to the vaccine viruses recognized many of the circulating viruses from both 5A2A and 5A2A1 subclades well, we're starting to see antigenic drift with our reference viruses from the 5A2A subclades against the D.3.1 viruses. Also, in the ferret model, we're also seeing good recognition of both 5A2A and 5A2A1 viruses when the ferret anasera is raised against the D.3.1 reference virus. Now, another way that we can look at our antigenic information is looking at antigenic cartography. I'm actually going to go to the next slide and probably advance one more. And now we'll have some labels. In this slide, we're looking at results across multiple HI assays performed here at CDC against the H1N1 viruses. And the circles represent the test viruses, and they're colored by which hemagglutinin subclade they belong to. We can see in a light teal, there is our viruses from the 5A2A, C.1.9, and they cluster quite well together and are very similar to the virus representing the vaccine candidate, Victoria 4897 and Wisconsin 67. Those are kind of right in the middle on top of those teal viruses. Viruses from 5A2A1, either the D or the D.3.1 subclade, are shown in purple and a darker, brighter teal. These you can see are above the 5A2A C.1.9 viruses. And so what we're seeing is not right on top of each other, again, showing antigenic drift between the 5A2A subclades and the 5A2A1 viruses, which circulated. And this is also showing how well our ferret anasera to Missouri 11, the D.3.1 reference virus, recognizes, and you can see that in the serum circle, any viruses that are recognized within 8-fold of the homologous titer of Missouri 11 are within that serum circle. And we just have a few viruses outside of that serum circle, and many of those have that additional substitution I mentioned in the position 155. Again, very small numbers of those and not consistently circulating. Okay, next slide, please. So another layer that we look at in our serologic analysis of antigenic results for H1N1s is looking at human post-vaccination sera. In this case, we have different panels of Southern Hemisphere vaccine viruses. We have 3 panels from Australia, which include cell-based, egg-based, and for the elderly, an egg-adjuvanted vaccine. And then from Peru and South Africa, we have an egg-based trivalent vaccine. When we look at these studies, the majority of our panels are selected from our sera that's tested is selected from individuals who have an appropriate immune response post-vaccination. So have that 4-fold rise in titer and a titer greater than 40, meeting the correlate of protection. So we're really assessing individuals that respond very well to the vaccine, whether or not the antibodies post-vaccination recognizes the circulating diversity that we have across the H1N1 virus. And in this assay, we do see good recognition of many of the different viruses. We are seeing reductions across some of the genetic diversity in the 5A2A1 and the 5A2A viruses that circulated. Next slide, please. Another thing that we looked at is vaccine effectiveness. And this is trying to understand whether or not there's a difference in vaccine effectiveness against the different viruses that co-circulated from the 5A2A and the 5A2A1 subclades. And we can look at the different colors. Those in blue recommend the estimated vaccine effectiveness for individuals against the D.3 subclades. And then that in red against the 5A2A C.1.9 subclades. In some estimates in different regions, we can see pretty similar vaccine effectiveness estimates. However, in other panels, especially those shown at the top from Australia and Europe, we can see that there's been a little bit trend to lower vaccine effectiveness against the D.3 subclades. And we also looked at and had an ability to look at individuals from our vaccine network that were breakthrough infections or those that were not vaccinated, and looking to see which viruses they were infected with. In this case, we had an opportunity to look at individuals that were infected with the D.3.1 viruses, and we're looking at their acute and convalescent sera. And in this assay, we were able to see that the majority of individuals had very low sera and antibodies recognizing either the vaccine viruses or the D.3.1 virus that they were eventually infected with in their acute sera. However, individuals in their convalescent sera had strong, robust immune responses to the virus that they were infected with, the D.3.1. And this convalescent sera well recognized the test viruses that we included in the assay from both the 5A2A and the 5A2A1 emerging viruses. So individuals that were infected with the D.3.1 virus showed good recognition of our circulating diversity. Next slide, please. So another summary that we do during this time is looking at antiviral susceptibility. The two classes that we looked at are neuraminidase inhibitors and endonuclease inhibitors. Nearly 4,000 H1N1 viruses were examined, and 96 showed evidence of reduced susceptibility to neuraminidase inhibitors. Many of these had an H275Y NA substitution. 2 had a Q136K, and you can see the remaining 6 had a mixture of different substitutions. In endonuclease inhibitors, we did not see very many that had substitutions. However, there were 3 that had an E199G substitution in the polymerase PA gene, and 1 had an I38T substitution. Next slide, please. So in summary, an important noted for H1N1s is that they circulated globally and predominated in most regions. We also saw that while initially in previous seasons, we saw this co-circulation of subclades from 5A2A and 5A2A1. During this time period, viruses from subclade D.3.1 have largely displaced all of the 5A2A viruses in circulation. Next slide, please. For antigenic characterization, while post-infection Fair antisera to our representative vaccine viruses recognized 5A2A and 5A2A1, Fair antisera from 5A2A1, the D.3.1 reference virus, also recognized recently circulating viruses from the 5A2A and 5A2A1 clades. We are starting to see a different recognition for post-infection Fair antisera raised against the subclades of C.1.9.3 and C.1.9. Next slide. Our human serology studies conducted from the Southern Hemisphere 2025 showed that in vaccinated human serum panels by HI assay against the recent viruses from the C.1.9, C.1.9.3, and the 5A2A subclades D.3 and D.3.1, we did see some significant reduction in circulating viruses across the genetic diversity that I just mentioned. The data supported recommending an update to the H1N1 to the A Missouri 11 2025 H1N1 PDM09-like D.3.1 virus as a vaccine antigen for the 2026 Southern Hemisphere. And again, most of this is showing that viral clade dynamics and recommending that A Missouri is a more appropriate vaccine antigen for the future diversity that we expect to come out of the D.3.1 viruses. Next slide, please. Now we'll shift on to the H3N2 virus characterization summaries. Next slide. H3N2 activity from February till the end of August. You can see in this case, we still had indetections in the Northern Hemisphere earlier in this time period. Parts of South America saw co-circulation, although H1N1 predominant. And then in Africa, I already mentioned the differences in influenza A detected with parts of the southern part of Africa having predominant H3N2 viruses. And then also seeing continued co-circulation, and in parts of South Asia and South and Southeast Asia, detection and co-circulation of H3N2. Next slide, please. So the phylogenetic diversity of the H3N2 hemagglutinin gene, again, showing the same time frame, so the end of 2023 until the end of August of 2025. All of the viruses that circulated, nearly all, belong to our clade 2A3A1 that we've seen for the last couple of years. And we've, again, subdivided them into new subclades. In this case, we can look at J.1 and J.2. The vast majority of viruses that circulated since February belong to the J.2 subclades. And we did see some significant emerging subclades within this group. Specifically, we'll call out J.2.1, J.2.2, J2.3, J2.4, and J2.5. And again, we can see the collection region by the color of the tick mark. And we can see during this time period, co-circulation of many of these emerging groups, but we are seeing some regional differences in the new subclades that are emerging. And I'll show that better on the next slide, please. Okay, so this is looking at the geographic regions, looking more at the J.2 subclades which circulated. And we can see one trend in nearly all of the regions, and that is the bright teal of J.2.4 emerging, and it was mainly H1N1, PDM09 predominant. But we can see emergence and co-circulation of many J.2 subclades, including J.2.3 and J.2.4 in more recent months. In South America, a little bit different trend in that not a lot of J.2 viruses have been detected, and instead it's been co-circulation of both J.2 and J.2.3 viruses. Next slide, please. So this is again showing the change in clade dynamics from September to January, showing a lot of J.2 in this dark blue and just small amounts of lighter J.2.2 and that bright teal of J.2.4 seen mainly in parts of South Asia. And then if we switch to our February till now, next slide, please. Here's where we can see the expansion of countries that have detected viruses in the J.2.4. You can see parts of North America, Europe, Africa, and more parts of South and Southeast Asia, and parts of Oceania. And then in that orange J.2.3, you can see detections in North America, South America, and just a few other regions. So we are seeing co-circulation of viruses in different genetically diverse subclades. And as we'll talk about whether or not these particular subclades have antigenic differences, we can see interesting clade dynamics in the expansion of J.2.4 in nearly all regions. Next slide. When we look at our antigenic analysis from this time period, again, we're using our post-infection naive ferret antisera in HI assays in this result. And again, the infections were either with the District of Columbia 2023-like cell-grown virus or the Croatia 10136RB 2023-like egg-grown virus. And we can see in these trends, small proportions of viruses in the HI, around 7%, with ferret antisera raised to the DC cell-based, and a larger proportions of reductions when we compare that to the homologous titer of the egg-based vaccines, over 41%, showing greater than 8-fold reduction in titer. We look at these same sets of viruses in another assay looking at virus neutralization on the next slide. we can see a similar proportion of reductions in the viruses tested, around 7% for DC27, and for the egg-based, we can see 24% reduction. So we can, in the majority of the viruses that circulated, we saw good recognition with our ferret antisera. However, we are starting to see antigenic drift. And if we go to the next slide, again, this integrated genotype and phenotype analysis is asking, well, are there molecular determinants for this antigenic drift? Are there specific substitutions in the hemagglutinin molecule that we can identify with the reductions seen in our post-infection ferret antisera? For this, you'll see that we have a lot of different subclades marked by the different colors in the bar. We can see for J.2 viruses, the majority of viruses with our ferret antisera raised to DC27, either in the HI or the virus neutralization assay, show good recognition of the J.2 viruses. We also saw good recognition of the J.2.2 viruses, and these viruses were the predominant HA subclade which circulated in parts of South Africa that I mentioned had a pretty strong H3N2 epidemic this season. The subclades where we saw more significant reductions include the subclades of J.2.3, J.2.4, and J.2.5. These subclades were emerging during the beginning of the year. And as I've shown previously, we can see some clade dynamics in terms of how they are increasing in their detections in different regions. The next slide, I'll try to explain some of the changes which could be responsible for this antigenic drift detection with our ferret antisera. So if we look at a hemagglutinin monomer and look at where the substitutions are in these new emerging subclades, our District of Columbia 27 is a J.2. And if we look at changes in the J.2.3 and the J.2.5 viruses, here we can see they share changes at positions 158, which is at the very top of the molecule and a major antigenic binding site. J.2.3 viruses also share an additional change at position 189. So these viruses have similar changes, but a little bit different, but sharing that 158K substitution. If we now look at the J.2.4 viruses, these viruses share a change at position 135. And in the 135, this is in antigenic site A and near the receptor binding pocket. And these change at 135 actually leads to a loss of a glycosylation site in this particular part of the molecule. And what I can also show here is that K189R substitution, which is an antigenic site B, we can see that that is also present in these J.2.4 viruses. So we see two different antigenic binding sites showing mutations compared to the DC27 in the J.2.4 viruses. And more recently, within the J.2.4, there's always emergence of evolution. But a particular note, we've seen additional substitutions, actually quite high number of substitutions and that are also within important antibody binding sites. These include substitutions I've labeled here, the J.2.4 plus 7. So in addition to the 135K substitution and the 189 and in the base of the J.2.4 viruses, these viruses in particular have additional substitutions at both 158 and 160 in site B, and an additional substitution at position 144, which could add back a butyroglycosylation site. And then also a substitution shown in at position 173, in addition to other changes not in antigenic binding sites. So quite a significant number of mutations in these particular viruses. And again, really leading edge in terms of detecting them in more recent collection dates. So this is explaining some of the changes on the surface of the hemagglutinin in these emerging groups where we've seen reductions in our DC27 ferret antisera model. So again, positions 158 in conjunction with 189, positions 135 in conjunction with 189, or these further evolved with additional substitutions at 158, 160, and 144. So next slide, please. When we look at our antigenic cartography of where the placement of these viruses are in our antigenic cartography space, what is interesting to note is that these different subclades of J2.4 and J2.5 and J2.3 are not antigenically related. They're actually quite antigenically distinct from each other. This is a common problem with H3N2 viruses where we have co-circulation of antigenically distinct subclades. And so a common problem that needs to always be addressed. In this case, we can see viruses from the J.2.3 and the J.2.5 subclade in green and orange co-localized together and in the bottom right of the antigenic maps, or in the right on the one from Melbourne. We can see viruses from the J.2.4 in light blue, or those with additional substitutions in a very light aqua right above them. So again, we're seeing antigenically distinct subclades, and we're seeing even further antigenic drift in viruses from that recently emerging J.2.4 subclade. Next slide, please. When trying to find an optimal vaccine antigen that would recognize all of the genetic diversity that we've observed emerging and with the different clade dynamics, it's been extremely difficult to find a single virus that would recognize all of the diversity well. And although the virus, the information that we have from fair antisera and vaccine effectiveness to the DC27 and the Croatia-like do a fairly good job of recognizing the J.2 viruses, we are starting to see those significant reductions in the J.2.3, the 2.5, and the J.2.4 viruses. And because of the differences that these viruses have between each other, they don't recognize each other at all. So the J.2.4 is distinct from the J.2.3. And making fair antisera to reference viruses from these particular subclades shows that we don't have good recognition, cross-recognition. When we're looking at an appropriate vaccine viruses to the emerging and likely to predominate J.2.4 viruses, we see good recognition using fair antisera raised to the reference viruses for the Sydney 1359 in the cell-based, or the Singapore GP 2238 2024 egg-based virus, shown in the circle around the north on the right antigenic cartography there. And that includes viruses with those additional substitutions I mentioned at positions 158, 160, and 173, and 144 in the J.2.4 viruses. Next slide, please. So this gives an overview of the human post-vaccination serum analysis from the panels I mentioned in the H1N1. And here we are seeing reductions in our post-vaccination human sera panels to many of the J.2 further evolved subclades that I mentioned in terms of J.2.1, J.2.2, J.2.3, J.2.4, and some in the J.2.5. And so we are seeing significant reductions to many of those important emerging subclades. Next slide, please. Summary for the antiviral susceptibility for H3N2. Of the 1,716 H3N2 viruses examined, no viruses showed genetic or phenotypic evidence of reduced inhibition to neuraminidase inhibitors. Similarly, no viruses showed reduced susceptibility to endonuclease inhibitors as well. Next slide. To recap the always difficult to give a short summary on the dynamics of the hemagglutinin diversity, we can see that although all of the viruses belong to this 2A3A1 subclade, we have further diversification and noted that the J.2 was predominant, but there are emerging viruses in the J.2.1 to J.2.5. And the substitutions in these emerging viruses are showing antigenic drift, not only from the current vaccine virus, but also between each other quite significantly. And then importantly to note that the J.2. Viruses are continuing to circulate in many geographic regions, and of note that emerging and recently expanding group within that. And not to forget the J.2. Viruses, which were detected in higher proportions in South America. So still a complex situation of the viruses for the H3N2 diversity. Next slide. So antigenic characterizations, and in summary, although the ferret antisera model recognized from the DC27 or the Croatia 10136RB, while they recognize most viruses well, viruses in the emerging subclades, particularly J.2.3, J.2.4, and J.2.5 were recognized poorly. When trying to find a vaccine virus which could recognize all diversity, that was not possible. But we did see trends that if some of the substitutions were shared, for example, between the J.2.3 and the J.2.5, they share an N158K. We did see cross-recognition with that ferret antisera. However, poor recognition of viruses with the J.2.4. And then when looking at the J.2.4, we saw good recognition with our reference viruses Sydney 1359 and Singapore GP 2238 to the J.2.4s, including those with those notable amino acid substitutions that have recently emerged. However, recognition of other viruses from the J.2 subclades poorly. Next slide. Our human serology studies, again, we looked at a lot of viruses across that J.2 diversity. And when compared to titers against the cell-propagated District of Columbia 27, 2023-like vaccine reference viruses, post-vaccination HI-GMTs or virus neutralization GMTs against many of the recent viruses, particularly of note, the J.2, 2.3, 2.4, and 2.5 subclades were significantly reduced. So this in part is the data that supported recommending a cell-propagated Sydney 1359 2024-like, a J.2.4 virus, or cell-based, and an egg-propagated Singapore GP 20238 2024-like as the H3N2 vaccine antigens for the 2026 Southern Hemisphere. Next slide, please. Now we'll transition into the influenza B viruses. Next slide. So influenza B activity, we'll see that this is since February. And so parts of the Northern Hemisphere saw higher detections of influenza B viruses during this period in Europe and parts of Asia, and also parts of West and South Asia. However, the majority of countries reporting in the Southern Hemisphere saw low levels of influenza B activity and much higher levels of influenza A. Next slide, please. Influenza B Yamagata. Next slide, please. So, and as I mentioned earlier, there have been no confirmed detections of circulating B Yamagata 1688-like lineage viruses since March 2020. It continues to be recommended that the B Yamagata lineage antigen should be excluded from influenza vaccines because it's no longer warranted. And at this point, the WHO committee is no longer going to have updated recommendations for the B Yamagata lineage component. So all evidence that we have in our global influenza surveillance and response systems have not detected influenza B Yamagata lineages now for over 5 years. Next slide, please. So now we'll talk more about the characteristics of the B Victoria lineage viruses which circulated. Next slide. So the phylogenetic tree of the HA for the B Victoria lineage viruses since the end of 2023 shows the majority of viruses belong to this B Victoria 3A.2 subclade. Remember, this is a 3 amino acid deletion compared to viruses which previously circulated. And the B Austria 1359417 has been the recommended B Victoria lineage vaccine antigen since the Southern Hemisphere 2022. When we again break up the hemagglutinin into new subclades, in this case C.1 through C.5, we can see over this time period co-circulation and different regional detections of different subclades of the C.1 through C.5. And we're going to note in particular the C.5 has been split out into C.5.6, 5.1 through 5.7, but more recently looking at co-circulation of C.5.1, 5.6, and 5.7, and a new emerging group in the C.5.6.1s. So the vast majority of viruses which were sequenced during this time period belong to one of these C.5 subclades, which I just mentioned. We want to note at the very top, you can see a C.3 subclade, and it's two C.3.1 and C.3.2 subclades, and you can see some dark blue detections. And this are detections of this particular subclade during the end of the Northern Hemisphere season in North America. And we'll talk more about the particular viruses later there. Next slide, please. Now looking at it again by a geographic region, there really isn't a very good summary except that the C.5.1, 5.6, 5.6.1, and C.5.7 co-circulated in all regions in different proportions. Where we did see a little bit difference is in North America with that emergence of the C.3.1 after 2025 and some increase in its circulation during this time period. So that's the kind of the notable difference for the B Victoria viruses. Next slide, please. Here we can see the detections and variability by region of which of the C.5 subclade predominated. Again, seeing regions where C.5.1 predominated, other regions where C.5.6 or its 5.6.1 subclade, and then also the co-circulation of the C.5.7. Next slide, please. Looking at the antigenic characterization results by the collaborating centers, here's where we can see that there were differences by collaborating center, and this will mainly be dependent on which viruses they had to test. We can see that overall there was good recognition in HI assays by either the cell or egg grown B Austria 1359, 417 like vaccine reference viruses. However, you can see in the CDC data a higher proportion of viruses with greater than 8-fold reduction to the homologous titer of our vaccine viruses. Next slide, please. So the genetic determinants of why we're seeing a higher proportion in the CDC data, and here we can see that the phylogenetic tree, and on the right showing the breakout of which of the C.5 subclades, or at the very bottom, the C.3 subclades, C.3.1 and C.3.2, which circulated, and our test results at CDC. We can see good recognition of C.5.1, 5.7, and C.5.6 and its subclades with our fair Anacera to P. Austria, but very poor recognition in viruses from the C.3.1 and the C.3.2 subclades. Now, looking at the hemagglutinin of these particular subclades, they independently had the same mutation at position 197 from aspartic acid to asparagine, and this adds a glycosylation site, putative glycosylation site on the hemagglutinin. And we've seen over the time for B Victoria viruses and B viruses in general, the addition and subtraction of putative glycosylation sites associated with antigenic drift. So in this case, we can see an antigenic drift detection with viruses with that additional glycosylation site added. And we saw more C.3.1 than C.3.2. Next slide, please. When we're looking at antigenic cartography, the subclades of the C.5 I've mentioned co-localize together and are well recognized by ferret Anacera to the B Austria. We can actually go to the next slide to see that serum circles. Where we're seeing outliers, again, are viruses with that C.3.1 or C.3.2 with that glycosylation change. These shown in the darker blue outside of the serum circles here. Next slide, please. Our post-vaccination sera is very similar to the data that we have with post-infection ferret antisera, in that significant reductions were not seen against viruses from the C.5 subclades. Instead, significant reductions were seen against viruses from the C.3.1 subclade with that glycosylation change. However, this particular subclade, again, had very limited geographic detections, and the majority of viruses that are currently circulating belong to these C.5 subclades. Next slide. For antiviral susceptibility, over 1,500 B. Victoria viruses were analyzed, and 5 showed evidence of reduced or highly reduced inhibition by neuraminidase inhibitors. When looking at endonuclease inhibitors, no viruses showed evidence of reduced susceptibility to baloxavir. Next slide. So in summary, we have that co-circulation of genetic diversity of the clade 3A2 viruses, predominantly seeing viruses from C.5.1, 5.6, and C.5.7. And then that lower proportion of circulating and that regional detection of the C.3.1 and the C.3.2 viruses, with the notable antigenic drift being able to be detected not only with our ferret antisera, but significant reductions seeing in post-vaccination human sera profiles. Next slide, please. So again, titers were significantly reduced really only to the C.3.1 viruses in our human serology assays. And this in total is the data that supported maintaining the B Austria 135, 9417, 2021 like viruses as the B Victoria lineage of vaccine antigens for the 2026 Southern Hemisphere season. So this concludes my presentation, and I'll happy to turn it over to the chair and be able to answer any additional questions. Thank you.
Thank you, Dr. Condor and team, for this large body of data and the presentation. Please raise your hand if you have a question. And I see the first question from Dr. Durbin. Dr. Durbin.
Great. Thank you so much. That was a wonderful presentation. This may be a little bit theoretical, but given we used to have quadrivalent influenza vaccines, has there been any thought, given the divergence in the H3N2, to recommend 2 different strains for H3N2? Because that genetic map was really between the J2.3, J2.5, and J2.4 was quite significant, and I'm a little bit concerned about a mismatch.
Yes, Dr. Durbin, thank you. That has been an active area of discussions for vaccine development. Currently, the currently licensed influenza vaccines do not allow for more than one H3N2 antigen. But I know that there's been some preclinical studies to see the feasibility of more than one H3N2 antigen in newer licensed vaccines. Thank you. But I agree that's an important area of research that needs to be done.
I have a follow-up question on the H3N2 story, which is, it seems that the District of Columbia strain had better cross-reactivity with than the Croatia strain. These are both in our Northern Hemisphere vaccine this year. And the difference was both in human sera and in ferret sera. And at times, depending on what you showed, it's significant. So, any explanation or projection here regarding what we're going to see in terms of effectiveness?
I can't answer
like the 2017, 2018, when we lost that glycosylation site and we ended up with difference in between, egg-based versus non-egg-based vaccine.
Right. I think you are pointing out that the difference between the DC and the Croatia are which platform the virus is propagated in. DC is a cell-based, whereas the Croatia virus was grown in eggs and has additional mutations that allow the virus to grow in eggs. This is a common thread for influenza viruses grown in these 2 different platforms, in that mainly viruses grown in eggs need to acquire mutations in and around the receptor binding pocket to be able to grow in eggs. And often this leads to antigenic differences between when we raise Vera anacera to the egg-grown viruses and test them against the circulating viruses which we grow in cells. So, egg adaptations occur in order to allow the viruses to be manufactured in eggs. However, there always is the potential for an antigenic drift difference between viruses grown in eggs versus those that circulate.
Yeah, I agree. However, the difference is really significant this time, at least in a couple of the slides you've shown, that the recognition between these two strains, the one selected for the cell versus the one selected for the egg, seems to be significant this time. I mean, it's probably more of an issue for the Northern Hemisphere than the Southern Hemisphere, which is what we're discussing here. But anyway, Dr.
And let me just qualify a little bit on that. When I show the human serology data, we use different reference anchors for the GMTs. So on the top section of the human serology section, we use the cell-based virus as our control for our getting our effect, or the egg-based or the cell-based vaccine. And so we're seeing similar individuals that get an egg or versus a cell-based vaccine showed good titers, or the egg-based show reductions just to the significant subclades that I mentioned. When we use the egg-grown virus in our assays, it tends to have a really high homologous titer. And in that case, shows differences in recognition in the cell-based viruses used in the assay.
Thank you. Dr. Perman?
Yeah, so I had a couple questions. One is, are you getting the same number of samples, virus isolates for analysis as you have in the past? Or has it been any sort of fall off like we've seen with SARS-CoV-2? And the second thing is something we've discussed in the past is whether just looking at antibodies is really sufficient, whether we should be looking at cellular immunity too to see if that has any effect. And this might relate to differences in clinical disease that occur as these virus mutates. I don't know if there's new data on that as well.
Thank you, Dr. Perlman. Your second point I'll answer first in terms of, yes, it's an active area of interest to understand the role of the cell-mediated immunity in disease for influenza, although I don't have any data to present for this particular question. For the first question, in terms of samples that we've received, the U.S. has a robust national surveillance program for influenza, and so we have a good amount of viruses coming in from our U.S. Partners. As part of the global influenza surveillance and response system, we also at CDC receive international specimens. And there have been some changes in the numbers of specimens that we've received since February. However, we're working with our colleagues to improve that there's good recognition and availability of viruses to test throughout the network. So you'll see, changes in the numbers that by different collaborating centers on which viruses they test. But overall, there was a robust number of viruses tested during this time period.
Thank you.
Dr. Monto?
An observation and a question. Usually when we see the Southern Hemisphere strain selection, we often wish that we had the opportunity to get the H3N2 that's being recommended for the Southern Hemisphere in our current Northern Hemisphere vaccine. And for that, we're going to need new platforms and things like that, which may be sometime in coming. And my other observation, Dr. Durbin already mentioned, and that is we have been saying for a number of years, especially after we it was clear we were going from a quadrivalent to a trivalent vaccine, that we should have 2 H3N2 viruses in the vaccine as long as we could show that there wasn't interference or some other phenomenon taking place. My question, when you started showing neuraminidase, I was hoping you were going to say something about neuraminidase drift, since we do recognize that neuraminidase is a secondary correlate of protection, independent correlate of protection. Is anybody really looking at this right now with all the work and all the clade diversity that gets worse and worse every year?
So regarding the neuraminidase, when we do the genetic analysis, we are looking at all genes in influenza viruses, and we are looking at the neuraminidase, and we are tracking the clade dynamics for neuraminidase substitutions. And we are seeing that with the D.3.1 viruses for H1N1, they did tend to have a lot of reassortment and trying out a lot of diversity of the neuraminidase gene. However, we did not have additional neuraminidase antigenic information during this vaccine consultation meeting, but it is an active area that we're trying to get more consistent antigenic drift for the neuraminidase for the vaccine decision. Thank you.
And I'm happy to see that you are tracking antiviral resistance, because if we go into a mismatched year, that's going to be even more important. Thank you.
Thank you. I have a question pertaining to the B. As you indicated, for 2-3 years now, we've been going with the same strain. So between infection and vaccination, the population has sort of immunity to that particular lineage, or strain, I should say. There's a new lineage that's emerging, the C.3.1 and the C.3, which is a bit distant from the Austria. The modus operandi, as we understand it, is trying to understand what's the background, what we've been vaccinated with, and what we've been exposed to, and see what are we not covering and what seems to be on the horizon. Was there a particular rationale why not a strain closer to the C.3 or the C.3.1 was not chosen?
Yeah, and mainly that's due its limited detection outside of the Northern Hemisphere. During other parts of the year where we had more significant influenza B epidemics, those were predominated by the C.5 subclades. So it was more the proximity of where it was circulating, and not seeing it associated with significant epidemics necessarily.
Okay, so it has to do with the distribution, the geographic distribution.
Correct.
And I guess taking a bet that it's not going to be the one going to the Southern Hemisphere, which is understandable, but I wanted to point that out. Thank you. Dr. Bernstein.
Thank you. I may not be interpreting the global surveillance maps correctly, but the B lineage did seem to be more prominent in certain continents and more in the Southern Hemisphere. What drives more of the B lineage prominence over the A viruses?
Yeah, that's a great question. I don't have an answer for you on that exactly. I think it's a mixture of population immunity that's driving an introduction in that region of particular viruses. And so there's opportunities for different dynamics based on the population immunity structure there.
Thank you. And I did want to add to what Dr. Durbin and Dr. Monto said about the consideration for 2 H3N2 strains in future vaccines, perhaps. Thank you.
Thank you, Dr. Bernstein. I have a question pertaining to the VE slide. you have shown a slide with VE for the H1N1 from different continents. Do you mind pulling that one up? Maybe I just wanted to clarify that I understood it.
My apologies, I don't have control.
Oh, okay. It's in the H1N1.
Right. So that slide was
16, maybe
yeah.
slide 16. Let's try slide 16. Could be wrong, but no, it's the one probably couple before or couple after. Regardless, in Europe, it seemed that the VE was very different than anywhere else. Was it an issue of the diagnostic or the diagnostics used? Because we saw a few publications in the last month or so from Europe where it was based on ICD-10 code to ascertain the VE of flu vaccines versus the NVSN, for example, that you showed on the same slide where it is PCR confirmed. Do you think the difference in VE had to do with the diagnostics used?
I don't believe it's a diagnostics. It just depends on the study capabilities of whether or not they had sequence information available from all of their cases. And so I'd have to go back and look at that particular Europe result and see what kind of information was available for that particular study result.
Okay, thank you. You know, when it to the issue of having more than H3N2 in the vaccine, my colleagues, Dr. Monto, Dr. Durbin, and Dr. Bernstein commented on that. I know it gets complicated with the issue of the antigenic interference and negative antigenic interference based on what's been circulating before and the year of birth, et cetera, et cetera. But what has been also another low-hanging fruit is the neuraminidase. It's an independent correlate of protection. It is less, at least so far, subject to drifts and shifts, and has been demonstrated again and again in terms of its importance in infection and disease. And in my viewpoint, that is definitely a low-lying fruit where antigenic interference may not be an issue and would potentially improve VE if we have more antigenic space to occupy, I guess, with the Yamagata removal.
I mean, all of these are active questions that we are working on with our preclinical vaccine development. For the currently licensed vaccines, again, we aren't unable to recommend more than one H3N2 antigen. And then, as you mentioned, with the neuraminidase, whenever we make our vaccine recommendations, we are taking into account information available on the diversity of the neuraminidase. And in most cases, the vaccine viruses also represent an update in the neuraminidase. I mean, all of them have not just the HA from the recommended vaccine virus, but also the neuraminidase for that particular virus as well. So both are updated in the recommendations. However, we don't necessarily have a lot of information on antigenic drift for the neuraminidase during these decisions.
Thank you. Dr. Perman.
Yeah, just a follow-up on the question there. So when you look at vaccine efficacy, do you have the capability to go back and look at the viruses in the people who broke through and had an infection to see if that actually correlates with some of the drift that you're describing?
Yes, in the US VE network, we're able to have sequencing of all of the influenza positive cases and whether or not they're vaccinated or not. And this is, this season we actually did a lot of work to see what particular viruses individuals were infected with in particular. And then with, as I mentioned with the H1N1s, also look at acute and convalescent sera of these individuals to understand, some of the reasons why we're seeing influenza infection. And again, as has been previously shown in several studies, most individuals have, when we look at the acute sera, they have very low titers to either the vaccine or the virus that they were infected with. And so they don't have a correlate of protection necessarily for an influenza infection. And then we can look at even individuals who may have a history of vaccination for that season. So we are seeing that in some individuals post-vaccination, they don't mount an immune response that we would consider to be protective.
So do you think that's more important than the drift, the fact that they've just mounted a very poor immune response?
I think it's two parts, because not only did they not have enough protective antibodies to the vaccine virus, but they also didn't have enough protective antibodies to that drifted virus as well. So it's both looking at both of those amount of antibody response shows that lack of protection.
Thank you.
Dr. Durbin.
Yes, I have more of a comment than a question, and that's just, it's more, I guess, focused or relevant to the Northern Hemisphere viruses, but the recombinant vaccine, I believe, is HA only, which would limit neuraminidase protection, of course, because it isn't contained. And again, just having FDA consider expanding the allowance of a recommendation to 2 H3 and 2 viruses might be helpful, because again, just in Northern Hemisphere viruses, use of the recombinant vaccine would not include neuraminidase. Thank you.
Yeah. Any other questions to Dr. Condor? Please use the raise hand function. Okay. Well, thank you so much, Dr. Condor. I don't see any additional questions. So next on the agenda, we get a 10-minute break. It is 10:16 Eastern Time. Let's reconvene at 10:27 Eastern Time. Next on the agenda is the committee discussion, recommendations, and voting. We have had a very detailed presentation by Dr. Condor pertaining to the rationale of the selection of the 3 strains for the Southern Hemisphere flu vaccine. And there were some engaging questions and answers with Dr. Condor from the committee, and now we will be discussing this amongst ourselves. I invite the committee members to use their raise hand function to voice any comments, questions, concerns about the vaccine recommendations. Dr. Rubin.
Perhaps I should have asked this during Dr. Condor's presentation, but when we did have the discussion about moving from a quadrivalent to a trivalent vaccine, we encouraged that, but I hoped that we would retain the capability to make a quadrivalent vaccine, in part to deal with some of the antigenic drift that we discussed before. And I just wonder if we've lost any capacity to do that in the switch.
It's really a question to Dr. Weir. Dr. Weir?
Yes. So all of the manufacturers who had licensed quadrivalent vaccines which would contain 2 influenza B strains retained those licenses. They're not active. They put them on an inactive list, but yes, they would still be able to, if a B Yamagata strain emerged, they would be able to reactivate those licenses. So they still have that. I would suspect as far as manufacturing capacity, they still would have that ability too, but I guess we'd have to ask each of them individually. But I think the answer to your question is yes, we haven't lost anything as far as a quadrivalent vaccine that would contain 2 B strains.
Thank you.
Dr. Durbin?
Okay, this is the obvious follow-up question. We haven't lost the capability for a quadrivalent with 2 B strains. How arduous is the regulatory process if you wanted a quadrivalent with 2 H3N2? Or is there any flexibility, for instance, to have a quadrivalent and which 4 makeup of those viruses, whatever the makeup is, that it's more flexible so that you can be more, you can respond to different changes more quickly?
So the answer to the question about how arduous is it, I guess, would depend on whom you're asking. Manufacturers might have a different view than I do. From a regulatory point of view, yes, there are things that would have to be done. They would have to update their license. To update their license, they have to have data to support that updating. And I think it was Dr. Monto that mentioned about interference. That would be one of the things that will obviously have to be shown. You add 2 influenza A3 strains. Do you get the same type of response to both of them? There's a very in-the-weeds technical problem of can you distinguish those 2 in a potency assay? So there are technical things that would have to be worked out. Then, of course, there has to be the clinical need to drive that, and who would recommend that? So I can sit here and tell you it's probably not that hard, but it does require some studies, and it does require data to support that sort of updating. I don't think... Well, we've never had the ability, like I said, we've had licenses for a quadrivalent that contained 1 H1, 1 H3, and 2 influenza Bs. That licensure was supported by data, and if one wanted to change that, they would have to have supporting data to support any recommended change. That help?
It does. I think we're almost in a catch-22 though, because it's difficult without, I guess, strong guidance. And I guess this will be driven by epidemiological data in the future to see if we really do need two H3N2s.
So if you think back, we kind of went over this when we did this VRBPACs about taking away one of the strains, and we rehashed the history of how we got to quadrivalence. And it also was a slow process where we debated it for years about whether it was needed. And it was a kind of a question of who wanted to go first.
Yeah.
Finally, some manufacturer, and I think this was the live attenuated, did the study, showed that it could be done, and that push, and then there was a recommendation for a fourth strain if someone made a quadrivalent, and then the other manufacturers sort of fell in line because I guess it became a marketing sort of thing too. So yes, someone has to go first.
Yeah.
That's true.
Thank you very much.
Okay, thanks.
Any other questions to get the discussion going? Dr. Monto?
Just an observation after Jerry's comments. One of the main things that drove the decision to start making the quadrivalent vaccine was capacity, that there was sufficient capacity to produce the vaccine. And it's clear that if they did produce a quadrivalent vaccine and have gone to trivalent vaccines and sales have not increased, that the capacity is there. So it's really a decision that the community has to push, because it's been talked about for some time. And the necessary serologic studies, which I believe, Dr. Weir, are the only ones that would have to be done, not efficacy studies, need to be made. It seems like something which is not very hard to do compared to many of the other challenges the vaccine manufacturers have had. And the additional effect, even if it's not a diverse year, that we may even see better H3 antibodies in general with a somewhat high dose. Thank you.
Yeah, I guess, Dr. Monto, that is important, in addition to the question of antigenic interference, meaning they have to be distant enough. The issue of that really related to having a totally different antigen versus just having a higher content, which results in higher cross-reactivity. But I agree with you that the question can be answered in preclinical and clinical developmental pathways, along with the other question of what would neuraminidase inclusion do. Okay, any other questions? I don't see any raised hands. I guess Dr. Condor convinced us enough with this very detailed presentation that she had. Cecily, I think I turn it over to you now for the questions.
Yes, thank you. Thank you, Dr. Al-Sali. This is Cecily Reese, DFO. The question before the committee is a voting question. If we can go ahead and display the voting question. Thank you. Voting members will use the Zoom platform to submit their vote for this meeting. If you are not a voting member, you will be moved to a breakout room while we conduct the vote. After the chairperson reads the voting question into the record and all clarifying questions are complete, we will announce that voting will begin. A voting window will appear where you can submit your vote. There will be no discussion during the voting. You should select the button in the window that corresponds to your vote, yes, no, or abstain. Please note that once you click the submit button, you will not be able to change your vote. Once all voting members have selected their vote, I will announce that the vote is closed. Please note there will be a momentary pause as we tally the vote results and return non-voting members into the meeting room. Next, the voting results will be displayed on the screen. I will read the voting results from the screen into the record. Thereafter, the chairperson will go down the list and each voting member will state their name and their vote into the record. Voting members should address their rationale for the vote. Are there any questions about the voting process before we begin? Okay. Dr. El-Sali, would you proceed with reading the question as is written? Thank you.
Sure. Voting question for the committee. For the composition of egg-based trivalent 2026 Southern Hemisphere formulations of influenza vaccines, does the committee recommend an A Missouri 11 2025 H1N1 PDM19 live virus, an A Singapore GP 2238 2024 H3N2 like virus, a B Austria 1359417 2021 B Victoria lineage like virus?
Okay, so if there are no further questions, then we will begin voting on question 1. Next slide, please.
Recording stopped. Recording in progress.
Voting has closed and is now complete. The voting results will be displayed. Okay. So we have the voting results, which are 9 yeses, which is a unanimous vote. And Dr. Al-Sali, if you would like to move on and go around to have people explain their vote into the record. Thank you.
Yes, absolutely. Thank you all for voting on the question number 1. We begin with Dr. Saad Omer. Dr. Omer, you said yes. Any comments?
Yeah, but so nothing significant to add, but based on the data presented, both the genetic and antigenic data presented, I think it's a reasonable case to vote yes for this recommendation.
Okay, thank you. Dr. Monto, you voted yes.
I voted yes and have no additional comments to what I've said before. I think it would be very good to begin to think again about the neuraminidase because we don't even require it in the vaccine. That's quite clear. Thank you.
Thank you. Dr. Meyer.
Thank you. Yes, I think just to start off, I just want to commend my CDC colleague, Dr. Condor. I thought that was such a great detailed presentation. And every time I see one of these, I'm so impressed with the amount of work and painstaking, detailed laboratory data that gets compiled for these. And I think it really speaks to just the value of strong global laboratory networks. So first, I just wanted to get that stated that I really appreciated that talk. I think there was a large amount of data presented that I thought does support the proposed recommendations. We did hear about some of the challenges, particularly with the H3N2 lineage, but I do think that there was data presented that did support this recommendation. And then I do think from a pragmatic standpoint, alignment with the WHO recommendations makes the most sense. Thank you.
Thank you. Dr. Perlman, you voted yes.
Yes, and I voted yes. I thought the data were compelling for the vaccine composition. I also agree with Dr. Meyer about the great job that the CDC did in the presentation, and I have nothing else to add.
Thank you. I voted yes, and I also I'm a little maybe this is not warranted, but I'm a bit anxious about the B strain. Of course, the saving grace is that the B is usually milder and less associated with less mortality than the A. But probably we may be seeing something evolve there to move us from the Austria. But given the geographic distribution, I agree, not to take a chance. And I echo what I just stated earlier, that it is time for manufacturers and the scientific community to start evaluating improving the vaccine by capitalizing on the neuraminidase data we have. And I want to finish by thanking the WHO and the CDC for the data they gathered as presented so elegantly by Dr. Condor. Dr. Rubin?
I agree with everything that's been said. I noticed that I think I'm off the committee in January, so this may be my last flu presentation. And I also want to commend the CDC and FDA and WHO staff for doing such a great job with this.
Thank you. Dr. Durbin?
Thank you. I don't have a lot to add. I also really want to thank the CDC presentation. I thought it was incredibly informative, in-depth, easy to understand, and very helpful in making these recommendations. I voted yes based on the depth of the data and the scientific evidence that was presented for this. I would encourage, I guess I have to encourage a manufacturer to be the first to step forward in looking at 2H3N2 strains, but I do hope that additional research will be done to make the vaccine even better. Thank you.
Dr. Bernstein? Sorry, Dr. Portnoy. Dr. Portnoy, you voted yes.
Yeah. I turned my monitor on and then I turned it off because I wasn't sure, but I voted yes. The data was very compelling. I'm always amazed at how much information is presented to us, both genetic, epidemiologic, and surveillance. It's just impressive. I'm also impressed by how we can respond to changes in the variants of the influenza as they evolve over time, and respond by developing new strains and having them available in the vaccines as well. So I think that I want to commend the CDC, the FDA, the World Health Organization. I think you do an amazing job, and it makes me comforted just to know that that surveillance program is still in place given all of the uncertainties in today's political climate. So thank you very much.
Thank you. Dr. Bernstein, you also voted yes.
Thank you, Dr. El-Sally. I don't really have anything. I echo all of my colleagues' comments. Clearly, I must admit, Dr. Condor's presentation was incredibly impressive. I learned something every year going through this. I think science is driving these decisions, which I think is really very important. And I really don't have much more to add than what's already been said.
Okay, well, thank you all for the discussions and the votes. To summarize the discussion, everyone was thankful for the CDC and WHO body of data as presented so eloquently by Dr. Condor. And everyone concurred with the selection for these 3 strains for the Southern Hemisphere flu vaccine. Comments were raised pertaining to improving the flu vaccines by utilizing what we know so far on the neuraminidase role in protection, the potential use of additional H3N2, generating data on the preclinical and clinical on the utilization of these paths to improve the flu vaccines, among others. And yeah, I think that was the summary. I hope I didn't miss any other major questions. And now we adjourn the topic 1. We do have a 30-minute break. Is that correct, Cicely?
That is correct, 30 minutes.
30 minutes. So now it is 11 a.m. Eastern time. Let's reconvene at 11:30. Thank you.
Dr. Elsali, you can go live.
Yeah, thank you. I would like to welcome the committee again for the topic 2. Topic 2 will be to discuss and make recommendations on advancing CBER's allergen standardization program. I hereby call the meeting to order. I would like the 4 allergy expertise on the committee to raise their hand so I can see where they are and I can call them to introduce themselves.
Oh, excuse me, Dr. Elsali.
Yeah.
We're going to go through, I have to go through the conflict of interest statement again, the introductions and conflict of interest statement again. So I'll go ahead and pick that up and add them in there if that's fine with you.
Okay, sure. It had me doing this on the annotation, but that's great. Thank you.
Thank you. My name is Cicely Reese again, and it is my honor to serve as the designated federal officer for topic 2 of the 190th meeting of the Vaccines and Related Biological Products Advisory Committee. On behalf of the U.S. Food and Drug Administration, the Center for Biologics Evaluation and Research, and the committee, I'm pleased to welcome you back and to extend a warm welcome to those who are just joining us for the second portion of the meeting. We will now take a brief roll call to reconfirm attendance for those who have been with us since the morning, earlier this morning, and then invite our recently joined allergenics experts to introduce themselves for the record. When called upon, please turn on your camera, unmute, and introduce yourself by stating your first and last name, your organization, and your expertise or role. Once finished, you may turn your camera off so that we can move to the next person. If you could please display the slide, thank you. And we will begin again with our chairperson, Dr. Hana Elsali.
Good afternoon, everyone, or good morning still. My name is Hana Elsali. I am a professor of molecular virology and microbiology, Baylor College of Medicine in Houston, Texas. My expertise is in infectious diseases and clinical vaccine development.
Thank you, Dr. Elsali. Dr. Bernstein?
Hello, everybody. My name is Hank Bernstein. I'm a professor of pediatrics at the Zucker School of Medicine at Hofstra North Shore and Cohen Children's Medical Center in New York. I'm a general pediatrician with expertise in vaccination and policy, and I do primary care pediatrics.
Thank you, Dr. Bernstein. Dr. Durbin?
Hi, my name is Dr. Anna Durbin. I'm a professor of international health in the School of Public Health at Johns Hopkins University and adult infectious diseases and internal medicine in the School of Medicine at Johns Hopkins. And my area of research is early vaccine development and evaluation. Thank you.
Thank you, Dr. Durbin. Dr. Colmar?
Hello, I'm James Colmar. I'm a pediatrician by training and a scientific AVP in global regulatory affairs and clinical safety, vaccine infectious disease at Merck & Co. I'm the industry representative.
Thank you, Dr. Colmar. Captain Meyer?
Hello, hi, I'm Sarah Meyer. I'm a pediatrician and medical officer at the CDC. My areas are pediatrics and vaccines.
Thank you, Captain Meyer. Dr. Monto?
I'm Arnold Monto. I'm an epidemiologist at the University of Michigan School of Public Health, interested in respiratory infections and control with vaccines and antivirals.
Thank you, Dr. Monto. Dr. Omer?
Hi, I'm Saad Omer. I'm the Dean of the O'Donnell School of Public Health at UT Southwestern in Dallas. I focus on interventional and observational studies of vaccines and infectious diseases.
Thank you, Dr. Omer. Dr. Perlman? You may be on mute, Dr. Perlman. We can come back to Dr. Perlman. Is everyone hearing me?
I can see him.
Dr. Perlman, are you on mute? We can come back to Dr. Perlman, but if we can see him, and he'll join. Dr. Oh, there we are.
Sorry, I was on mute, or I muted myself here. Yeah, I'm Stanley Perlman, pediatric infectious diseases at the University of Iowa with expertise in coronaviruses.
Thank you, Dr. Perlman. Dr. Portnoy?
Good afternoon. I'm Dr. Jay Portnoy. I'm a professor of pediatrics at the University of Missouri, Kansas City School of Medicine. I'm an allergist immunologist at Children's Mercy Hospital in Kansas City, Missouri.
Thank you, Dr. Portnoy. And Dr. Rubin?
I'm Eric Rubin at Harvard, the Brigham and Women's Hospital, and New England Journal of Medicine. I'm an infectious disease doctor at who studies tuberculosis.
Thank you, Dr. Rubin. And we will now join in with our allergenics experts for the first time today. Dr. Assad.
Hi, I'm Amal Assad. I am a professor of pediatrics at the University of Cincinnati. I am the Director of Clinical Services in the Division of Allergy Immunology at Cincinnati Children's Hospital. My expertise is allergy and immunology.
Thank you, Dr. Assad. Dr. Davis? You may be on mute. Do we have Dr. Davis's audio? We can come back if we're working on that. Dr. Dykowitz?
Hello, I'm Mark Dykowitz. I'm professor of allergy and immunology and internal medicine at St. Louis University School of Medicine in St. Louis, and my expertise is allergy and immunology.
Thank you, Dr. Dykowitz. Dr. Greenberger?
Hello, everyone. Paul Greenberger. I'm an internist and allergist immunologist, professor of medicine emeritus at Northwestern University, Feinberg School of Medicine in the Department of Medicine in Chicago. My expertise includes work with Aspergillus fumigatus, primarily in the context of allergic bronchopulmonary aspergillosis. And a number of years, not that many years ago, cat allergy accelerated immunotherapy through the Immune Tolerance Network study called CATNIP.
Thank you, Dr. Greenberger. We're going to try to go back to Dr. Davis and see if we have her audio. If not, we can work on that, and we can, at a break, we can have her introduce herself. We're working on the audio. We'll come back to her. We may be having some audio difficulties. So I'll go on to the next portion of the meeting where I'll read the conflict of interest statement again. The FDA is convening today's meeting of the Vaccines and Related Biological Products Advisory Committee, also referred to as VRBPAC, under the Federal Advisory Committee Act, FACA, of 1972. The VRBPAC will meet in open session to discuss and make recommendations on advancing CBER's allergenic standardization program. With the exception of the industry representative, the members of the committee are either special or regular government employees and are subject to federal conflict of interest laws and regulations. Accordingly, FDA has reviewed the financial interests of the committee members for compliance with federal ethics and conflict of interest laws. We have screened the members for potential financial conflicts of interest related to today's meeting agenda. Both their own interests and those that are imputed to them, including those with their spouses, minor children, and employers. Based on the agenda for today's meeting and all financial interests reported by the committee members, FDA has determined that all members of this advisory committee are in compliance with federal ethics and conflict of interest laws. And as a result, no conflict of interest waivers under 18 U.S.C. 208 have been issued in connection with this meeting. Dr. Archana Chatterjee has been recused from the meeting based on today's agenda and her financial interests analyzed by FDA. James Colmar of Merck & Company is participating in this meeting as a non-voting industry representative, acting on behalf of regulated industry. Consistent with Commissioner McCary's April 17th, 2025 statement, FDA is only including industry representatives in advisory committee meetings where required by statute. FDA is required to include an industry representative in today's meeting under 21 USC 355 N3C. Industry representatives are not appointed as special government employees, nor are they regular government employees. Industry representatives serve as non-voting members of the committee. Non-voting industry representatives represent all regulated industry and are not any particular association, company, product, or ingredient, and bring general industry perspective to the committee. Under FDA regulations, although a non-voting member serves as a representative in a representative capacity, the non-voting members shall exercise restraint in performing such functions and may not engage unseemly advocacy or attempt to exert undue influence over the other members of the committee. Dr. J. Portnoy is serving as the consumer representative for this committee. Consumer representatives are appointed special government employees and are screened and cleared prior to participating in the meeting. They are voting members of the committee. There are guest speakers at today's meeting and an organizational speaker who will be giving a presentation to the committee, answer questions from the committee, and return the committee back to the chair. They will not participate in the committee deliberations, render advice to the FDA, or vote. The speaker and organizational speaker participating in this meeting are presenting the views of their professional societies and not their personal views. The following guest speaker has been screened and cleared to participate in this topic for the meeting, and that is Dr. Thomas Platts-Mill. In the interest of transparency, FDA asks that speakers and guest speakers disclose any personal financial involvement with a firm, product, or other entity affected by the committee's discussion to allow the audience and the committee to objectively evaluate their presentation. Today's speakers and organizational speakers have not reported any such relevant interests. FDA asks that all other participants, including the open public hearing speakers, advise the committee of any financial relationships that they have with any affected firms, its products, and if known, its direct competitors. We would like to remind the members that if the discussions involve any products or firms not already on the agenda for which an FDA participant has a personal or imputed financial interest, the participant needs to inform the DFO and exclude themselves from the discussion, and their exclusion will be noted for the record. Thank you. Dr. El-Sali, I will now turn the meeting back over to you to commence the open public hearing for session 2.
Thank you, Cecily. So now is the open public hearing session for topic 2. Welcome to the open public hearing session. Please note that both the FDA and the public believe in a transparent process for information gathering and decision making. To ensure such transparency at the open public hearing session of the advisory committee meeting, FDA believes that it is important to understand the context of an individual's presentation. For this reason, FDA encourages you, the open public hearing speaker, at the beginning of your written or oral statement to advise the committee of any financial relationship that you may have with the sponsor, its product, and if known, its direct competitors. For example, this financial information may include the sponsor's payment of expenses in connection with your participation in the meeting. Likewise, FDA encourages you at the beginning of your statement to advise the committee if you do not have any such financial relationships. If you choose not to address this issue of financial relationships at the beginning of your statement, it will not preclude you from speaking. My understanding is that there are no one who registered for the open public hearing session, so that concludes the open public hearing session. Next on the agenda is Dr. Rabin. Dr. Rabin is Chief Laboratory of Immunobiochemistry, Division of Bacterial, Parasitic, and Allergenic Products, Office of Vaccine Research and Review at CBER FDA. Dr. Ronald Rabin will give us an overview of the replacement of radial immunodiffusion assays of currently standardized extracts with ELISA or aptamer-based enzymatic assay. Dr. Rabin. We cannot hear Dr. Rabin.
Oh, okay. Can you hear me now?
Yes, we can.
Okay, terrific. Thank you very much. Members of the committee, those of you who were in the morning session, for staying for the second half of the session, and thank you very much for the group of allergists who have joined the committee meeting for this session. As you have seen from the agenda and the briefing document, we've basically broken this presentation, to this topic up into two presentations. The first one pertaining to the enzyme-linked monoclonal antibody and aptamer-based assays that we are currently developing. Next slide, please. The desired outcome for today's meeting is the updated methodology is for potency measures and allergen extracts that can be represented by one or two allergens, and to apply these methods towards increasing numbers of standardized allergen extracts. The problems that we're addressing is that the current method for measuring the major allergen content is outdated and should be replaced, and that non-standardized extracts are a regulatory gap that compromises clinical reliability. Next slide, please. Just to remind you that the questions relevant to this talk are the scientific soundness of mass concentration measurements by ELISA or a similar assay using aptamers rather than monoclonal antibodies, and the appropriateness of these revised assays for CBER's allergenic to expand our allergenic program, standardization program. Next slide, please. What I'm going to do is discuss allergenic products and the regulatory framework for their regulation. To the allergists in the group, I apologize because we have a lot of people on the committee who do not think about allergic disease and allergen and immunotherapy from day to day. I'm going to go over some of the basics so that everybody's on the same page. I'm going to discuss current potency measures of allergen extracts, progress in the ELISAs and aptamer-based enzymatic assays to replace outdated potency assays in current use, a need for expanding the list of allergen extracts, standardized allergen extracts, and the concept that the adoption of the ELISA that we're working on would serve as a template for validation of new assays and tech transfer to manufacturers to use for lot release. Next slide, please. So just to remind you of what I'm sure you all know, that asthma and food allergy are common chronic diseases. Over 1 in 4 American children have allergies, which for the purposes of this statement could include atopic dermatitis, allergic rhinitis, conjunctivitis, asthma, or food allergies. And the graph on the right is from the recent MAHA report showing the increase in prevalence of food allergies over a period of about 30 or 20 years or so in children either 0 to 4, 5 to 9, or 10 to 17 years of age. Next slide, please. So allergen immunotherapy is the only disease-modifying treatment for allergic disease. And in 2009, it was estimated that about 3 million Americans receive allergen immunotherapy. Immunotherapy for environmental, that is non-food allergies, is the most often administered as subcutaneous injections of allergen extracts. And the basic recipe for these allergen extracts has been used for over 100 years. The next slide, please. Now, the FDA has not changed its approach towards standardization of these allergen extracts in the past 30 years, but advances in science really present an opportunity to bring regulation of allergenics into the 21st century, and that is why we are having this conversation today. Next paragraph, please. Next paragraph, next slide. So what are allergen extracts? Allergen extracts are sterile aqueous extracts of plant or animal proteins used to diagnose or treat allergic hypersensitivity. These are crude preparations, and the source materials may be pollens, food, or animal hair or dander. Now, it's important for me to state that the questions before the committee concern these licensed products that are used to aid in the diagnosis or treat allergic disease and that are licensed for administration by the percutaneous, intradermal, or subcutaneous routes. The presentation and discussion are not relevant to the licensed sublingual products, the licensed oral immunotherapy product for peanut allergy, or any novel products in our regulatory pipeline. We are only referring to these allergen extracts, these aqueous allergen extracts. Next slide, please. Now, the regulatory framework, our authority to regulate these extracts derives from two laws enacted by Congress, the Food, Drug, and Cosmetic Act of 1938 and the Public Health Service Act of 1944. Regulations that specifically address allergen extracts appear in Part 680 of Title 21 of the Code of Federal Regulations, although other parts of 21 CFR also apply to allergenic extracts as well. And what these regulations say is that CBER determines standardization methods and potency units, and that once CBER standardizes an extract, it must be distributed by the manufacturers as a standardized extract. Currently, there are 19 allergen extracts, and they were standardized between 1987 and 1998. And they're standardized by either measurement of a major allergen or overall potency. And I'll go into those in more detail in a few moments. Now, for the extracts that aren't standardized by CBER, they're considered non-standardized, and they are they're described as, their concentrations are described as being protein nitrogen units or weight per volume at time of extraction. And it's important to point out that for these non-standardized extracts, there's no indication as to whether a protein is intact. Now, one salient feature about the standardization and that how we regulate it is a difference between how we do it here and how it's done, for example, in Europe. In Europe, the different companies standardize their own extracts and use their own unitages. And what that means, but here we do that. And the reason for it is because unlike the European market, by using reagents and potency units that are common to all manufacturers, healthcare providers can infer from that, for example, that a Timothy grass extract labeled 100,000 BAU ml from manufacturer A is qualitatively and quantitatively identical to a Timothy grass extract labeled 100,000 BAU per ml from manufacturer B. This is an advantage that we feel, a strong advantage for regulation and standardization by FDA rather than individual manufacturers. Next slide, please. Now, as I mentioned, some of the extracts are regulated by the major allergen. Now, a major allergen is currently defined as a protein in which more than 50% of the allergic patients are sensitive to. And we have this talk at least concerns two particular allergens, extracts that are regulated by major allergens, and that major allergen is measured currently by the radial immunodiffusion assay. Now, a picture of the radial immunodiffusion assay is shown on the left side of this slide, in which you have a glass slide with agar, and then you have holes that are punched into it. The agar has in it a polyclonal antisera against the allergen, and then the allergen at different concentrations are put into the punched wells. And after a period of time, these precipitin rings are formed, and the diameter of the precipitin rings are correlate with the concentration of the allergen that was placed in the center in that hole. And you could see a curve, a calibration curve in the center. And you could see as well the machinery that we use to measure these precipitin rings. And the important point here is that while this technology works, it's antiquated, it's old. The precipitin rings do not always form these ideal edges, discrete edges that I'm showing you here in the picture. And the instrumentation that you see on the right is no longer being manufactured. And so if it were to fail, then we would be in a bit of a pickle. Okay. Next slide, please. Now, the allergens, which this talk will not really center on the allergens that are standardized by overall potency, but for contrast, I'm going to go over how that was done back in the 80s and the 90s when it was done. And the reason that these allergens were standardized by overall potency is either there were no major allergens that could define them, or at the time, at least, there were no known major allergens that could define them. Of course, in the last 30 years or so, we've learned quite a bit about all of these allergens. But the way that it was done was with this procedure called ideal testing, in which you had subjects who were highly allergic, and they received these intradermal injections of serial threefold dilutions of the allergen extract. And you see sort of how it was mapped on their back on the right. And in response to these injections, they would develop the little wheal, which is the little oval in the center, and then the flare, the redness, which is the outside oval. And the flare, the redness, the erythema, that would be measured, the orthogonal diameters, and when the orthogonal diameters were 50 millimeters, that was just arbitrarily referred to as an extract that was 100,000 bioequivalent allergy units. Next slide, please. Now, obviously, a problem with the ideal testing is that it was useful for measuring and determining potency, but it wasn't an assay that you could use for lot release. So a surrogate assay had to be developed, and that assay is the competitive ELISA for overall potency. And for those of you that aren't familiar with it, it's simply that you have in plate-bound you have antigen, or in this case allergen, reference allergen, in which you have the known concentration that is bound to the plate in your 96 well plate, bound to the bottom surface, and then you have your test allergen in solution. And these two allergens are competing, as shown in the center part of the cartoon there, for antibody, in this case IgE, from pooled human sera, 10 to 15 allergic subjects. And then the antibody itself is either linked to an enzyme, or there's a secondary antibody that's linked to an enzyme. And you wash away everything that's in solution, and what's left is the signal from what's bound in the plate. And the more allergen there is in solution, the less antibody there is bound to allergen in the plate. And it's a reasonably good ELISA. It works reasonably well, but it does have some limitations. It doesn't detect compositional differences between extracts. And of course, since we're using serum pools from paid donors, these pools can vary because of differences amongst donors. We don't get them from the same donors each time. The donors, of course, are not identified. Next slide. So, as I mentioned, there are 19 standardized allergy extracts and hundreds of non-standardized extracts. And this is just to show you how they kind of break out. The ones on the left, the grass pollens and the house dust mites, are standardized according to overall potency by BAU for the grass pollens, or AU, and they're really the same thing for house dust mites. And then on the right, short ragweed pollen and cat, hair or pelt by their major allergens, and those are the ones that we're discussing today. And the venoms also by their major allergens, but we're not going to be discussing those today. Next slide, please. So what I've showed you so far is that allergen extracts are crude preparations that are safe and effective and modulate allergic disease. There are 19 allergen extracts that are standardized for potency, some for major allergens, some for overall potency, and there are remaining hundreds of extracts that are non-standardized. Next slide, please. But there's some drawbacks for major allergen. These assays are outdated. We have an instrument that can't be replaced, and it would be difficult to expand the standardization program using these sorts of assays. Next slide, please. Next slide, please. Next slide. Yeah, for overall potency, that relies on some assumptions that I'll be discussing more in the next talk. But the assumptions are that the extracts from the different manufacturers are qualitatively similar, and that allergic patients react similarly to the same set of allergens. If either of these aren't true, then standardization may not actually represent the product. And next slide. And then the next slide, please. And then the remaining, and then as far as those that are unstandardized, there's no indication as to whether the protein is intact, and so therefore they can lack efficacy, and as a diagnostic product, they can lead to misdiagnosis. Next slide, please. So the rest of this part of my talk then pertains directly to this first question: the scientific soundness of mass concentration measurements as obtained by ELISAs or a similar assay using aptamers. Next slide. So, as I mentioned, the way that standardization works in the United States is that we develop the standardization assay, and that the assay then can be adopted by the manufacturers. So the manufacturers don't have to use our assay. If they want to use their own, that's fine, but they have to demonstrate that it's either equivalent or superior to ours. But we devise, we qualify, we validate these potency assays for allergenic extracts. We distribute the reference reagents at no cost to the manufacturers for potency testing for lot release of the standardized extracts. And we do so in our laboratory, the Laboratory of Immunobiochemistry, which is the laboratory that I manage. And this is an ISO 17002 certified laboratory, at least right now for the competitive ELISA, and for any other assays that we will integrate into the lab, we would intend to obtain ISO certification as well. Next slide, please. Before I continue, for those of you who don't think about allergic disease every day, you might not be familiar with the nomenclature of these allergenic proteins. The nomenclature of these allergenic proteins is fairly straightforward. The first three letters pertain to the genus, the second letter pertains to the species, and then the number pertains to a group number of allergen, which is often just numbered according to their order of discovery, although within a group of species of plants or animals, if there's a number of an allergen, if there's a particular allergenic protein that has has high homology amongst the species, they'll all have that number. So cat, for example, is Felis domesticus, and we're talking about FeLD1, by far the most important allergen from cats. Next slide, please. And that is the most important allergen from cats. And then ragweed, we're talking about AMBA1, which is by far the most important allergen for short ragweed. Next slide, please. Now, what is FeLD1? It's considered a universal allergenic protein because almost all cat allergic patients are sensitive to it. It's a secretoglobulin protein complex produced by salivary and sebaceous glands. It's a tetramer comprised of two disulfide linked heterodimers, chains 1 and 2, and the chain 2 is an N-linked glycoprotein. It's an extremely stable and sticky protein. It's found almost everywhere, in homes that have cats, in homes that don't have cats, because people who have cats will visit homes that don't have cats. It's found in schools because it sticks to clothing. It's really quite remarkable. And even if you get rid of your cat, you'll have FeLD1 in your house for a good 6 months after the cat is gone. It's originally was assigned in FeLD1 units. It was sort of later determined that maybe a unit was 4 micrograms of FeLD1. The literature isn't really clear as to how they got that number. And then it's also the extracts are required to have 10 to 20 FeLD1 units per mil, and then they're assigned this BAU unitage, which is a little bit odd to me, has always been, in which case where you had an extract that was 5 to 9.91 FeLD1 units, it was just called 5,000 BAU, and 10 to almost 20 units, it was 10,000 BAU. Next slide. Now, this is just a picture of the heterodimer, and you could see that they're linked by their sulfurs, and there's some calcium molecules, ions in there that are involved in the linkage. What's important, what this reminds me to share with you, is that the IgE reactivity to the heterodimers has been shown to be greater than the sum to either of the monomers. So we can infer from that that some of these IgE epitopes are conformational rather than linear. And so the stability of the heterodimer is very important to its allergic properties. Next slide, please. Well, we had some in-house monoclonals to FeLD1, and we worked with them for quite a bit, but we couldn't really get them to work with the kind of precision and accuracy that we were that we needed. And it became apparent over time that laboratories, one academic laboratory and then another in private industry, were cloning allergen-specific IgEs from allergic donors. And this was very attractive to us to use as reagents because they're biologically relevant, just by definition. And what this figure shows is just a schematic of how that was done, that they would enrich the B cells and do single sort. They sort on the B cells, RNA-seq to determine which were plasmablasts or memory cells or naive cells, clone the immunoglobulin, determine its content. And what you could see from this is probably the most interesting take-home message is the bottom right graph, in which you could see that unlike any of the other immunoglobulin types, almost all the IgE secreting cells were plasmablasts. And we know that that's the case with allergic disease. That allergic disease, is such a problem because these IgE secreting plasmablasts are long-lived. Next slide, please. And then what they do is they take these antibodies. In this case, they found 4 antibodies that reacted to FeLD1, and they do these sandwiching, or they do these competition assays on a surface plasmon resonance chip, in which case they have one of the antibodies bound to the chip. They have the FeLD1 bound to the antibody, and then they put in the other 3 antibodies, and the antibody either binds to the FeLD1, meaning that it recognizes a different epitope and can be used as a sandwiching antibody, or it's blocked because, and that means that it can't be used as a sandwiching antibody. And they found 2 pairs of sandwiching antibodies, and we licensed one of those pairs. Next slide, please. And these are just SPR assays showing of these, all 4 of these monoclonals. And I should point out that we're referring to them as class switch because this company, IGgenix, is using their business model is to use antibodies as a therapeutic modality. So they class switch them to a stable IgG4. Okay, and that's what they really are. But at any rate, that obviously doesn't affect the binding affinity to the target antigen. And what you could see here is that these all have sub-nanomolar affinities. Next slide, please. Well, we use these antibodies and to develop the ELISA. And we could show that it was certainly reproducible and reasonably precise. The EC50s of the relative potency shown of 2 particular cat allergen extracts, which is shown in the upper left-hand corner, was a very tightly distribution along that line over 142 measurements. And the distribution of one of the extract potency we found was that the reference value was 14.7 FeLD1 units per mil, and that the mass per unit of FeLD1 we determined to be about 3.12 micrograms. Now this, next slide, please. Now this was a reasonably good assay, and it was good enough to publish, but we realized that it really wasn't good enough. We hadn't really gotten it to perform well enough in the regulatory domain. And so we're working very hard on that. And we've changed some of the parameters of the assay. And what you can see here is some preliminary data in which we have 6 replicates of the assay in which the EC150 is very tight with confidence limits plus or minus 6%. So that's really what we're shooting for before we start using this assay as a regulatory tool. Next slide, please. So what about when high affinity monoclonals aren't available for all allergens? Well, another possibility is to use DNA aptamers. Next slide, please. And what are those? These are synthetically produced oligomers that bind to target molecules with high affinity. They're often referred to as chemical antibodies. They're selected from a starting pool of about 10 to the 14 randomly sequenced single-strand DNA oligomers. Their affinities and competitions are determined with a technology like surface plasmon resonance. And there's some advantages to it because there's no animals or human blood that are necessary. And once the optimal pair has been chosen, synthesis of DNA, single-stranded DNA, of course, is relatively cheap. Next slide, please. This is a schematic of how these aptamers are selected, and it's a little bit complicated, but I'll just describe to you the salient features. Briefly, the aptamers have these pre-CBER primer binding sites on each end and random sequences in the middle, and then the little site that docks them to beads. If the DNA aptamers bind to the target protein, they separate from the beads, and then those aptamers can be amplified by PCR, cloned and sequenced, and then tested for binding affinity with the technology, again, such as SPR. The best pair then are selected, and then we develop the ELISA, or the aptamer enzymatic assay. Next slide, please. So what I've done is I've described to you where we are with these newly developed assays. I can tell you that the aptamers are now in the process of being selected. I actually just received an email from the company yesterday that they've got the pairs and they're moving forward with it. So that's happening. And I just want to remind you again that the FeLD1 and both the AMBA1 are in units. They're currently in units, or for the FeLD1, it's AMBA1 units, and then a BAU. But I want to communicate to you that this is done because we use as the reference material an extract. That we use an extract. So we're always comparing one extract to another extract. But since really this was put together 35 to 40 years ago, there have been highly purified preparations that are commercially available of these allergens, and that allows us to measure their absolute concentrations. And that way we can discard any kind of ambiguous unitage and simply state the concentration of these major allergens in micrograms per mil. And that, of course, is the first question that we are posing to you this afternoon. Next slide, please. So now we'll move to the second slide, which is the appropriateness of these revised assays for CBER's allergenic program, standardization program. Next slide, please. So I mentioned to you that non-standardized allergen extracts can be a problem, and they can be a problem because there's no indication of potency. It's simply protein nitrogen units or weight per volume at time of extraction. And it can be a problem if the protein in the extract is not intact. And in fact, we did have that problem. In 2022, 4 lots of peanut extract were withdrawn because of false negative skin tests. Some children were misinformed that they were not peanut allergic, and they subsequently reacted to peanut-containing foods. And then it happened again in 2023 that pecan extract lots were recalled because of false negative skin tests. And what you see below the text are four images in which this is a typical ELISA that was done by a lab in Vanderbilt that has human IgEs to these 4 peanut allergens, ERA H1, ERA H2, 3, and 6. And you could see the red and the violet with the inverted triangles to the right showing that unlike the other 3 extracts, these concentrations were really quite low in these recalled extracts. So this was a real problem, and it had real consequences for patients who depended upon these assays for a diagnosis of food allergy or to be informed that they were not food allergic. Next paragraph, next slide, please. And so from that, there became, people advocated that we should expand our standardization program. The main advocate was our, of course, stakeholders, those who are food allergic and those who are concerned with the medical care of patients who are food allergic. And probably the largest and most predominant advocacy group, Food Allergy Research and Education, had a workshop last year, put in tandem with their annual Development Day seminar, in which we from FDA, manufacturers, academicians, and of course representatives from FAIR itself discussed standardizing food allergen extracts. And we all pretty much agreed that this was a worthy endeavor. And so this is something that we're going to be doing, that we intend to do with your concurrence in our reference reagent lab to develop ELISAs or perhaps aptamer-based assays to replace obsolete assays, and also to expand our standardization program. Next slide, please. But we could do that beyond food extracts, and what we've learned about allergens has really helped facilitate a strategy that we could use that might make some of these antibodies very potent tools. And so, for example, tree pollen allergy is actually a big problem, and none of the tree pollen allergen extracts are currently they're all non-standardized. And you know, oak, birch, cedar, these are all very prevalent in North America. Next slide, please. And what I'm showing you here are ribbon diagrams of 6 related trees: birch, hornbeam, chestnut, European beech, white oak, and alder. And these are all proteins that belong to the pathogenesis-related protein 10, or PR10 family of allergens. You see they all share the number 1 because they're all very, very similar. And they look very similar. And if you go to the next slide, please, you can sort of gander. I mean, I realize we're not going to give you a lot of time for close inspection, but there's, you know, a fair amount of similarity and identity amongst these 6 proteins. And so it's quite possible that we can use, with a minimum number of reagents, that we can standardize all these tree pollens with one hit. And of course, standardizing a tree pollen such as white oak pollen probably means that we could standardize the major allergens from red oak pollen and other pollens at the same time. And it's really a very effective strategy. At least theoretically, it's appealing. Whether or not it'll go as smoothly as we hope, of course, we won't know until we do the experiment. But I would say that cross-reactivity of patients who are tree allergic to many of these trees suggests that it's a viable option. Next slide, please. So here we are, we're replacing the FeLD1, and the ELISA is progressing towards qualification and validation. The aptamers are being selected, and the most important, and then the work on the FeLD1 ELISA will serve as a template for qualification, validation, and tech transfer. Next slide, please. Now, what about validation? The validation is really an important part of this process. It's absolutely required by 21 CFR Part 211, a good manufacturing practice, and 21 CFR Part 610, General Biologic Product Standards. And there's a number of documents at here, and the reason of showing you these documents is not to really discuss them, but to point out that if you're not really familiar with assay setup, this is a huge amount of, there's a huge amount of work and body of literature as to how to go about doing this. Next paragraph. Next paragraph, next slide. And assay validation is the foundation of quality control. And the objective is to prove that the assay is fit for the intended purpose, appropriate for the stage of development of the product, and can be trusted for critical regulatory decisions. In other words, that it's accurate, precise, reliable, and reproducible, and therefore supports the concept that the product is safe, pure, potent, and effective. The assays are the foundation for quality control, and an unvalidated or poorly validated assays can give misleading results that can affect safety and efficacy of the product. Next slide, please. There are a number of performance characteristics to test and document in the process of validation. The ones on the left are critical. The ones on the right are also addressed. Accuracy, specificity, the limits of qualification, linearity, range, and precision, all are defined not only in the lab, but the results are statistically quantified. They're statistically defined so that we really know the variability and the precision of the assay. Next paragraph. Slide. The template that we're acquiring is that we produce monoclonal antibodies, or the aptamers. We develop the assay procedure. We'll do that within the lab. We qualify the assay to determine its performance characteristics, and this is with our statisticians. We transfer the technology to the manufacturers, the reagents, the validation protocols. We work with them and help them to achieve the same performance characteristics that we've been able to demonstrate, troubleshoot when that doesn't happen. When all of that is done, we publish the assay, we adopt the assay, and we inform stakeholders that these allergen extracts are now standardized. Next slide, please. Before I summarize, I just want to acknowledge all the people that have contributed to the work that I've presented today. Those in our LIB reference reagent lab, Aaron Chen, who does a great deal of the work, Mona Phoebus, Katerina Dovorovskaya has retired. We miss you, Katya. Your replacement will never live up to your legacy. And Robert Zagorski, who is our quality manager and really keeps things at a high level of performance in the lab. Those within the division above me, Dr. Slater, my friend and colleague who retired last summer, Dr. Tennant, who is now the acting director, Jennifer Bridgewater and Leslie Wagner, who are regulatory coordinators and policy experts. Leslie is really the person who is advising me as to how to do the validation and really working with us. She's invaluable. Jennifer has always been invaluable. And Dr. Robert Hamilton helped us set up the mouse assay, the cat assay originally, and then the people from IGGenics who worked with us and were so kind to license the antibodies to us. Next slide, please. So again, what I've shown you is the replacement of the RID is progressing. We've got aptamers in the works. We have a FeLD1 ELISA that we think will provide a template for standardization of currently non-standardized extracts. Standardizing the food allergen extracts is a priority for us. The similarity of major allergens may provide templates for standardizing multiple allergen extracts with one hit. And assays for standardization will undergo rigorous validation. Next slide, and the final slide is to bring to you the voting questions that are relevant to the information that I've shared to you up till now. Question 1, scientific soundness of mass concentration measurements. Does the measurement of mass concentrations by ELISA of their major allergens provide a scientifically sound approach for expressing and reporting potencies of cat hair and pelt allergen extracts and of short ragweed pollen extracts? Question 2, appropriateness of revised assays for CBER's allergenic standardization program. Are the revised assays for cat hair, pelt, and ragweed pollen allergen extracts scientifically appropriate templates for expanding CBER's allergenic standardization program to include major food allergens and environmental allergens? And with that, I have finished this first presentation, and I'm open to any questions.
Thank you, Dr. Rabin. We need to circle back to Dr. Davis. Dr. Davis, would you please unmute, put your camera on, and introduce yourself to the public and the other committee members?
Thank you. Yes, my name is Dr. Carla Davis. I am the chair of pediatrics and child health at Howard University. I served as the director of the food allergy program at Texas Children's Hospital, Baylor College of Medicine for 27 years and have a translational research program in food allergy.
Thank you, Dr. Davis. So on the agenda now is the Q&A portion pertaining to the first presentation by Dr. Rabin. Please use the raise hand function and ask any questions you may have to Dr. Rabin. And I see Dr. Davis. Well, no, just a second. First question from Dr. Rubin.
Thanks very much, and thanks for that presentation. You know, it's hard to argue unless you're Dr. Octerlony. It's hard to argue that better measurements of and better and easier and more accurate and reproducible measurements are a bad thing. I guess the only question is, do we know that these measurements correlate with efficacy and, you know, as either a diagnostic as opposed to just a better measure? And along with that, what do we know about the minor antigens? Are they important, and should we be measuring those as well?
Yeah, that's an interesting question. So the first question is do we know that measuring the major allergens correlates, you know, with the actual allergenicity? And the answer is that seems to be the concept that they do. That they do, and that their concentration does reflect the potency, and I think implicit in your question, if I'm understanding it correctly, is it's the way that we're measuring them correlative to their potency, because that's the underlying assumption, of course, of a potency measurement, really. And I think the answer to that is yes. I think that, you know, for native allergens, you know, those that have not been mutated to ablate, you know, Ig epitopes or T cell epitopes, for example, you know, the best thing that we can do is we can demonstrate that these proteins are intact. And so we have to do that by, you know, sometimes, you know, denaturing the protein and showing that it loses its activity on the ELISA, or just from the knowledge that we have. For the ragweed, we can do that. For, you know, the MB1 is fairly heat labile, and if the, you know, the aptamer assays recognize a, you know, a heat denatured protein, then it's not of use, and the pair that's chosen is not the optimal pair. Since it's almost, you know, impossible to degrade a FeLD1 allergen, we don't have that tool at our disposal. But again, everything that's known about it is that these antibodies seem to be you know, do seem to have to be conformationally dependent. It is possible, and, you know, it's something I would love to do. Haven't really had the time, but, you know, to see whether or not, you know, we can get, you know, some EM cryo or something to actually look at these antibodies and see where they bind. From what I understand, and obviously I'm not a structural biologist, for FeLD1, this is because of some of its properties, it's a very difficult thing to do, but, you know, that it would be lovely to do that. Did that answer your question?
Yes, thanks. Thank you very much.
Great.
Dr. Portnoy?
Great, thank you. Gosh, I was on the allergenic extracts committee back in the 1990s, and this conversation sounds exactly the same as it was back then. I'm really glad that we're finally moving forward with new technologies, but we were discussing the option of using this ELISA-based approach back then. I'm just kind of curious to know why we suddenly decided to just go ahead and go with it, as opposed to just waiting the last 20 or 30 years like we have. One of the discussions back then, as was just brought up, is that there are more than one major allergen, perhaps FeLD1. A lot of people are allergic to that, but I have patients who are not allergic to FeLD1. They're allergic to some of the other cat allergens. I was just wondering if you'd had maybe some consideration to measuring several of the major allergens rather than a single one, and maybe labeling the extracts.
Yeah, thank you. That was the second part of the previous question I forgot to ask. And, you know, reviewing the literature, and actually Tom is on the line, because some of the literature is Tom's literature in a recently published paper of his. And Tom, you can remind me, I think FeLD4 is one of them, but there are a few other allergens that from cat that have that are turning out to have some importance to a subgroup of patients. I think that that is something that ideally would be great to do with these assays, and we can actually, the way to do them might be to apply the mass spec, the technology that we'll be talking about in my second talk, to them. I think it's not a high priority. We have to pick our battles, you know, that what we have right now with ragweed and with cat are sort of good enough, okay, to keep them going and move them forward. And there are things that, you know, I really want us that are higher priority, like the foods, to push forward. But I think that you are really correct. This is, you know, it's something that I've begun to appreciate mostly, I would say, in the past month and a half in preparation for this meeting, that some of these so-called minor allergens in cat and perhaps even in ragweed are not so minor after all.
Well, particularly like with peanut, because when you look at it in vitro assays, we can measure components now and actually figure out which allergens the patient is allergic to. Are there any thoughts given to maybe comparing the potency of these extracts with the results of in vitro tests? Because it would be nice if they correlated more effectively.
Yeah, so that's kind of the dream, and it's more relevant. And I think, you know, how we would do that is, you know, if you'll hold that question for the next talk, you'll see how we're thinking about it in terms of that. And we're thinking about it more in terms of these really, you know, complex allergen extracts like house dust mite and alternaria. But the idea of circling back and applying them to something like cat is certainly a very good one. But I would appreciate if you would just hold that thought and sort of allow, and so that we can just focus on the first two questions here. Okay.
My last question is, how do you plan to calibrate these results? Are you going to use purified allergen or recombinant allergen? Or what are you planning to use?
Yes, the reference reagent will be purified FeLD1. There will always be an extract that will serve as a positive control and a quality control, a reference extract, you know, for which the results will have to be within some window of potency, you know, that will either, you know, validate or invalidate, you know, that particular assay, right? You know, so you have a quality control. So that is how we intend to do it for these major allergen assays. Yes.
All right. Thank you.
You're welcome.
Dr. Paul Greenberger.
I think you're still muted, Dr. Greenberger.
Yeah. Please unmute.
Pardon me.
Okay, now we can hear you, sir.
Thank you, Ron. I think I just want to make a first comment. Priority is going to be so important. You used the word, but to limit the array of testing and possibilities until the methodology is confidently proved. So, and I want to make a comment regarding what Dr. Rubin brought up about what I interpret as heterogeneity of the IgE responses. That's certainly known for ragweed, for example. Not everybody with clinical symptoms reacts to the major allergens, so that's crucially important, and I think that's would extend to virtually all the allergens.
I think you're right, and I think we really began to appreciate that now. But I think, I mean, yes, I agree with you.
And my question was, are you able to share with us what ELISA assays you've got operational, or what's your
right now we've just got, we really have the cat. You know, we haven't moved out anything further. We don't have the reagents for the eptamers yet. So, you know, the cat and the ragweed are, you know, that's the first thing. We got to replace those so that we can discard the RID. Once we're doing that, and particularly if once we replace the biologist who retired, we'll have somebody whose attention is turned to this. Then the question is tackling the next sets of allergens. But these licensing deals, are not pocket change. They obviously they cost some money. So we really only approach companies about working with their reagents and licensing them when we're ready to move forward with it. So we haven't gone further until we get this CAT assay down, to really what it needs to be.
Do you need help to set up your assay? It sounds like it.
No. Well, we need we need a full complement of people in the lab. We need that. That's what we need right now. And but as far as intellectually or operationally otherwise, we have the tools. We have the people who know how to do this. We have access to a great support from Dr. Hamilton at Hopkins. We have, who's a fountain of advice. And really, anyone in the community, particularly the food allergy community. I mean, they're always available for advice. So, it's just really people, a person whose job will be to move these assays through, to make us into a little assay factory. That's the plan. And we are fully capable of doing that.
Thank you.
You're welcome. Thank you.
Dr. Omer?
So, first of all, I think the overall approach makes a lot of sense. But I do have a couple of questions. You described the pathway for qualification, validation, and technology transfer. And the qualification step is pretty important in that pathway. Could you elaborate a little bit more on the statistical approaches that you allude to, like specifics of that, because that's kind of important, especially for these kinds of, approaches that you're proposing. So if you have that information, go ahead.
No, no, I have statisticians who have that information. And I know they know their stuff because they work with us when we evaluate, INDs and BLA supplements, when manufacturers are doing assays. I know that the relevant document is ICH R2, I believe. But I think I would be well outside my lane to start commenting on how the actual statistical approach is done. I'm sorry. If you want to shoot me an email at ronald.raven@fda.hhs.gov, I can forward it to my statistical colleagues, and they can give me a couple of paragraphs to send you back. I'm happy to do that. But I don't want to comment here. Okay.
The second question is, of course, given the relatively limited experience with the DNA aptamers, are there any safeguards? What are the specific safeguards in place or will be in place to ensure reproducibility and stability of these aptamer-based assays over time and across different entities?
Well, I think that we have to develop a stability protocol for that reagent like we develop for any other reagent. I have to say I haven't given it a single strand of DNA is an extraordinarily stable, molecule. But obviously, we could have it made with, some PCRNs, and we can do something like, take it out of the -80 and make sure that a PCR is up appropriately and focuses on a gel. And I mean, those sorts of things, I think that, we do that with all our reference reagents, and reference reagents, of course, have to be checked for stability like everything else. So I haven't given that a great deal of specific thought, but I don't think that that's an issue that is going to be difficult to deal with. I mean, my experience with these reagents are even monoclonals. My background is on flow cytometry. I used to do a lot of flow. I mean, just tons and tons of flow. And I remember getting vials of lyophilized monoclonal antibody that were literally 20, 25 years old that I would put into solution, and they would work absolutely perfectly on flow. It's kind of remarkable. And I don't think it'd be any different for DNA. So next question, please.
Yes, Dr. Meyer.
Thank you for that interesting talk. I know you're really focused on kind of the biological appropriateness of these methods for the voting questions, but for the completeness of the discussion, I was wondering if you could comment on any impacts that there would be on the consumers, so like the allergists using these products. If there was a transition made, would there be any supply chain issues? Would there be any changes in costs that might affect people's ability to use these products, those types of more implementation aspects?
Sure. So let's just answer it for the ragweed and the ELISA. For the ragweed and the cat, what I would anticipate is that we would bridge the, we would, as we move, have the new assay, we would bridge, with the old unitage with the new unitage and drop the old over time. That's what I sort of imagine. I don't see that as being any increase in cost or any effect in cost. I mean, the manufacturers will be speaking to that, of course, because they're already doing an assay, so now they're just going to do a different assay, and the different assay is easier and less time consuming than the first assay. So I don't see that as affecting it. As far as the additional extracts and, and using the technology that I've referred to today that we've spoken about so far, I just want to remind you that we supply, the major cost is incurred by the taxpayer. It's incurred by us because we purchase these reference reagents. We distribute these reference reagents to the manufacturers at no cost. That means the monoclonals or the aptamers, we've paid for their design, we've paid for them, we conjugate them, we distribute them. So their cost in materials is an ELISA plate, a secondary antibody, and an enzyme-linked IgE, or in the case of the aptamers, it'd probably be Avidin, right? The top aptamer would be biotinylated, maybe, and then a bunch of buffer and doing these ELISAs, and I don't perceive that as being a huge issue in human power in hours and time, but so of course I've been a government employee just about most of my professional life. I've not been in private industry, but I don't perceive it as being a big roadblock myself. I suppose that there might be some lots that would have to be rejected that don't meet a potency criteria, but it's not as if the source materials are rare. It might mean that you have to start with 2 bags of peanuts rather than 1, or something along those lines.
Okay, thank you. Dr. Platts-Mills?
Mute. Thank you. Ron, you mentioned oak and birch and the comparability between them, and we had some very interesting.
Excuse me, I'm sorry. We will not be able to have questions or comments from Dr. Platts-Mills because he is, I guess, speaker for this meeting. So
I beg your pardon. I will hide quickly.
Thank you.
I think
Tom, you know, I'm always interested in what you have to say, and we can talk later. I'm very interested in what you have to share.
Okay.
Let's
I think
go
we're
ahead,
allowed
please.
to take questions from Dr. Assad. Dr. Assad?
Yes, thank you for your presentation, Dr. Rabin, and thank you for taking my question. I have a few questions. First, as Dr. As Jay Portnoy mentioned, ELISA has been around for a long, long time. And what we're proposing now is to almost use an old method. But I mean, you're still using an old method with a little bit of new reagents, which are your monoclonal antibodies and your aptamers. But we are still stuck with the lack of biologic significance of the amount. So if I understand correctly, you're either going to use your monoclonals or you're going to use your aptamers for various allergens, and at the end come up with a quantitative assay. So it's going to quantify how much there is of this allergen in this milliliter, microliter, whatever. That's correct. Okay. But the previous allergenic assays also included how the human person responded, which were those skin tests, intradermal tests. We're not going to do this now again. They seem to be yeah. But my question is, because there are newer ways to measure the human response to these allergens, like the BAT and the MAST and all of these, can we pair this measurement that you're proposing with other measurements that not only measure quantities, but quality and function?
Okay, so let me address the premise of your question first.
Yes.
Again, for these assays, okay, the ones that I've discussed so far, particularly the CAT and the ragweed, they've been assigned the BAU values, but the BAU values were considered as a translation of AMBA1 units and FeLD1 units. The data that even quantified I'm not sure where the AMBA1 unitage came from. I mean, these were done years ago, and the literature, I mean, you know, where it's discussed is in the textbook. But to my knowledge, the manufacturers don't even use a BAU unit with AMBA1. With the FeLD1, it was an abstract. You know, and, you know, reading the abstract, they might have only tested one person. Okay, I'm not really certain how many people they did. And it was really a translation of the number of units of FeLD1 or AMBA1. So I don't consider, reviewing the literature and having put a lot of thought into this, you know, that the relationship of BAU to concentrations of FeLD to the allergen potency, the total potency of a cat extract, hair or pelt, or a ragweed extract is as tight as it is, say, for the grasses. Okay, you know, for the grasses, you know, it's been done. It seems to be reliable. We've never had any issues with it. I don't think that the relationship between that BAU unitage and those two particular extracts is as tight, okay? Now, the question of whether or not we would tie these to new assays and how we would integrate them into something like a BAT or so forth, I guess I would have to think about that. I guess I would have to, you know, I haven't given that much thought. You know, I've sort of, you know, you can be a lumper and a splitter, and I've been a bit of a splitter here to say that there are certain allergen extracts that have 1, 2, or maybe even 3 major allergens, and we can really work on that, you know, that you quantify these 1, 2, or 3 major allergens. You pick one as a release criteria because you can't continue to stack release criteria. And then you look at some that are just too complex for that. And for that, we have an alternative approach that we haven't discussed yet. That's kind of where my thinking is, but you know, I hear what you're saying, and it's worth some thought, but I'm not gonna, I can't give you that any more than that, you know, off the cuff.
Well, thank you for considering. The other question, and I know we're not discussing peanuts, for example. We're not discussing other allergens, but using
we're discussing peanuts. Yeah, we intend to do this for peanut. Yep.
Okay, perfect. So peanut allergy is related to the components of peanut, as you may very well know. But the allergy changes by age. So most infants are positive to RH2. Some may be positive to RH1, but most are positive to RH2. When you get to the teenage years, they are positive to RH9. And when we started measuring RH6, or the company made it available, RH6 seems to be highly associated with anaphylaxis. So how are we going to solve this conundrum of the different, you know, how are you going to standardize that peanut extract to be of maximum usability in a year-old versus a teenager versus an adult? Okay. Just creating more problems for you, Dr. Abel.
So so that's a complex, that is a tough question. And, you know, and I've certainly, you know, I've begun to think about it. I've had, you know, I was actually talking with Gideon Lack about it a few days ago, and, you know, and we were talking about different possibilities. I think that we are aware that that is a tough question, and we have to find some middle of the road of something, you know, where the perfect cannot be you know, the perfect is the enemy of the good, right? We have to come up with something that gives us you know, some sense of a reliable, consistent product, you know, without putting too much stringency on it. And, you know, that the manufacturers, A, you know, will not want to release it, or B, that they can't make, you know, lots consistently that they can release. And I think that there are different ways of doing that. Again, in the interests of sort of expedience and wanting to get these food allergen extracts standardized to some extent, we're probably just going to have to pick, you know, we're going to have to pick and choose. And, you know, I would not do that without consulting with, you know, the experts in the field who are, you know, who are available to us to advise us on that. You know, as to addressing the complexity of it, if you want to really consider that peanut is a complex extract, then, you know, as soon as we're done with this Q&A and we launch into the second part of the presentation, I think you'll find that very interesting and hopefully exciting.
Okay, just one last part to the question here. Are you at some point going to release, or other manufacturers going to release, an equivalency between what they've already had on the market and what now will be standardized? Because practically speaking, for skin tests, for environmental allergens at least, and the use of the allergens, and I know we're not discussing using them as therapies, but for allergy shots or allergen immunotherapy, this becomes a major problem. How to?
Yes.
Yes.
Yes. I wouldn't be surprised if if one of the consequences of standardizing, non-standardizing extracts is that what we have overall is a higher potency extract that has than one that has been released in the past. And I think that that will require some education and communication with the healthcare providers, that when, these come out in their standardized forms, as you know better than I do, because you take care of patients, that when you change from one lot of an extract to another, you should dilute that second extract, by at least, 1 to 2, for safety reasons, because potencies can vary even that much among standardized extracts using the available tools that we have. And it may be that they just need, they really need to go down a lot less. It may also be that we could do, some sort of in vivo testing to kind of get an idea, because since these really haven't been standardized, nobody really, what is the best concentration? What's the ideal concentration? If it's too concentrated, as Dr. Lack reminded me, you could end up with false positives of peanut allergic. You don't want that. Obviously, that would have a major impact on somebody's life to errantly inform them that they're peanut allergic when indeed they're not. And so these are things that we are going to have to deal with. And I am grateful for your questions. And I assure you that we are cognizant that what we are doing here is more than just, making an ELISA and saying, have at it.
Great. Thank you.
We are running a bit out of behind. If the questions can wait, because Dr. Raven is going to give another talk right now. What do you think, Drs. Davis and...
I think that our next talk is, going to be a little bit shorter than the time allotted. I would really prefer that we allow Drs. Dykowitz and Davis to ask their questions now, if it's all right with you, particularly since we started early.
Sure. Dr. Davis.
Yes. Thank you, Dr. Raven, for your presentation and all of your work to try and move this forward. Given the fact that that we've been using these extracts, as you mentioned, for 100 years, and now Dr. Portnoy mentioned that we've been talking about ELISA for 20 years. I do believe this, any advancement is going to be helpful. I want to comment on the consumer and really in your thinking about how to move this forward, because of course you would like for it to benefit the patients and the providers. I believe that validation of potency is going to be a critical issue. And we have standardized products now, but in practical application, much of the concentrations aren't really utilized. It's really the potency when therapy, is the extracts are put together for the patient. And so, and similar to Dr. Assad's point, there's going to need to be some kind of validation of potency or what's happening in the patient, I believe, before the standardization is going to be accepted or used by the consumer. So I would just really urge you, as I've heard your other comments, to really to keep this in mind and really make sure that this happens. I do believe, as you mentioned, that there are two things that are true. One is that minor allergens and major allergens all play a role, but you have to start somewhere. So I that I just wanted to state those things. And my question would be, given the fact that it is going to make a difference on the consumer, Would you be open to expanding your thoughts regarding this validation of potency as you seek to standardize?
Yes. Well, I've heard the message loud and clear. I think I can say that I've heard, we have come to the committee for your advice, not simply for your approval, if you will, but we've come to you for your advice, and we've gotten some very solid advice. And of course, I'm a member of the standardization committee at, in Quad AI. Every year I've gone to the meetings, I've gone to them, and I can, and they are, a potential source of wisdom, for that. Paul Ehrlich, the meetings the triennial regulatory meetings in Germany has its own standardization committee. And so I think it's very clear that we need to seek some outside advice. And we have those people available to us. And, you are the president of Quad AI, so I could flip it around and say anything that Quad AI can, or the incoming president, if you will, and anything that you can do, we could seek advice from this respected organization, and we will incorporate that into our plans.
Wonderful. Thank you so much.
You're very welcome.
And the last question comes from Dr. Dykowitz, and just want us to all be cognizant of the subsequent topics, because they may touch upon what the questions are.
Thank you very much for the presentation. I'll try to be brief. I'm thinking about this is a very logical approach, particularly in terms of being able to identify not just several major allergens, but minor allergens that might be present within commercially available extracts. But what I could also envision is that there might be some challenges where you have an extract that traditionally we've just viewed for one particular major allergen, but then the other major allergens or minor allergens might vary considerably between different extracts. And I'm trying to think from a clinician standpoint, for instance, if we're talking about using these extracts for treatment with subcutaneous immunotherapy, how we might reconcile that. Do we envision, for instance, that there would be some consistency expected from manufacturers, that there would be not only some consistency with the amount of the major allergen, but consistency over time or over release of lots of what would be, shall we say, secondary allergens?
So I think the answer is that we have to see, since we've not been measuring multiple allergens in an extract at the same time, I don't know what's realistic, what we can realistically expect. And again, Mike, ideally, I would love that. Ideally, I would like to see for some of these products, that you have one, maybe two max proteins that are release criteria, and that then, in the particular lot, what else is in them is listed, and, and then that can be matched to a component resolved analysis that somebody, that you get through, some of these new chips, like the Alex chip or whatever, and you can say this extract is better than that extract. I think the first thing, we're going to have to learn a lot as we do this. And as we do this initially, the most important thing that for me to consider is that I do not want the perfect, to be the enemy of the good. We got to get something out there where we can say that we have some standard of quality, and we have to do it in such a way that we say that now that we have a standard of quality, we also have the tools to learn a lot more about this particular product, and we have every bit of license and authority to improve that standard of quality as we learn more and more information. So this is not an endpoint. It's a beginning. It's a new thing. We're changing the way we do things. And we're going to change the way that we do things as we continue to change the way to do things to get the best products out there. That's the best I can answer your question.
Thank you.
All right, thank you everyone for this very engaging discussion. The next talk is also by Dr. Rabin, use of tandem LC-MS to measure potencies of complex extracts with multiple major allergens. Use of HDM bodies and fecal pellets as source materials for human dust mite extracts. Dr. Rabin.
Well, thank you very much for staying with us so far, staying awake. And we'll move on here. And so the part here that we're going to talk about is related somewhat to what we've already discussed, because the question of what the delineation of a complex allergen extract is obviously a bit of a moving target, based on the current knowledge today. Okay, next slide, please. So the desired outcomes here are to talk about an updated methodology to better characterize complex allergen extracts from relevant source materials to improve product quality. Excuse me. The problem statements are current methods are outdated, do not adequately assess complex allergen extracts, and that source materials may not represent clinically relevant allergen exposure. Next slide, please. And so the voting questions then will revolve around, and we're going to try to stick to one term here, but we're talking about what's called tandem mass spectrometry, which has also been called LC-MS analytics to improve product quality. And then we were going to talk specifically about house dust mite material, source material optimization. Next slide, please. So I'm going to remind you, if you will, of the existing standardization method for complex allergen extracts and its limitations. The surrogate extracts, again, the surrogate assays, again, of these do not detect compositional differences among extracts for different manufacturers or lots among the same manufacturer. And then we're going to discuss the LC-MS as a transformative platform that enables comprehensive proteomic characterization and how LC-MS or tandem mass spec can reveal potential for improvements in manufacturing methods for complex allergen extracts. And I'm going to point out to you that I'm not going to be giving the bulk of this talk. The bulk of this talk is going to be given by my colleague, Brad Strader, who is really an MS, expert. For me, it's a black box. But so Brad will discuss that part for you. Next slide, please. Just to remind you, there are 19 standardized extracts, hundreds of non-standardized extracts. Last talk, we discussed extracts on the right side of this now, and on the upper right quadrant, if you will. And now we're going to address one of the non-standardized extracts, but also the house dust mites. Okay, we're not discussing the grass pollens, so just the house dust mite. Next slide, please. Okay, just to remind you again that this was the ideal testing that was used on highly allergic individuals. They would do serial threefold dilutions. They would come up with a number, a sum of the orthogonal diameter of the erythema, of the redness. We would arbitrarily call that 100,000 BAUs. The surrogate assays, the competitive ELISA. The ELISA works, but it doesn't detect compositional differences between extracts, may vary because of differences amongst donors. And these things rely on two assumptions. Extracts from different manufacturers are qualitatively similar, and allergic patients react similarly to the same set of allergens. Next slide, please. I just want to show you that sometimes ideal testing doesn't work. And this was a study that was done a number of years ago, I think about 10 or 11 years ago now, by my colleague Jay Slater and really by the NIID Inner City Asthma Consortium, where they were wanting to standardize cockroach allergen extract, and cockroaches are a serious problem, you know, of hypersensitivity in inner cities. And here what we have are 8 of these ideal 50 plots from 8 different individuals. And on the x-axis of each one is the dilution of the extract, and on the y-axis is the sum of the orthogonal diameters. And then you see 3 black lines, you know, dotted or solid or whatever, on each of the plots, and those represent 3 products from each of the one product from each of the 3 manufacturers of the extract. And what you could see very clearly is that while the patient on the lower right-hand corner might have had a nice ideal 50 kind of response that they would hope to get, nobody else really did, and they are all different from each other, and there was really, you know, no consensus that they could come up with to use this particular method to assign for overall potency. So it just simply did not work. So it has its limitations when these assumptions about equivalence of response or equivalence of qualitative equivalence of products fall through. Next slide, please. So the data that Dr. Strader now is going to take you through is going to address the LC-MS/MS analytics to improve product quality. And so I'm going to step aside. Thanks. Okay, next slide.
Okay, thank you very much, Ron. So what is mass spectrometry? Well, liquid chromatography tandem mass spectrometry, or LC-MS/MS, is an analytical method utilized to generate peptide fragmentation spectra that are then used for qualitative and quantitative information. And so in our lab, we use LC-MS/MS, which I'll try to refer to as mass spectrometry, to quantitatively compare the complex mixtures of samples that include, say, source materials or allergen extracts to characterize the proteome. And what I mean is we can do this to quantitatively compare the relative abundance of proteins in different samples. And we can also use this towards characterizing the allergen profiles in these different sample types. That is, what is the relative abundance of allergens in one sample source versus another? And thirdly, this is a method of discovery. It allows us to identify proteotypic surrogate peptides that we can then utilize for absolute quantification. And so what I mean by surrogate peptide is a surrogate peptide is a peptide that's exclusive to, in our case, the allergen of interest, and it is reproducibly and reliably seen in all our sources. And also, it has a good signal and is resistant to modification. And so in our next step of our mass spectrometry strategy, we will be using parallel reaction monitoring for absolute quantification. And in this strategy, we use these surrogate peptides as standards. We isotopically label them, and then we use them by spiking them in the samples that we're studying. And by that, we can then generate calibration curves that allow us to calculate the absolute concentrations of the allergens we're interested in. And because we're measuring absolute concentration, we're measuring potency, and therefore, we can use this as an assay for promoting manufacture of extracts that are specific, potent, and consistent. Next slide. Next slide. Okay, there. Okay, so this is a typical workflow for mass spectrometry. You reduce, you alkylate your source, your complex mixture, and then we proteolytically digest it. In our case, we're using trypsin to produce peptides. And so these peptides are then loaded onto a C18 reversed phase column configured with an HPL system that is coupled online to a mass spectrometer. In our case, we're using a Lumos tri-bit Orbitrap mass spectrometer. And so during a mobile phase gradient, when we're performing a data acquisition, peptides are eluted as a function of hydrophobicity. And as they're eluted off the column, they are electrosprayed at the front end of the instrument, and then they're fragmented in the mass spectrometer to produce tens of thousands of MS-MS spectra. And these MS-MS spectra are what give us the information. They are then searched bioinformatically using proteome software to generate qualitative and quantitative information. Next slide. And so before I talk about Alternaria alternata or the house dust mite data, I just wanted to show you this slide that our lab published in 2017 by my colleague Samuel Medaille. And here we see a plot of the absolute quantification analysis of 5 separate German cockroach allergens that was measured over 4 different days. And what this figure really demonstrates or illustrates is it shows the precision, the reproducibility, and the linearity of this technology over a large concentrational rates of 6 orders of magnitude. Next slide. Okay, so I'm going to talk about Alternaria alternata first. So Alternaria alternata is the most commonly associated mold with seasonal allergies. Now, it's a plant pathogen, and so it's mainly found outdoors, but it can be found indoors under poorly ventilated conditions or conditions where we have an excessive amount of moisture. And spores are released late in the summer during the dry part of this into summer. And there's been shown to be a correlation with the summer release of spores and these seasonal allergies. So here we see a picture of a common tobacco plant infected with Alternaria alternata. And we also see here an infestation of Alternaria alternata in a room. Next slide. Okay, so it's important to remember the proteome is dynamic. And so it's dependent upon the developmental stage, such as these different life cycle stages in this for mold, as you can see here in the lower right-hand panel. It's also it's also dependent upon the structural origins and can be impacted by the growth media. Next slide. Okay, and so up until this recent publication in our lab, we didn't really understand the allergen profiles for these individual life cycle components. We just didn't know which of these life cycle components the allergens were more prevalent. So today I'm going to talk about this study where we actually used our MS-MS quantitative strategy to compare the proteome and allergen profiles for hyphae, non-germinating spores, and spores. I will also, in the study, we also did a comparison of 3 individual allergen extracts from U.S. manufacturers. And I just want to say that the information that we obtained from this study can be and should be used towards improving manufacturing quality. Next slide. Okay, so we used visualization techniques to count spores and to determine the sample integrity and identity of each sample component type. Each life cycle component source was then pulverized with a mortar and pestle, and then we extracted the proteins using organic solvents. After the protein extraction was finalized, we then utilized SDS-PAGE to confirm that we had suitable extraction and complexity for downstream mass spectrometry analysis. Next slide. Okay, so in our study, we did 2 separate studies using a total of 6 biological replicates. That's 3 replicates per study. So here you can see that what's important in this slide are the numbers. And so for study 1, we found 3,906 proteins, and in the second, we found 3,885. And you can also see from the Venn diagrams that there's similar numbers between the distributions of different sample types. And so what's important here is the consistency. because the similarity between these numbers show that we were consistent in our sample prep procedure as well as our analytical technique. And this is an important critical confirmation step if we're going to use this information as a regulatory guide or a tool. Next slide. Okay, so as I said, one of our major goals in the study was to compare the allergen profiles for these different life cycle components. And so here we see two volcano plots. And volcano plots are a two-dimensional way of plotting the fold change differences for those proteins found in both sample types. And so for the left volcano plot, we see the comparison between hyphae versus spores. And in the right volcano plot, we see the comparison between germinating spores versus spores. And what is apparent from these studies, and these volcano plots represent our study 1, is that most known allergens were more prevalent in non-germinating spores. And to our surprise, the major allergen, Alt-A1, was largely secreted and was found abundant in the spent media that was used to culture the mold. And it was near the limit of detection in these source materials. And so I just want to point out that we're actually using this information to identify those surrogate peptides that we plan to use next in our absolute quant method for parallel reaction monitoring. Next slide. Okay, so for the commercial allergen extract comparative study, a total of 3 separate lots were analyzed for each commercial vendor for a total of 9 separate samples. And so using the same strategy, a total of 672 proteins were found in all 3 studies. And what we found in the study was most of the known allergens were not detected in ALK or jubilant Hollister-Steer samples, and only a few of them, or a small fraction, were found in the Stollinger-Greer samples. Another thing that we noticed was that there was major variation between individual lots for each of the vendors. And so these high coefficient of variation numbers clearly show that a standardization method would improve the manufacturing process. Next slide. Okay, so now I'm going to talk about some studies we did toward house dust mite source material optimization. Next slide. Okay, so house dust mites are ubiquitous in the Northern Hemisphere, except for cold, dry climates. House dust mite allergens are often the first respiratory allergens encountered by infants and are considered initiators of the allergic march from allergic rhinoconjunctivitis to allergic asthma. Now, house dust mites eat epithelial shed from humans and their pets and live in upholstered furniture, carpets, and bedding. And it's been actually estimated that 10% of the weight of a 2-year-old pillow is made up of mite bodies and feces. Next slide. House dust mites are coprophagic, and their fecal pellets are structurally organized and contain digestive enzymes so that food within the ingested fecal pellets is absorbed for nutritional benefit. Now, the fecal pellets are particularly important because these digestive enzymes are also allergens, and because unlike the bodies, they are small, and so when they are inhaled, they actually make their way deep into the lower respiratory tract. So, as Ron pointed out earlier, house dust mite allergen extracts are standardized for overall potency, which implies that they are qualitatively similar. However, the method of culturing house dust mites may differ among manufacturers, and thus their allergen extracts may qualitatively differ. And another issue with house dust mite extracts is the source material. As a consequence made after a meeting of the Allergenics Product Advisory Committee in 1987, it was decided that house dust mite extracts were derived from mite bodies, exclusive of the fecal pellets. However, in the last 35 years or more, it has become evident that the fecal pellets are an important source of house dust mite allergen. Next slide. So we used the same mass spectrometric strategy used with Alternaria. which was to make extracts from two source material components. In our case, we made extracts from fecal particles and house dust mite bodies. And we also included in the analysis house dust mite extracts from Stallinge's Greer. Sorry about that. Okay, so in this study, where we used 3 replicates for each sample type, we identified 1,411 proteins. And what's really interesting was that from the feces proteome, 7% of all ion current matched to peptides belong to known house dust mite allergens, which implicates or indicates clearly that these allergens make up a substantial amount of the proteome. They are relatively abundant. And also, this was over twice what we saw in the body's extract and over 3 times what we saw in the house dust mite extract. When we plot the allergen ion current values, the pie charts show how the distribution of abundant changes for each sample. So there's clearly a change in how these appear depending on what samples you look at. So what is in, next slide. Sorry. So what is important is that a relative abundance comparison for these allergens show that the feces extract is enriched for several allergens, including the major allergens DARP1 and DARP23. And interestingly, DARP2 was equally abundant between all samples. And there is some evidence that the bodies does enrich for certain allergens. But what we can say about the pie chart and this table is that these data collectively show that house dust mite extracts can be improved by including the fecal pellets as source materials. Next slide. And so before I give over my summary slide, I'd like to make some acknowledgments. I'd like to acknowledge everybody that I work with, of course, Jay and Sam and Daye and Kavita, but I also wanted to mention Philippa Hillier and Andrew Freeman, who played a substantial role in the house dust mite project. And I'd like to thank my collaborators from Portugal for their efforts and help in making the source materials we used in the Alternaria alternata study. And so the next slide. So I'd like to summarize by saying that what we've said today is that mass spectrometry is precise, it's accurate and reproducible for qualitative info and identifying surrogate peptides that can be used for absolute quantification. And I mentioned that parallel reaction monitoring with these surrogate peptides would be an ideal way to measure potency, and therefore this can be used as a potency assay. Now, when used to improve product quality, CBER's reference reagent lab will transfer technology and reagents to the manufacturers for lot release. And so I also said that mass spectrometry can guide manufacturing of complex extracts. And we demonstrated that today by showing that you can actually improve Alternaria alternata extracts by increasing the ratio of spores. We've also shown that you can improve house dust mite extracts by including fecal pellets. And finally, this is a mature technology, and mass spec and parallel reaction monitoring are already used in the industrial in industry, and they are now suitable for promoting manufacturing of extracts that are specific, potent, and consistent for allergenics. And with that, I'd like to thank. Next slide. Oh, next slide. Sorry. Yeah. Okay, so now I'd like to read the questions. So the questions that we will be discussing is question 3, LC-MS analytics to improve product quality. Does LC-MS technology compare with the currently used analytic technology, provide sufficient fit for purpose analytical capability for better characterization of complex allergens extracts to improve product quality? And question 4, house dust mite source material optimization. Do the available data support inclusion of both house dust mite bodies and fecal pellets as source materials for HDM allergen extract to more adequately mimic clinically relevant allergen exposure. And now we can take questions.
Thank you so much. Please use the raise hand function for questions you would have for our speakers. Dr. Rubin.
Thanks a lot for that presentation. I'll get video. There we go. I have a technical question and a separate question. The technical question is there allelic variation among the allergens that you're looking at that could affect the peptides that you're measuring? In other words, could the PRM not work because you would have a different peptide, a different peptide mass? The second question is there you're focusing on quantitating the major allergens, but is there a lost opportunity here because you also get for free the quantitation of anything else? So it is an opportunity to measure purity at the same time that you're measuring the amount of the major allergen. Thank you.
Well, thank you very much for your question, Dr. Rubin. First of all, that's a really good question. And the whole success of a MRM or a PRM strategy for absolute quant with mass spectrometry is how you select your proteotypic peptides or your surrogate peptides. And so one of the things that we try to do is when we look for peptides that are exclusive to our allergen that can serve as a surrogate, is we try to avoid peptides that are amenable to modification, such as oxidation or methylation or any kind of post-translational modification.
Or an amino acid substitution.
Well, I mean, yeah. So, I mean, yeah, the idea is that we want to find peptides that we reproducibly identify in multiple samples that actually are exclusive to that protein. And of course, if there's an amino acid substitution, you miss it, but that would be an isotype. And what was the second question is that, the good thing about this technology is that you can quantify multiple allergens simultaneously because you're using a mass spectrometer. You can design PRM or MRM assays to look for, where you actually quantify and spike into your sample multiple peptides representing different allergens of interest. And then you can use the same data acquisition to quantify those allergens against their absolute quantification. So this is one of the reasons why people are moving towards this type of technology.
It is our intent.
That's our intent.
It isn't our intent to measure multiple allergens. That is the beauty of it.
Absolutely.
Thank you.
No problem. Yeah. Next question.
Dr. Davis?
Thank you. Yeah, thank you for that presentation that I think has just a great deal of promise. And as you mentioned, detecting several allergens and doing it in a more standardized way. I have two questions. The first is that I noticed in the mold extract evaluation alternaria that even though Hollister Steer and Auk had a better quantification of AMA, or Alt A1, the major allergen, they did not have these minor allergens that Greer extract had. And I wanted to understand what you think is the reason for that, if it's actually the technique, the spore versus hyping, and if you think that this is going to have implications for manufacturing. I think you alluded to this and what those implications are. And then my second question is with regard to cost. So ELISA typically per sample $5 to $20. This LC MSMS probably more like $40 to $200. Do you think that is it feasible financially? And do you think there'll be any pushback from manufacturers to this kind of assay?
You take the first.
Okay, so So yeah, so about the commercial allergen extracts. When we did this source material analysis and we saw that the allergens were enriched in non-germinating spores, it became clear to us that that's where you want to go. And I think one of the things that's problematic is that there's no standardization of these extracts, and so while they might be, they're just adding spore and hyphae without any emphasis on,
to our knowledge.
To our knowledge, yeah, I just heard him whisper. To our knowledge, we don't know exactly what their ratio of spore to hyphae is, but I think it's clear that they would benefit substantially if they increase their ratio of spores. And so that's one of the things. Do you want me to try to answer it?
No, I'll answer the second one. I think you're going to hear from the manufacturers, and yeah, it is. There are two different approaches. Ironically, I would say that that the reason how it came to be that we brought this technology into our lab and considered it as a regulatory tool actually happened. Oh, it was probably 12, 13 years ago when I attended a meeting in Cuba, of all places, and one of the manufacturers presented data in which they were using this technology to, as quality control or to assess their allergen extracts. I mean, that's how I learned of it, and that's how it was brought to our lab. But yeah, I mean, the technology costs a lot of money, and it would cost a lot of money, and you're right, maybe it would cost $200 or $400 to contract it out, to have somebody else do it. I don't know how much that would cost over a lot of, how much that would increase the cost over a lot of extracts. Again, here you do have a substantial investment in equipment and if and somebody who knows how to use it if you're going to do it in-house, so that's a big deal. The heavy label peptides are not a cheap item. They're and again, we supply the reagents. But yeah, I think you might hear from, when you hear from the manufacturers, you might hear some pushback about that with regard to price, but they'll be getting their talk, so you can ask them directly.
Can I have one thing?
Yeah, go ahead.
I think, everything he said is relevant. I just want to say that a majority of the cost probably would be upfront, getting the instrumentation or deciding whether or not you wanted to work with a contract company that specializes in this. But the payoff is once you've developed your PRM assays, the efficiency is really good. And so you can get a turnaround quickly.
Mm-hmm. Yeah, thank you for answering those questions. I think that there's an opportunity there for potentially one provider of LC-MS to really service, the few manufacturers of this worldwide. So.
I would think so too.
Mm-hmm. Next question.
Thank you, Dr. Omer.
Yeah, so I want to know a little bit about the global alignment aspects of this. So are there any precedents from WHO or European reference labs that support the dual source HDM extracts? And equally importantly, how would FDA's adoption interact with these standards?
So to my knowledge, the answer is no. What I can tell you is, when we took this project on, with the eventual goal of incorporating it into the regulatory atmosphere, we did so as a collaboration with Paul Ehrlich Institute in Germany. And in fact, one of their fellows was here with us for a few years. Unfortunately, they've sort of dropped the project for reasons that we're not certain, but that everybody's got to make those choices. This is something, as far as the global aspect of it, what I can tell you is that that is addressed. So there is you may not be familiar, there's a triennial meeting called the Paul Ehrlich Seminars in Germany. It's a very unique meeting and that is really centered around the regulatory aspects of allergen extract, manufacture and distribution. And so, regulators from all over Europe are there. Of course, we've traditionally gone to those meetings and participated in it. I'm on the scientific board of it and so forth. And then there are some academicians as well. And there is always a meeting of a standardization subcommittee. And the last meeting that we had was heavily discussed about mass spec. So there's an interest to this, but it appears right now probably that we are going to be the pace setters on this, and which I'm actually quite proud of, And my guess is that when we do these things, that the Europeans will follow us. And that's okay with me.
All right.
Next question.
Dr. Assad?
Yes, thank you. Thanks for the presentation. So my question is, since all this is done for the purpose of standardization, at the end of the day, once you do your MS and find the percentages of different allergens in different parts of Alternaria and in different preparations or extracts from different companies, how are you going to determine the optimum?
Yeah. Yeah, well, that gets back to the conversation that we had previously. I mean, I think we really have to consider the optimum, what the optimal quantities are, that as we solve one problem of deciding what the minimal requirements of a particular extract would be, minimal release criteria will be, we're going to have other problems as to what it actually means to standardize these. Does it, are we standardizing them or are we characterizing them? If you're accepting a certain level of heterogeneity, you can't really call it standardization. We might have to come up with a different word for some of these things. I think these are problems that we anticipate. I've anticipated them before we had these conversations today. They are a lot, brighter on my radar screen after these two conversations that we have today. And I think that we're very fortunate that we have, experts on the committee here. We have experts within the academy, and European colleagues, and we're gonna solve these problems as we move along.
So the second part of the question relates to the population that is exposed to these allergens, and I mean, we know that for dust mites, pternicis and Freinii have different distribution by geographic area. We also know that some populations are more reactive to some allergens, like African Americans are more reactive to cockroach allergen and to dust mite allergen than Caucasians and other races. So again, I mean, that all needs to factor in when you, based on, like the discussion we had before about age, different populations are different. And so what's utmost characterized and standardized for a population may be different than another. And you'll have to come up with something that covers everybody and every age, and that's not a small task.
Nope, I agree with you.
Okay.
I agree with you on that. And you know, the only thing to really say to it is that the first solution that we may come up with may not be the ideal one. I think, Dr. Assad, that I would hate to see us, you know, 90% there with a given extract and then stalled for 3 years because we're trying to solve some of the issues that you brought up. Okay, I want to do, you know, I want to get something in place for some of these extracts that will, you know, improve things or reach some endpoint. And then, you know, we, the FDA and the community will be there to remind us that the job is not done, that, you know, the first iteration is not necessarily the last iteration. And I think that that's the best way that we can incorporate your comments and your concerns. You're plural, after all, because your colleagues on the committee are agreeing, you know, have stated the same concerns, you know, and in a way that will be efficient and not just, you know, and it won't become just another thing that we plan on doing but haven't really done. That's my biggest concern. My biggest concern is that.
Okay.
Okay.
So I'm not sure if you're going to be answering for us any more questions, but if you're not, I have one more question. Like, I don't know if you have more presentations or what's that?
No, this is, well, there are more presentations. There's a presentation from Dr. Platts-Mills and from APMA.
Yeah, but from you, for both of you.
No, from us, this is it. So please go ahead.
So my question is, or the status of things are, that at the end of the day, as users of these extracts, particularly in diagnostics, we are always faced with the question, and particularly in food allergy. I know we didn't discuss a lot of food allergy here, but there is a major discrepancy between the skin test responses and the CMIGEs, specific IgEs to the foods. If we do for environmental allergens, the range for specific IgEs for a certain allergen is different. Like it's very high for grasses, it's much lower for Alternaria, middle for dust mites. I've published a paper years ago on that. So we left with this reconciling the results of skin tests with CMIGEs, and we also left with trying to reconcile or even to interpret all of that. So what does a positive skin test of this size mean versus that size? There is all the things that in practical terms, and I know that may not be your issue, but once you approve something, you approve it and standardize it as, well, this has this much, Alt-A allergen. Does this mean you expect with this allergen that's standardized to produce a positive skin test? What's the positive predictive? How big is the skin test? Is it? What's the positive predictive value of this skin test versus a different skin test? So all these become more steps and things that practically affect the use. I mean, to the point that I, for example, in my practice, very rarely do skin tests anymore for foods. I just use the CMIGEs. They seem to correlate, give me more information and components. CMIGs and components. So the skin test just muddy up the waters.
So let me ask you then. I mean, what do you think accounts for that? And, in an ideal world with unlimited resources, how would you reconcile those things? I'm curious to hear what your thoughts are.
Yeah. So, I mean, this is where translational research comes in. You bring those highly allergic patients, use that standardized extract that you have decided, and show these curves of positive skin tests. You can also bring patients who are not highly allergic. Like, again, in food allergy, it's a spectrum. And in these patients, those skin tests of this size correlate with such. I mean, you said you talked to Gideon Lack. After a lot of discussions with Gideon Lack on the NIH Committee for Peanut Prevention, and looking at those studies with the Australian studies, with other studies, the number of 7 millimeter became, yes, that's what predicts you're going to be peanut allergic or not allergic. But that is not actually universally true. So I think, yes. So I think,
especially since you don't know what that means in terms of how much allergens in the extract, because it's not a standardized extract.
Well, that's true. If we end up with standardized extracts, then we need to almost
repeat. May be more meaningful.
We would almost need to repeat those epidemiologic studies to say where is the cutoff. And I think that should be part and parcel of what you're going to do.
Okay.
Yes.
Okay. Fair enough. Dr. Greenberg.
Dr. Greenberger?
I would like to thank you for your presentations. I have one quick comment and then a question. The comment is I'd like to see the United States and FDA be leaders in standardization of allergenic extracts. And I'm glad we have this was commented by Dr. Rabin, and I hope that this can be the case. A question is, what would be satisfactory fit for purpose, let's say in a year or two, for, let's say, ragweed? What do you see under your criteria meeting fit for purpose?
Sure, I think fit for purpose. Well, fit for purpose for the ragweed assay would simply mean that we have the linearity of the range of measurement of AMBA1, that covers, that well brackets the range of the concentration of AMBA1 in the allergenic extracts. I mean, in a limited sense, that's what that means. If you're talking about, say, taking the mass spec test and applying it to AMBA1, or for that matter, any other, or not a ragweed, or for that matter, any other extract, I think fit for purpose is demonstrating a range at which you're measuring these allergens and ensuring that you are measuring intact allergens, which, is, right, because that's the one big drawback of people like, Dr. Schrader knows, very well, and, makes absolutely sure that you're, because you could be starting off with a bunch of digestive peptides and then you're measuring a bunch of digestive peptides and it's garbage in, garbage out. So, but fit for purpose, sort of by definition is, accuracy, precision within the range that brackets the range of concentrations that what you're measuring, that you intend to find. We don't need a hypersensitive assay. We're not looking for, contamination of wheat flour by a little bit of peanut protein, like what's necessary in the food industry. We're looking at extracts. So does that answer your question?
It helps, but I would like to hear that I'd like to hear how the mass spec data could help us look at heterogeneity, or at least say what would be the major allergens with these measurements, say of the mass spec?
Well, a major allergen is defined by what people react to. So I don't think that mass spec addresses that. I mean, what mass spec addresses is what comprises the major concentrations. And the idea, I think, of applying it to the clinical, sort of the dream is, is to be able to put it together with component, monitoring, and individualized patient therapy for those who would benefit from it. You had something?
Well, yeah, I did want to. Yeah, so with mass spectrometry, we can get the relative abundance or absolute quant for a number of allergens and simultaneously in the sample. We can also compare how these differ from one, say, batch to another batch. So we can definitely address heterogeneity just by looking at changes from one sample to the next. And what we're hoping to see is that if there is a standardization in process, is that these differences would narrow and they would become less. In other words, your coefficient of variation for identified peptides would decrease and it'd be tighter and smaller. Say, ideally, a great number would be below 20% instead of 40 or 50% like what you were seeing in the data slide I showed, which is outrageously high.
Okay, so I think that's the best answer that we can. I hope that answers your question the best that we can answer.
And I would, well, before I turn off, I'd like to see a meeting of this committee in 1 year to get a progress report. And we could continue to help. Is that feasible?
All right. That's not my decision. Taken under advisement. Taken under advisement, I have been told by upper management. Okay.
All right. Thank you.
Okay. And one final point, you may have clarified this, including the fecal pellet in the extract improves the diagnostic sensitivity.
I could only imagine that it would. I would hope so.
Now, do we know that it's false negative because we don't have the fecal pellet?
I don't know that that's, I don't know that that would be known. I don't know. Dr. Platts-Mills, that is a great question for Dr. Platts-Mills.
All right. That is a great segue into the next presentation. And I want to remind all the committee members that we do have a designated 2 hours for discussions, Q&A, and all the presenters usually are available to clarify points and answer questions. Next on the agenda is Dr. Thomas Platts-Mills. He is a professor of medicine, Division of Asthma, Allergy, and Immunology, Department of Medicine at the University of Virginia School of Medicine, Charlottesville, Virginia. He will be discussing approaches to allergen standardization related to dust mite. Dr. Platts-Mills.
Thank you very much. It's a real pleasure to be here. Some people think that inviting me to talk to the FDA was rather inviting the fox into the hen house. But it's a pleasure. And I need to say that I have a conflict, which is that we have received support from Fadia Thermo Fisher for doing assays, but they don't control anything that we publish or talk about. And I'm grateful for that. I'm grateful to the NIH for support and continuing support at this time. The dust mite, when we first started here, you'll notice that I use the term we in a royal sense. When we started in '82, there were thought to be upwards of 5 million people on treatment with house dust extract. And the house dust extract was collected in vacuum cleaner bags. And so it was standardized in vacuum cleaner bags per liter, which was not satisfactory. Over that period, cultured dust mites appeared, firstly from Voorhorst in Amsterdam, who developed the technique. which was taken on by Bencard in the UK and then Hollister in Spokane. And now, of course, there are many people growing dust mites. And we've had this issue already brought up. Should we use isolated mite bodies, whole culture, or mite feces? And I'll address that. To provide a suitable method for comparing batches of a product to establish standard, we've heard about skin testing, endpoint titration, and I will talk about that, in vitro methods of measuring potency of an extract, and immunoassays for DERP1, DERF1, DERP2, and DERF2. Maybe I should spell out that the skin testing, the ideal technique had many problems. Firstly, it was much too demanding on the subjects. And Harold Nelson actually said, I refuse to recruit anyone to do that skin test titration. And if you've ever had intradermal skin tests on your back, you will understand why. In vitro methods of measuring potency of an extract, yes, Dr. Rabin has discussed those, and there are methods, but obviously skin tests tell you that they really react, or BAT can do that, but they are all demanding in terms of routine use. And there are immunoassays for the allergens. And as we've heard, there are several forms of mass spectroscopy, but there is also the original thing developed by ALK, which was cross-radioimmunoelectrophoresis, or CRIA, which can give you a wide range of proteins that are seen, and was established by Henning Lowenstein in the 70s. And finally, proteomics, which I will mention. If I can have the next slide. Do I have control over the slides? I don't know. When we talk about the sources, we really come to the data that came with a purification of dust mite in DERP1. And I want to stress that the first allergens purified, which were LOLP1, AMBE1, FELD1, and DERP1, were all purified before cloning or monoclonal antibodies. And so they actually focused on identifying a protein peak, which is once you start cloning, you don't do. But in keeping with that, DERP1 we can measure in the air quite easily, and DERP2 we can measure. But none of the other allergens in dust mite can be measured accurately in the air at the moment. And DERP23 is actually, which is an important allergen, is actually difficult to measure in dust extracts or mite extracts. And then I'll talk about Dr. Toby in a minute, but we purified, Martin Chapman and I purified DERP1 in 1980, and together with Dr. Heyman and Dr. Alberzi, we purified the group 2 allergens and published those in 89. Next slide. This is Ewan Tovey turned up in London in 1979 or 80, and he took a job as a publican pulling pints of beer, and he started talking about mite feces. And we heard about it, and it turned out he'd started doing a PhD in Sydney, Australia, where there are plenty of dust mites, and he said that it's the feces. We had developed a technique to measure antigen P1 with rabbit antibodies to DERP1. And with that, working with Ewan, we've presented good evidence that the quantity of DERP1 created in a culture was largely in the form of the feces. I doubt that this percentage is correct, that is 99%, and I don't intend to do the experiment again. But he also showed in a very elegant experiment with double-sided sticky tape inside a pasta pipette that you could actually not measure DERP1 coming out of live mites, but you could rapidly out of mite feces. It came out within a minute. And the concern was, is there a peritrophic membrane on the outside of these fecal pellets? And you, in the next slide, went into houses. If I can move, can I move the slides? No. Next slide, please. He went into houses and proved pretty convincingly that there was no airborne measurement in undisturbed houses. These are actually some of the disturbed ones, but in undisturbed houses, we could never measure airborne allergens. But in the under disturbed conditions, we got quite significant levels in nanograms of what we thought was DERP1 at that time, what was DERP1 at that time. And really interestingly, the size of these particles is on average 15 microns and often greater than 20. And at that time, it was widely thought that particles had to be less than 5 microns to get into the lungs, which simply isn't true. And there was a very good scientist in Sweden called Svartengren who proved that a proportion of large particles do enter the lungs, not into the distal lungs, but into the lungs airways which are involved in asthma, and that fecal particles, and that included fecal particles. Here is a picture of off the first stage of the impactor, and there are actually 3 fecal particles stuck together there, but you can see an immunodiffusion ring very nicely with a rabbit antibody to DERP1. Next slide, please. Then we come to the question, what should we use for extracts? And this is ALK work from the early on. This is a paper published in 2016 where they described their details. Well, but they started this long before that. And they started sieving extract and created a multiple panel sieving program to separate particles rich in whole bodies and rich in fecal particles. And next slide. This is their picture. So if you have a sieve that has a micron particle openings of 350 microns, then 90, and then 50, you can get a fraction that is very rich in whole bodies and a fraction rich in feces. And the reason we're focusing, we knew that you could sieve to get feces from Ewan's work, but these fractions are then killed by freezing and dried to below, killed by freezing at -20 and dried to below 15% moisture content before sieving. It is very difficult to sieve if there's any moisture in the particles because everything sticks together. But with this, they've got an extract of feces which was rich in DERP1, an extract of bodies which was richer in DERP2. And they worked out how to mix them together to create extracts of the proportions that they wanted. Next slide. This is a study published by ALK or supported by ALK, and they described their extract as having 15 micrograms of group 1 allergens, DERP1 and DERF1 combined, as well as 15 micrograms of group 2 allergens, DERP2 and DERF2 combined. But in addition, they stated that the tablets contained the broadest possible spectrum of major and minor allergens from these mite species. Now they didn't state how they knew that, but they already understood CRIA, and I suspect by 2016 they were definitely using mass spectroscopy already. So that there's a model here of a company that knows how to balance group 1 and group 2 allergens at a ratio of 1:1. And I'm not suggesting that we know that 1:1 is correct, but it's certainly not far outside the correct zone. And they had good data with sublingual immunotherapy. And of course, allergens are being used widely now for oral exposure, for subcutaneous exposure, and for sublingual exposure. And it's actually the development of tablets that has pushed accuracy of components in relation to the companies. Next slide, please. This is a separate, completely different company. This is HAL, which is a company in the Netherlands, which has never attempted to come to the United States. But this is Klaus Bachert, who tragically died last year, and a large group of European investigators, including Ronald Van Ree and Oliver Farr. And they use different ranges of doses, but they pretty well knew that they thought there should be 15 micrograms and 13 micrograms of the major deteriousness allergens, DERP1 and DERP2, in a dose. So that they knew that already, and they did something else, which was to actually measure IgG4 responses to DERP1 and IgG4 to DERP2. If I have the next slide, I'm including this data for a very specific reason, that here is IgG4 to DERP2, and with the maximum dose of allergen, this is used in Allergoid SCIT, subcutaneous immunotherapy, the G4 response to DERP2 is modest. By contrast, the G4 response to DERP1 is not the same as that with dusmite, a whole extract, but is up much greater, 4 or 5-fold greater than that to DERP2. And I'm mentioning this because we have data much more recently suggesting that this is a real difference and important. Next slide. Just a word about allergoids. There's a long history of allergoids in the United States. David Marsh, who trained in England and actually may have known people who in the main company making toxoids in the United States, in UK, that is tetanus toxoid and diphtheria toxoid, and developed the technique of glutaraldehyde modifying allergens at that time. Unfortunately, this allergen never got approved in the United States. Harold Bayer was very opposed to allergoids because he said you can't measure what's in them, but we're well used to them in toxoids for other purposes. And Roy Patterson developed polyethylene glycol extracts, which many people thought were very, very effective, but never got approved. Can you measure allergens in allergoids with mass spec? And the answer is almost certainly yes, and that you could measure them. Of course, you can't prove that the whole object of allergoiding is to make them not react with IgE antibodies, and therefore that you can't prove that they're allergenically active. That you can only do by controlled trials, which appeared to show that. Next slide. I'm moving fast, probably because I can't see the faces of the audience. The faces of the audience are something that normally control you when you're speaking, but this is another preparation. This is funded by Allergen Greer, said to be in France. Of course, Greer is in North Carolina, and they give their result, potency in index of reactivity. But they have clearly stated that the quantities here are 14 to 17 micrograms of DERP1 and 53 to 68 micrograms of DERP2. That's a strongly biased to DERP2, but I'm not saying that that's wrong. I think the important thing is that you can state these ranges. And they said in addition that the extract includes the following allergens, including DERP23 and DERP36, which I think are definitely allergens. But most of these are discovered by cloning. And when you clone an allergen, you provide no evidence that it's actually, you can get definition of a protein with no evidence whether it's produced in the environment and whether it can be measured. And as we know, DERP23 is very difficult to measure, and we believe that many of the others are. DERP11 maybe, it's a larger protein and actually associated with atopic dermatitis in its sensitization. This was a large study and primarily of allergic rhinitis, and it's all sublingual, but they had good effect on the asthmatics as well. Next slide. But this is the major study published in the New England Journal and the first author was Brian Vickery, Andrea Vereda, Casale, Kirsten Beyer. A lot of extremely distinguished people were on that paper, and it absolutely showed that oral immunotherapy for peanut allergy in children is effective. This data was impressive and led to the licensing of Palforzia. And remember that we know the dosage. We know what is measured in that in terms of group 1, group 2, and a wide variety of other allergens. Next slide. I'm not showing pictures of mass spec, but I do want to say a few words about proteomics. This is a really impressive paper on the proteomics of Dermatophagoides terranicinus, but this is the figure, one of the figures in the paper, and you'll see that there are multiple allergens identified here, and you could get information about them through proteomics as you could from mass spec. And what I want to discuss is how much could an allergist in practice deal with data like this? If you knew that there were 20 allergens that had been already identified by cloning or by purification, and you could get some estimate of the quantity in an extract or samples made from mite bodies, which I think most of the data in this paper was, can you get data that your individual patient is sensitized to which of these allergens your patient is sensitized to, and then choose an extract accordingly? And my own view on that is the answer is no. No allergist has time or effort to do that, and getting accurate measurements of IgE antibodies to specific proteins is expensive and difficult to deal with, and matching them up with a picture as complex as this would be impossible. So that I'm really not convinced that we want to know all the components of an extract. And I think that, I think that it's worth knowing that there's some model that a company has of what their extract produces, and that they follow that so that they, if there was a major change in their extract growth conditions, which could easily happen, or the strain of mite that was growing in it, yeah, they could know, and that would be helpful, and it could be done with mass spec or proteomics or cross-radio immunoelectrophoresis in-house. Making standardized maps of either proteomics or mass spec and saying that a company had to match up to it might really increase the cost of manufacture. I made my point, I hope. Next slide. Some years ago, it became clear from data coming from Sweden that in some studies, the children living in a house with a cat were actually less likely to be sensitized to cat. And there are other studies where that's not found, but there's certainly a study in New Zealand where it was found quite clearly. And actually, it appeared in that study that the highest levels of mite did not decrease sensitization. But Ewan Tovey, again, the same Ewan Tovey who first proved that mite feces were an important source of sensitization, published data on nonlinear relationship of mite allergen exposure to mite sensitization. So if we published a paper called The High Risk of Asthma Among Early Teens Associated with Quantitative Difference in Mite and Cat Allergen Specific IgE and IgG4. And I need to mention Dr. Keshavarz and Dr. Wilson, who played a major role in that, and which was published in eBiomedicine, which is a part of Lancet Science in 2025. Next slide. So this is the data from Sydney with Ewan, Katarina Almquist, who did elegant studies on cat allergen in Stockholm, and Guy Marks, who has taken over that group since the tragic death of Ewan Tovey. But what you'll see is that allergy to house dust mite is lower in the highest exposure group. The wheezing is lower, but above all, asthma is highly significantly lower. But above all, asthma is highly significantly lower in the group with the highest exposure, and these exposure levels are very high. That is, the highest group was all greater than 23.4 micrograms of DOP1 per gram of dust. Very interestingly, our own data suggests that exposure can change the relative importance of allergens. So for the next slide, this is data, some of which comes from Indobiotech from Martin Chapman, who's an author on our paper. And you'll see FeLD1, we can measure in dust easily. We can measure it airborne and have done for years. FeLD1, DERP1, we can measure airborne during exposure, as I've made clear, and we can easily measure it in floor dust. DERP2 levels in our hands are lower, but that's not always true. And DERP23 is too low to measure in the air. We've never succeeded, no one's succeeded in measuring it, and is very low in floor dust, much lower than the others. So to see the next slide. This is dust mite data from the paper in eBiomedicine. And here you'll see the blue is non-asthmatics, and the orange is asthmatics. So here's IgE to dustmite, IgE to DERP1, IgE to DERP2, which is actually higher and slightly more common than IgE to DERP1, and finally DERP23. You'll see there is a good population of subjects who have IgE, of asthmatics, who have IgE to DERP23. If we now, and this is all the subjects with asthma, this is dustmite patients, all the subjects with asthma, and 199 subjects without current asthma randomly chosen. And so this is IgE to DERP23. But if I can have the next slide, here we're looking at specific IgG4 to dustmite, DERP1, DERP2, and DERP23. And you'll see that there's a much lower percentage of positives and a higher number of unmeasurable G4s to DERP2. And DERP2 seems to be more strongly associated with asthma, but much less G4. And DERP23, among the asthmatics, there were 26 asthmatics associated with DERP23. Only one had detectable G4, and that was very low. And so that we are seeing, with what I believe is due to high exposure, you get good levels of G4 with dustmite, a good prevalence with DERP1, but see, 80% of the asthmatics were positive to G4. Only 24% of the DERP2 positives, IgE positives, were had detectable G4. But DERP23 effectively at 1 out of 26. Next slide. We had followed up the Swedish data, and in a large school study in England and in Virginia, well, actually, this is a study done between Los Alamos, rural Virginia, and the city of Charlottesville. And among those patients who were living, who had all their houses measured, these are the levels of FeLD1 in micrograms, FeLD1 per gram of dust. And you'll see that the highest level of exposure had lower prevalence of sensitization and much higher prevalence of significant IgG. And we had other evidence at that time, this is in 2001, we had evidence that these were IgG4 antibodies. But let me show you the data, the new data. Next slide. When we look at IgG4 to IgE ratios for cat dander, so this is IgG4 in nanograms per ml. This is cat dander IgE in nanograms per ml, and we're getting comparable units. And some of you may know that there's been real trouble with the units of IgG4 in nanograms, because some papers were published with nanograms per liter, and then in milligrams per ml. And the difference between nanograms per liter and milligrams per ml is enormous. What we see here is that if the ratio is less than 50:1 of G4 to E, there's a highly significant increase in asthmatics, and the red dots with a black circle around them were moderately severe. That is, that they had two or more acute episodes in the past year and had a diagnosis of asthma and were using inhalers. By contrast, if they had greater than 51, only 2 out of 20 had asthma, and there are a large number of subjects who make G4. These are all 135 subjects living in a house with a cat, approximate age 13, in the Viva cohort in Boston, which is Emily Oken and Diane Gold's thing, and Cheryl Reifus-Schumann is the main statistician. Next slide. I want to just, I apologize about the complexity of this slide, but these are IgG4 to IgE ratios for asthmatics, and this is cat dander data. And here you'll see that the mean ratio is under 20 here. So this is 20, 30, 40, 50 up here, and that's the data I've already shown you. For FeLD1, this data is actually slightly more impressive. There are a large number here with very low ratios of G4 to E, and these are asthmatics in the blue circles. And for FeLD4, looking at the same issue, there are only 3 where we had G4 and E among non-asthmatics. So the statistics don't work. But the level of the ratios to G4 to E to FeLD4 6 out of 8 were below 10. And that is, it looks as though this ratio of G4 to E to FeLD4. So there's 2 minor allergens we're looking at, DERP23 and FeLD4, where the allergen appears to be strongly associated with asthma and makes poor or no IgG4. So next slide. In conclusion, I want to make a point about intra and intermolecular epitope spreading. I apologize about these terms because they get confused very often. If we use the term intramolecular epitope spreading, means that you can have one antibody binding to DERP1 and no only IgE antibodies to only one site, or you can have IgE antibodies to 4 or 5 sites on DERP1, and that seems to be associated with much more ability to induce histamine release and symptoms. The alternative is epitope spreading from one protein to other proteins of the same source. And this may be equally important, but it's intermolecular epitope spreading. And what we appear to be looking at here is that major differences in intermolecular epitope spreading occur between IgE and IgG4 antibodies to cat or mite components. That is, that the low or absent G4 responses to some protein allergens, DERP2, DERP23, and FeLD4, could be the reason why some of these allergens have a more significant role in symptoms, including asthma. But what matters here is that the relative importance of the minor allergens, such as DERP23 and FeLD4, may be different if you're in an environment with very high exposure to mite allergens or cat allergens, compared to an environment where the level of exposure is much lower. That means that effort to make a decision about what level of allergens you need in an extract could be extremely complicated and unlikely to be fruitful. And that the position taken by some of the manufacturers appears to be that you should measure group 1 and group 2 allergens, make a decision about the ratio and state what that decision is, and keep to that ratio within certain range in your statement of the extract, and to monitor either with CRIA or with proteomics or with mass spec. But if the FDA takes a position that people should use mass spec for their intermittent monitoring, that may be fine. But making a decision that you've got to have this, that, and the other allergens, multiple different allergens, would be exceedingly difficult. Next slide. So the summary, the ability to separate fractions of dust mite culture has been available for many years. Over the last 20 years, there has been a progressive move to defined extracts, particularly in the production of tablets used for oral sublingual. Assays of group 1 and group 2 mite allergens have been possible or available for at least 30 years. However, there's no simple basis for defining a ratio apart from 1-to-1, because the relative importance of these or other mite allergens can change with different levels of exposure. By selecting or sieving different sources of mite, it is possible to enrich whole bodies of feces and to create extracts with defined quantities of group 1 and group 2 allergens. It would be difficult to extend, I apologize, but it would be difficult to extend this to other allergens because their quantities in extracts or the environment are much lower or much lower. Next slide. In conclusion, with the process of standardizing mite allergen extracts, skin tests are essential. Skin tests at some level are essential to be sure that product is clinically active, but no form of skin testing can define the strength of an extract because it depends on the choice of the subjects tested. That is, there are patients who differ in their sensitivity by logs, and if the company can choose the subjects, they can decide what the strength of their extract is. Assays for group 1 and group 2 mite allergens to assess the consistency of products should be used to relate batches to local, national, or international standards. And I think that applies to DOPI1, DOPI2, FELDI1, BLOGI2, and cockroach, you probably need BLOGI2 and BLOGI5. Answer to Dr. Assad, I don't believe that African Americans are more sensitive to those cockroach allergens. I think many African American communities in the United States do not like having cats in the house, and cats are major consumers of cockroaches, and the increased levels of cockroach allergen in the houses of African Americans in part or in major part reflect the lack of cats. The assessment of the quality of extracts by either CRIA or mass spec or proteomics should be encouraged, but I think the FDA has made a very strong case for using mass spec as a monitoring system, but not as a standard definition of standardization. With a focus on standardization, what will be necessary is a standardization of the mass spec techniques used. If I can have the final slide, thank you. Thank you very much for your audience. But I'm showing you this utterly beautiful picture to remind you that I don't believe that an allergen practice can handle thinking about more than the 10 or more allergens. They can't think about it, and they can't make decisions on the basis of it. Thank you.
Thank you, Dr. Thomas Platzmels. I do know that the committee has many questions And in the interest of time, though, we will move to the next presenter. And Dr. Platts-Mills and the other presenters will be available for at least an hour worth of Q&A after the next presentation. Thank you. So now I would like to welcome Ms. Trina Repp. She will give us the perspective from the Allergenic Products Manufacturers of America. Ms. Trina Repp.
Hi, thank you. Yes, I'm presenting on behalf of the manufacturers. So on behalf of the Allergen Products Manufacturers Association, this slide just shows who we are. We are a nonprofit association of the businesses listed. I'm the current president, so I'll be presenting on our behalf. And I am employed by ALK, one of the manufacturers. Next slide. So we did want to thank Dr. Rabin for inviting us to present in this discussion. And I think, as was already mentioned, allergen products have been around since the early 1900s. Since then, there's been a lot of knowledge about allergy and treatments that has grown, and the technology has greatly advanced. We do agree it's important to continue to innovate and improve our products and to provide the best treatments to the allergic patient. We also want to thank Dr. Rabin and his colleagues. We did notice some of our questions within our presentation were addressed during their presentation, so we do want to thank them for that. We're still going to present it, but they may have already been addressed. Next slide. So we created this presentation before seeing the briefing book. We did have a preview of what the topics were going to be, so we did want to include what we believe the topics were. We believe this aligns with what was presented today, so we don't need to do much more about this slide. Next slide. So the first thing we do want to talk to is the change from the allergen units, which are related to the BAUs, for cat and ragweed. I'm not going to explain the ideal 50. That was very nicely explained by other presenters. But we do want to emphasize our position that we do want to maintain that clear link of the current units and the BAUs when changing to FeLD1 and AMB1 units. It does maintain that link to the original skin testing. I know there's some issues with that method. However, that's how it's been linked previously. And we also want to link it to that to also provide a conversion for allergists when they're adopting the new units in the clinical setting. We do want to say, the agency has kept us informed on the new ELISA development, and we do support the change. We've been involved. We did want to mention at this time for the cat ELISA, we're not sure we're convinced yet that the currently published data shows a strong correlation between the current FeLD1 units and the future FeLD1 milligrams or micrograms per mil. We do feel additional data is needed to make that conclusion, but we also know there's been some additional work since that publication. Next slide. There is one consideration we would like to put out there when referring to the BAUs or the major allergen units to the micrograms per mil, and that is the labeling. Currently, when we label in the BAUs on our products, for example, for the cats, we will say it's a 10,000 BAU per mil cat extract. When we do the actual testing for the standardization, we have an acceptable range of 10 to 20 FeLD1 units per mil. We would like to propose, it's our perspective and our stance that we would like to maintain this labeling in the future. So when so essentially not reporting the exact results of micrograms per mil on the label, but essentially saying if it's within this range, it is an X microgram per mil extract. So for example, if you take this 10,000 BAU and the current range and you multiply it by the approximately 4 FeLD1 units per gram or micrograms per FeLD1 unit, any extract that has a result of 40 to 80 FeLD1 units per mil would be labeled as a 60 microgram per mil FeLD1 protein and not, say, a 45 microgram per mil protein extract. This really accounts for the method variability. It would be consistent with the BAU labeling, and it would also discourage some unnecessary discrimination in batch selection at the clinic. As manufacturers, we are a little concerned because it wasn't clear to us what the labeling expectations would be, that if we were to put on there the exact results from the assay, that we might start getting requests for specific batches because it's perceived as being a higher potency than one that would be within the normal range of the method variability. Next slide. So let's talk about the mass spec. It's a very interesting presentation. So I think I will acknowledge that we do want to thank Dr. Rabin for clarifying at the beginning of his presentation that these standardizations are for essentially the traditional aqueous extracts, not necessarily the newer products like the slit tablets or the OIT. So you will see some of the new products in our presentations, just because when we heard standardization, we weren't sure if it was going to apply to these traditional products or to all products. So you will still see it, but the points we're trying to make are still relevant, even though we have included some of this data in here or information in here. So what we wanted to highlight with respect to the mass spec, currently we do have multiple house dust mites, and we are using the mites as the example, but this could apply for all of our products. We have house dust mites, we have the 3 manufacturers, we have different processes, we have different source material. All of these products are approved, they've got real world use, they're considered safe and effective, but they may be different. So next slide. So we have also had some updates over the years about mass spec. These slides are actually from a presentation given at an APMA meeting that we had with the FDA, and this is from Dr. Spirik in 2016, I believe. And the point of this is that you may have an extract that has the same potency, but the actual composition may be very different. We expect that if you were to look at all of our extracts, they will be different, even though they have a similar potency in the current standardization. Our concern is that all of these products have a history of safe and effective use. When I say some are supported by clinical trials, that's really the slit tablets. But what our concern is that if we create a single composition, a specific composition that these extracts need to conform to, that might not be applicable to all of the products. We also have some concerns with the cost. So MS mass spec equipment is expensive, and also there's a lot of batch-to-batch variability within both the source material and the extracts. When you're looking at a small selection of extracts, I mean, as we can see in the data presented, some of the CVs when they did 3 batches was high. When you look across 20 batches or 100 batches, you can really see the variability, the natural variability in the product, which can affect these types of assays. Next slide. So when you're considering these factors for the mass spec, it's kind of our position that when we're talking mass spec, and I do want to say within the industry, there's some minimum, there isn't a lot of experience. I know some of the companies have this implemented, as Dr. Rabin said, one of the first presentations he saw was from a manufacturer. So there are a couple manufacturers that have this technology. I think maybe one might be using it for product on the market, but a lot of it is used in research and development. And from our perspective, we're not against using this type of technology, but from our perspective, it's our position that it shouldn't be used as a release test. It's very useful in characterizing a product during development, or to even evaluate an impact of a process change during life cycle management. But if you were to use it as a release test, you need to have robust specifications that need to be set, and it should also consider the acceptance criteria at the end of shelf life. This can be very complicated considering the inherent variability of the source material and across the manufacturers. We all have different processes, and our processes can very much impact a composition on this type of analysis. I mean, it sounds like, it's a crude extract. They're all very similar, how they've been done for 100 years. You take a source material, you extract it, you purify it, you sterile filter it, but they're still not the same, because differences in the source material and small differences in the manufacturing can result in differences in the extract. Mass spec is also performed on degraded proteins and only measures the presence of the allergens, but not necessarily the potency. And it also does not measure stability. So we do want to question what the stated link between the quantitative measurement and the biological potency really is, because presence doesn't necessarily mean potency. So it is our position that if it is implemented, we do agree it could be very useful in characterizing our products, either retrospectively for the current products. I think I will not mention any of the development products or future products, since that's not in the scope. But to use immunochemistry methods as the batch release, to continue using those, either the current, whether it's the current relative potency ELISAs or new major allergen ELISAs, we do think it's very important to maintain that link with the potency combined with the characterization. And yes, I think that's the main point for this slide, is that if it's to characterize presence, it's one thing, but it's different to use it as a release test for composition. Next slide. So the addition of the house mite fecal to the extracts. So it was our perspective, and the data is very interesting that's been presented, but that the current extracts do contain fecal, essentially the major allergens related to the fecal particles. There are some present in the purified bodies. It's not just, there is going to be some gut fecal. It is made available in it for extraction by grinding the bodies prior to extraction. And then also there is the house mite slit tablet that's already on the market. It contains both the body and fecal extracts with the defined ratios of the major allergens. We did want to point out, as an industry, there is a patent for that process. So Dr. Platts-Mills had presented one of ALK's papers with the picture of the sieve. That is a patented process. So if this is an expectation for all manufacturers, it just needs to be considered that there's not an infringement on the patent held by ALK. And that patent does cover from the source material to the drug product. And I do want to state, as somebody who was involved in that process development, the manufacturing of the source material and the processing of the source material to get those defined ratios can be very complicated to achieve it consistently. Next slide. Oh, next slide. I'm still seeing the current slide. Oh, thank you. So in general, on standardization of new products, so this refers to both the potential new ELISAs, the potential implementation of mass spec. We do support innovation and modernization of the allergen products in ways that benefit the patient. There are just some things we want to be aware of. Some of these have already been touched upon. There are some global standardization initiatives. Specifically, in Europe, they've recently standardized 2 products, the Flame Pretense and the Bacillivir Cosa. A lot of us are manufacturing products that are approved in markets in addition to the US, some of those markets have their own standardization initiatives. We are concerned that if we start getting multiple standards created worldwide for the same allergen, it'll be very costly for us to demonstrate conformance to all of the standards. And in some cases, it may not be possible, because when you create these assays, the reagents are very important on what exactly they're detecting. So we just want to keep that. I mean, it sounds like everybody's aware, but just when we're doing that, we're doing these standardization initiatives. It's very important to consider the global standardization initiatives as well. we also want to talk about the cost considerations for the clinics and patients. So standardized products are more costly to produce, and I wanted to touch on this. It's very true that the reagents are provided by the FDA, and we really appreciate that. We do transfer the methods, but we do still have to do some sort of validation internally of these methods, specifically in our labs with our individual products. There is cost associated with that. If we add additional standardized products, then we're going to have to consider an increase in the number of analysts in our labs and quality personnel for reviewing and approving and releasing those products. And some of these initiatives say for example, the fecal addition to the mite extracts, and even the potentially looking at different ways to grow the molds, that might have to result in some process development activities to meet the standards, which will also contribute to the cost of the standardized extracts. So on the surface, it does look like just implementing a new method with reagents provided by the agency. However, there's a lot of back-end work that does need to be done by the manufacturers that will increase the cost of the standardized products that are essentially going to be handed over to the prescribers and the patients in the end. So we did want to point that out. And with that, I mean, are the prescribers willing to accept these additional costs? And is the cost benefit for the patient, has that been determined? I think it's come up several times. We're a little concerned on how these standards are being selected, especially with the mass spec and how it ties to clinical relevance. And that part there is, if it's arbitrary, is it considering, and I don't think it is fully arbitrary, but there needs to be a link for the patient and to benefit the patient if it's going to be implemented for all the manufacturers. And I think this last point was already addressed. We did have the question on if alternate methods would be accepted. For example, if we had already met a standard in the EU and we're using that method, or had an internal method that could be demonstrated as appropriate, would they accept the method? And it sounds like yes, they will. So we do appreciate that already being addressed. Next slide. So we do have a slide specifically on the foods. I'm going to comment again, a lot of this was, we were concerned, about that these standards would be applied to all product lines. It's been clarified that the newer technology, this will not be applied to. But I think we still want to emphasize that these new products, we agree it should not be applied to the new products. They're all either already backed by clinical trials, or they're in clinical programs. So they're going to be standardized. Or I guess they won't be standardized, but they'll be backed by clinical data, and they have a very high level of characterization. So we do now understand this will only be applied to the current extracts, which are only diagnostics. So I think that's important. Those are diagnostics. They're not the therapeutic treatments. For now, I guess I think, we aren't against standardizing for the foods, the diagnostics, considering the recent recalls and issues with that product type. Our main concern was also for the new products related to this slide. Next slide. And then we just had some general considerations. This is going to be a lot of new methods. We're going to be applying it to products already on the market. And just, I think you did touch on this as well. Dr. Rabin touched on some of this as well, just to make sure we're considering some of the, we do have some guidelines for analytical procedure development and life cycle management and validation. We have some ICH guidelines. Q14 has some very nice guidance for when you're applying new methods or standards to current products. So just making sure that these will be considered as these are being developed. We do want to just make a note that to remember, not every product matrix will work with every standardized method. This was more directed towards some of the newer products. We have some manufacturers with experience when the EU introduced their new standardizations, that it didn't actually work with the matrix of certain products. And then the last thing is to consider ring trials with the manufacturers before implementation. I know we've been collaborating quite a bit on these and that we will be testing them, but doing actually a formal ring trial from a manufacturing perspective, we would prefer to see that so that we can also show it's working in our lab. You know, every time you send a new method out to a different lab, especially if it's a brand new method, you're adding additional variables. You have different people, you might have slightly different equipment, just to show that it's going to work everywhere. So we would like to request ring trials before implementation. Next slide. And then one of the other important things for us as manufacturers is, you know, there is an impact to our current BLAs. This will result in a lot of updates to our BLAs. We're going to have a lot of changes to labeling. We might have to have some labeling system changes. We'll have PI updates, SPL submissions, you know, NDC, GTIN updates. This is a lot of updates, and depending on how many products this will apply to, I mean, it could be several. It could be quite a lot of work for us and for you as reviewers. So we would like the agency to consider a defined path for these changes that are directly resulted from the standardization initiatives to better utilize our time and your time and resources. Possibly it could be an expedited review period for prior approval supplements, for example. We also would like to request that if this is approved, that we are able to see kind of a roadmap for implementing and for implementation of these methods, and so what the framework will be and the interaction of industry for these methods. Next slide. So, and just lastly, we do want to just remind everyone, you know, the APMA and CBER have been collaborating since we were incorporated in 1988. That timing is not a coincidence. This was essentially created, this association was created when the standardization program started for allergen products. And part of our purpose, if you look at the, I'm not going to read all of them, but one of them is to develop and assist in the development of industry standards. And we have been working with CBER for over 35 years. We worked on the original collaborations, and we've had continuous collaboration with different initiatives. And we do want to say that we look forward to the continued collaboration with CBER on these new initiatives. And next slide. That was the conclusion of my presentation, and thank you.
Thank you, Ms. Rep, for enlightening us on the industry perspective here. I would like to inform the committee members that we will break for 10 minutes now. There are questions for Ms. Rep, questions for Dr. Platzmills, with which we will begin the Q&A portion or the discussion portion of the meeting. And these questions would need to be pointed to the actual presentations, and then it would be more of a general discussion. Right now it is 3:06 Eastern time. So let's reconvene at 3:16 Eastern time. I'm sorry, yes, Eastern time. Are we live?
Am I live?
No, did this session begin again?
They said the recording was on.
Okay. All right.
And
Well,
I am alive.
Okay, thank goodness. Welcome back to the question and answer portion of the meeting. We will begin by specific questions to Dr. Platts-Mills and Ms. Trina Rip pertaining to their respective presentations. So please use the raise your hand function in the Zoom so we can begin the conversation. Dr. Eric Rubin.
I have a question for Ms. Rep, actually, about the proposal to limit labeling to ranges rather than specific concentrations. That's not the way we label drugs where we measure concentrations. If you take ibuprofen and it says 400 milligrams, you assume that there's not between 300 and 500 milligrams. It's just 400. And of course, if you were given a dose, what a manufacturer of a drug would do is adjust the concentration so that it fit whatever the requirement was. So I'm curious what the justification is for not giving exact doses.
So the justification is more around the variability in the immunoassays. They can be very wide. The precision of the assays are not, I think a lot of the assays can be around 25% variability. Also, currently we are, the BAUs are measuring FeLD1 units, which is in a way measuring FeLD1, but we're not using the exact label. We're using a range. So it's exactly how the BAUs are labeled now, is to use a range. And that is to consider, at least as far as I understand, I was not here when it was created, but looking at some of the past discussions, it looks like it was selected that way because these methods have such a high range of variability.
But the new methods we're talking about don't have that error. They're much more precise. LCMS is extremely precise.
That's the LCMS. This is specifically for the new ELISAs that we're speaking about for the cat and the ragweed.
So if you were to use LCMS, would you feel like it would make sense to give a precise measure?
I think the issue with the LCMS is that it is measuring a presence of an allergen, not necessarily potency. So the immunoassays are actually measuring, what's binding to the antibodies. The mass spec is just saying, yeah, this protein is here, but we don't know. It could be degraded. It could not be active. So for the mass spec, I think it's a little bit more difficult to say that this is the potency because it's being detected by mass spec. Does that make sense?
Yeah, it makes some sense. I mean, that assumes, though, that the antibody binding in ELISA is a stand-in for the biological effect.
Mm-hmm.
Know that that's true. There's evidence for that. You're using an artificial IgG or monoclonal to measure the amount, and that's not the same as the IgE that is mediating the allergic effect. So I'm not sure that is any more predictive of response than the absolute concentration of protein. It's different. The skin test is different. The skin test is different because it's a biological output. The ELISA is just another way of measuring the same thing.
Yeah, but there still is some binding, and I know that they're cloned antibodies, but they're still based off of human sera. So I think it's still more linked to biological response than a mass spec would be.
Yeah. And can I just say something?
Yes. No, I'm sorry. We won't. We can only allow you to take questions and answer questions from the committee members.
I'm answering the question.
Oh. Oh, okay. If you want to answer.
No, well, Dr. Rubin, most of your molecules are small molecules, which are absolutely ideally dealt with by mass spec, and you've got a purity of product, We're dealing with measuring something in the middle of a very complex mixture of biological molecules. And that's different.
I completely understand that. I take your point. But it seems like the solution to that is to measure more of the molecules than to just say, it's about 300. You want, the whole concept here is to produce a reproducible reagent, and measuring something or measuring two things or measuring three things seems better than saying it's roughly right.
But I guess the other side of that is if you're measuring, the proteins in the mass spec, you're saying we're measuring it, they're precisely there, but what if they've degraded and you're not detecting degradation? So maybe there's actually no active activity in the extract without the complementary immunoassay.
And my last point, and you're welcome to respond, but it seems like we want to get to better levels of precision, and I understand the limitations. These are crude reagents. But even for crude reagents, it seems like the more things you measure and the more precisely you measure them, the more you get to standardization. And that's the whole point, I think. But feel free to respond.
I think one of the, complications with that is currently, as you said, they're crude. I would say they're complex extracts from natural products. We don't know what the variations are. We don't know what the differences between manufacturers. So if we're talking about a mass spec standardization, we really need to understand where our products are now. At least for the previous products, I know there's a question of, the current products, we don't know what kind of variation we currently have, what their compositions are. Like the mites have been on the market for years. They've been shown to be safe and effective. Yes, there's probably some differences clinically, but what that ties to in a mass spec is not clear. So I do think, in theory, it sounds fantastic. I think when we start, I think we need a lot more data before we can say it's an absolute way to determine potency.
Thank you.
Dr. Portnoy, is your question specific about those two presentations, or is it more about the general topic and the questions on hand?
I guess I basically just had a question about how standardized do we need these extracts to be? Allergists right now are currently using extracts, and they're going to throw a fit when we change the standard, the nomenclature and the standardization. They're not going to know what to do. They're not going to like this at all. And I was really taken by the comment about other countries already having standards for their extracts, and this is a different standard perhaps. And I'd be curious to know what the standardization process is from the other countries, and maybe we should just adopt one of those that have already been used and shown to be effective.
So I'm going to take it that your question is more general, and we will begin with this question. So it has to do mostly with the overall exercise today, which is what is the thrust behind the standardization? Where do other countries stand, and what can be adapted? So this is a question really to Dr. Robin and the FDA. Dr. Portnoy, you can stay, so they can answer your question. I think we lost your audio and video.
So you want me to ask it again, or just wait until?
No, I think let me see if Dr. Robin can answer it. No.
Okay.
Yeah.
So yeah, I don't know. I don't know what's done in Europe, but other than what I explained to you, is that I don't believe that I don't believe that it's harmonized. But certainly we can find out. We're not looking to reinvent any wheels. And so, if somebody already has something in place that works, that would be fine. But it is not my understanding that that's the case. And if things are manufacturer specific, I can't think of a reason that a manufacturer would be interested in sharing their reagents, on a large scale with the United States of America. So I think it makes sense on the question, but I think implementing the answer is a lot more complex than you might imagine.
I can imagine.
Ms. Rep, are you trying to address the question from Dr. Portnoy?
Yes.
Okay, please go ahead.
Yeah, so I think that in my presentation, I had mentioned their standardization efforts across different markets. Specifically, I mentioned EU. There has been a recent standardization for essentially 2 species. I'm going to say species, not products, because it's applied to the products that contain those species. And that's flame pretence, and specifically a standard for FeLP1, and Betula varicosa there is now a standard for BetV1. And they have been implemented as the European Pharmacopoeia. They are actually pharmacopoeial reference standards, and the manufacturers that have relevant products are now testing using those standards to determine the BetV1 content using the same method, and a FeLP1 content using this method for the relevant products. And I believe that they are being not reported as the label strength, but still being either put on the label or in the insert as additional information. The product strength is still being reported as the strength determined by the individual companies, because in Europe, the standardization is done by the strength is determined by the individual companies compared to an in-house reference that has a whole approval process through their registration process. So I don't know if that answers your question, but our concern is if we have a BetV1 standard that we're testing to in Europe, for example, and we get a new standard in the US that is, I like the idea of this standard that covers, birch, oak, and all of the related allergens, but having to test to both on the same product is our concern.
Great, thank you.
Helped.
Can I say something about that?
Yes. Oh, sorry.
Yes. Yeah. What I tried to do in my talk a little was to point out that 3 companies that are active in Europe have taken the situation with dust mite and said, we know how to measure group 1 and group 2 allergens and can define a range that we think would be appropriate without being particularly strict about what the ratios are. And then each of them has stated at some point that they're actually looking at other allergens and know that they're present. And that seems to me a rational approach to the dust mite at the moment. We're not ready to define the quantity of DERP23 in extracts, and it's not clear that many allergists in practice would know what DERP23 meant. So that I think that's what I see as the way that the European market is likely to go. And if Dr. Rep, if you have a feeling that it's different, since you represent 2 companies that are really active in Europe.
Okay. Question from Dr. Assad.
Yes, my question is for Dr. Rep. I do have a problem with a lot of things you said. But the major problem is your declaration that these products are safe and effective. Basically, the major impediment to us knowing safety and efficacy is that we don't even know what's in there. The safety is not 100%. There's been, we don't know, the positive and negative predictive value of these skin tests, which we use these products for diagnosis, and they're not equivalent among different manufacturers and different products. The safety is not 100% there. There are lots of reports over the years of anaphylaxis to the allergen immunotherapy, the subcutaneous allergen immunotherapy. So I'm not really sure about what you're saying. It's that's one comment or question. The second one is I mean, from the point of view of a manufacturer, acquiring a machine or a person to run that machine, or finding a way to get the assay done will be just the first step, because a lot of these other allergens are gonna hopefully also become standardized, and the FDA will move on from one allergen to the next, hopefully. So it's not like all the cost is going to go to dust mites if you have to acquire a machine or do something else. So I'll be eager to see what you have to say.
So thank you. Thank you for the comments. Regarding the safety and efficacy, I guess when I say that, I mean within the constraints of the licensing and the labeling. There are black box warnings on all of our products, and that is to acknowledge, you know, there are risks with them. But when I say safe and effective, I mean within the whole construct of the licensing approvals and applications, and within our labeling and our package insert information. So that's, I guess, what I meant by that. So I guess I don't want to disregard there are some risks with our products. They're pretty well known, and you're very right. We do get adverse reaction reports, and we monitor them. But those are, I think, pretty clearly discussed in the information across the products. For the costs, yes, that is correct. There will be the initial investment for the equipment will be high. There is maintenance and continuous qualification of equipment. That can also be costly. And depending on how many allergens we are going to have to implement and potentially release on, there is cost for validations. If we have to do process improvements for as each allergens are introduced, that will still contribute to the cost, and we will have to develop and validate methods for those, maybe internally in addition to the ones that are provided by the agency, just to be able to assess our overall product. So I think it's also hard to assess the actual cost for the implementation of the methods. I think you can either overly simplify it or you can overly complicate it. The truth is probably somewhere in the middle, but there will be additional costs.
Yes.
It was okay.
I understand that, but isn't that the cost of doing business? Like you're creating a product, and it has to be, measured one way or another. Your package inserts don't usually say how much there is. I mean, it goes by weight per volume in some things. Some things would do say the BAUs or the AUs, but that doesn't end up being anything that's of major use other than us trying to utilize guidelines of how to prescribe allergen immunotherapy, for example, based on the previously standardized AUs and BAUs. But nothing, the rest is weight per volume, which is like doesn't mean very much. And you've seen the data there that when they actually looked at different products or different batches from the same product, they are not similar. They're not the same.
Yeah, and I fully acknowledge that they aren't the same, but I guess when it comes to the new standardizations is also, I think Dr. Rabin said the same thing. There has to be a prioritization. I think we have over 200 species in the US, maybe more. I don't remember the exact number. And to characterize and define each and every one of those might not be a practical task, at least unless we want to take 20, 30 years to do it. It's not that different in other markets. There are weight per volume products in Europe, for example. So I do absolutely understand your point of view. We're not against, standardizing more products. It's just we want it to be tied to something like clinical relevance, just measuring an allergen. What is it tied to, I guess? We, of course, want our products to be potent. We do understand the issue, especially with the recent diagnostics of the foods that we would love to see resolved as well. So it's acknowledged, but also understand from a manufacturing standpoint, there is a lot of practical aspects for us as well.
But are you comfortable as a consumer? Are you comfortable as a consumer and not a representative of the manufacturing that you might be given one day, an allergy shot with a little of something, and then the next day you're given an allergy shot with a lot more, and the third day you're given it with much less, because all of this is not equivalent and is not standardized. And you change from an allergist to another, then you have to start from the beginning again. And it's all an unknown. It's really an unknown and I think at the end of the day, it really damages the reputation of allergists and the practice of allergy in general.
Yeah, I'd say that's a fair statement. I'm presenting here on behalf of the industry, so I'm not the consumer representative, so I might have some personal response to that, but I'm going to avoid saying that just because that's not my purpose here today. There is some cost associated with it, and also what we want to benefit the patient, so there does need to be a cost benefit for the patient as well. And I don't know what that is because, as you said, we don't know a lot about these extracts. I would say how currently they are kind of consistent within a manufacturer through the process. We have very consistent process. And, these are biological products, and sometimes there's things we can't control. So even if we did know the exact composition, for example, I've done development within the source material world. When there's a drought, we will see differences in how the pollen itself looks and what it's expressing. So we do also have to deal with nature. And so we are a little concerned of over-characterizing a product in a way that we might even have shortages because of some of this natural variation, and we won't be able to supply anything or any sort of treatment, which for us, we see better than no treatment.
I understand that, but when you look at the cost for the patients, they're paying for something they don't know what it is. There is no measure of what's in there, except for a few allergens. So it's like, is it a gimmick that we're giving them the stuff? We don't know what's in it, or we're doing skin tests with stuff that we don't know how much the potency is. That is a real problem. And I personally think that the FDA's move to try and to start this standardization process on sound basis is a good move.
And
so anyway,
it's a great place to move on from this particular. It's enlightening to hear both of you discuss this, but we gotta move to the 4 questions on hand. Cecily and Avi, do you mind putting up the 4 questions we will be deliberating?
Yes, Avi, thank you.
Okay, so I'm gonna go through the 4 questions. I'll be reading them. Please prepare your questions that you want to deliberate amongst the committee members or by asking the FDA representatives in order to get informed voting, hopefully, around these 4 questions. Question 1 pertains to mass concentration measurements. Does measurement of mass concentrations by ELISA of their major allergens provide a scientifically sound approach for expressing and reporting potencies of cat hair and pelt allergen extracts and of short ragweed pollen allergen extracts? Next questions. Where's question 2? Or did you jump to
question 4?
Okay. Do the available data support inclusion of both house dust mite bodies and fecal pellets as source materials for house dust mite allergen extracts to more adequately mimic?
So we'll just go back. We'll do 2 and then go right through to 4. I think they pulled up 4 by mistake.
Okay. This question 2 is CBER allergenic standardization program. Are the revised assays for cat hair, pelt, and ragweed pollen allergen extract scientifically appropriate templates for expanding CBER's allergenic standardization program to include major food allergens and environmental allergens? Next. Does LC-MS technology compared with the currently used analytic technology provide sufficient fit for purpose analytical capability for better characterization of complex allergen extracts to improve product quality? Question 4. Do the available data support inclusion of both house dust mite bodies and fecal pellets as source material for the HDM allergen extracts to more adequately mimic clinically relevant allergen exposures? So I know there were at least a couple people with raised hands. Please use the raise hand function again so we can begin discussing these questions and deliberating around them. I can begin by indicating that a common thread that sort of went through these 4 questions, the uncertainty of the clinical output of the endeavor. Definitely having more precise measures, more modern measures of extracting and purifying and measuring these allergens would be welcome and would diversify the tools we have. But there are many questions pertaining to the improvement in diagnostics and therapeutics that would come out as a result of this particular project. And in a sense, it opens the horizon for many research questions that can be answered by the scientific community to help enlighten, a lot of the issues that were raised today. Dr. Davis.
Thank you. Yes, I just had some comments and one question. I do think that this is a step in the right direction, but agree with you that there has to be, this connection with the outcome of the test and the clinical relevance. And that speaks to so much of the discussion today. I have actually 2 questions surrounding these questions. One is for Tom Platts-Mills, and that is the use of IgG4 to IgE ratio, and if that might be one of these markers of clinical relevance. Just wondering, since there was an outcome of an atopic disease like asthma to this particular test. It's not likely as functional as the BAT or the mast cell activation test, but but could that be also another outcome besides skin testing? The other question I have is for Dr. Rep. How easy, there's a process to isolate the fecal pellets and also the bodies. How easy is it? I mean, I know something would have to be done, but it seemed to me like it might be fairly easy to just change the ratio and increase the fecal pellet protein amount. But I'd like to know, just from a manufacturing standpoint, how easy or difficult that might be. And a corollary to that is how easy or difficult it might be to change the spore to hyphae ratio for mold production. I know it's complex, like a four-part question.
Can I answer or address the IgG4 question? Clearly, doing IgG4 assays, as far as we know, has to be done with immunocap, and it's clearly not inexpensive. It certainly has a cost to it. Doing IgG4 on Isaac is tricky because there are all recombinant allergens on the Isaac, and you get different answers. But I think IgG4 ratios is a very interesting research question. I don't see it as part of standardization at this point.
Okay, thank you. Mm-hmm.
So I will take the questions on the how easy is it to change the mite processing and also the mold. So for the mites, yeah, I mean, it's it's a separation of particles by size. It's a size particle separation. It sounds simple. There are some complications. The amount of allergens in the fecal pellets and in the mites themselves aren't consistent. There is there's actually quite a bit of variability from batch to batch. I'm not going to be able to share data, and I'm not going to be able to share too much, but we do trend that, and we do see quite a bit of variability. So if you essentially are purifying your mites to, remove the food, and then to a certain amount of, like, if you're trying to aim for a specification of the amount of fecal within the body extract to have a mix there, and you just extract off of that, you're going to have some variability. The idea of sieving or separating somehow the bodies from the fecal and then, adding in a specific amount, that's where we're getting into maybe the patent from ALK, where they've gotten that, they have a process defined and described in that patent. So there could be some issues there. I've worked with mites for quite a long time on a production commercial scale, and there's still a lot of things we don't know about their biology, but we're always amazed at how complicated it actually is, but it is doable. I mean, it's not impossible, but there's some complications with it. The molds, it's actually, the data on the mass spec was extremely interesting. One of the first things I did in my career was grow molds. And you're essentially growing mold pelts. You're starting out with a small culture, and then you're going to pelt. Probably, I mean, we'd have to do some development on that, but probably you could stop it at a point of pelt development of where there's more of one type of spore versus a hyphae. Also, I was reading the briefing book. There's some allergens that are expressed into the media. I believe some of the source material removes the media, maybe some doesn't. So there probably could be some adjustments made to include those, but it would be some development work. And when we're talking about multiple species, you do have to do that across all the species. And then it's development on the source material and then through the extract, just to make sure that, it's all getting through to the final product. So I don't know, does that answer your question, or did I just make it more confusing?
No, that's fine. Thank you very much.
Dr. Dykowitz?
Yes, thank you. This is a question of clarification for Dr. Rep. And in your presentation, you said that one might consider ring trials before implementation. Could you elaborate on everything that would be involved with doing ring trials?
Sorry. Yeah, so the ring trials essentially would include a protocol that covers, all manufacturers, like a universal protocol. You would send out the reagents and the test method to each manufacturer that would have a relevant product, and essentially have them test it within their labs with their people to make sure that they're getting consistent results and expected results using that method with similar precision and repeatability across all the manufacturers and their products. Because there could be some differences in the product matrices that might be interfering with it, that maybe wasn't seen in the development in a research lab, for example, but that you would see in a production environment. And then you would essentially take all of that data and evaluate it for the appropriateness of, is it ready to be used as a standardized test for the industry or not?
So the point that you would have is that until everything had been really definitely clarified as being reproducible across manufacturers, that there would not be any regulatory requirement for such labeling?
Yes, I think that's kind of what that is essentially what we're proposing. We want to make sure it's appropriate for the intended use of the products that are currently on the market. You wouldn't want to release a standard that we find out after it's been implemented that it doesn't work with one of our products, and now we can't release it, for example, or at least work as intended.
I mean, my other alternative thought of this would be that you would set some standardized requirements for release, but then as part of characterization, make the, if you will, the mandate that there be assessment of the content of these extracts using these other techniques. And, after the fact, study if there were any issues with reproducibility or comparability. And I kind of viewing the idea of requiring ring trials before implementation as obstruction to moving forward, with admittedly the need that as we implement new standards, there have to be studies of the relevance and the applicability of these. Thank you.
So, sorry, was there a specific question?
No, I think it was more of a comment.
Okay, just wanted to make sure.
Dr. Greenberger.
Thank you. Thank you for the presentations. I have to say that I think when the new methodology should be applied, they should be applied to currently standardized products such as ragweed or cat, and to see if the technology, say ELISA's used in a modified way, could be useful to try to have some release criteria put into place. And I am viewing these questions sort of as compared to this current situation, how much research is needed to get there. Because I think that would be helpful to try to get the release criteria as a target. So it's more of a statement than a question.
But I can, take, because again, this is a recurring theme since the beginning of the talk, and I would like to ask Dr. Rabin and the colleagues within his lab, are there plans to compare the standardized methods, modern methods, with a particular clinical readout?
Well, there weren't, because particularly for the ragweed and the cap, because we were simply revising one assay to another assay. It might be, I mean, we've had this discussion, and I think I've said a number of times that, I'm hearing that. And so, I'm taking it under advisement. It might be useful. It might be a useful thing to try to do with cat and ragweed sort of as a precedent to see what comes out before we venture into the other uncharted territories. But it's not going to stop us from adopting the new assays for ragweed and cat. So, I think that's the best answer I can give you, given the fact that this is the first time that I've heard this argument, being very vociferously and, passionately made, and it's very rational. But obviously, I'm not going to make any decisions about our strategy on the fly on the day of an advisory committee meeting. The committee will have to trust that we're taking their advice, very seriously. And we know who to consult, to move forward, and we'll do that.
Okay, thank you. Dr. Dykowitz, is that a new question or from before your hand was raised?
Oh, sorry, I should have lowered my hand. Thank you.
All right. Dr. Portnoy?
Hello. So as the consumer representative, I'm really concerned about the transition from the current status to the new standardized extracts. I think that's going to be a real chocolate mess when allergists are told, here's the new extract, you have to start using it. It's going to cost more. It's going to be very confusing. So that's just one comment that I have that gives me a lot of pause about this. On the other hand, I really do think that we need to move forward into the 21st century with new technologies, because the old way is really very outdated. My question is, when we vote on these 4 issues, I assume that this is just giving the lab permission to study these as a way of possibly standardizing these extracts. I don't see any wording that says that it will then become mandatory that they must do this. And if it's something that I'm voting for that says this is how it's going to be and it's mandatory, I'm probably going to vote no on these things, because I don't think that the data is there and that we're it's ready for prime time. On the other hand, if we're giving the lab permission to move forward with studying these approaches to see if they would be a valid way of standardizing these extracts, and perhaps will the extracts be better when they're standardized, then I would be more inclined to vote yes. I'm just kind of asking for clarification on what exactly it is that I'm voting for.
Okay, so with regard to your first question, I would remind you that once upon a time, none of the extracts were standardized, and then a bunch of extracts were standardized, and the medical community seemed to adopt to that standardization just fine. So I see
it
no
was
reason.
A chocolate mess, I remember it, but they eventually came around.
Okay, well, then it'll be another chocolate mess, and then they will eventually come around. Or maybe we'll have learned, or maybe we can figure out, with consultation with the Quad AI and the college as to how, we can minimize the chocolate in the mess. But no, I let me state very clearly that it is our intention to move forward with this, okay? Particularly with the foods, I really feel, and we really feel, I think I'm speaking for upper management here, that we've had some failures that have, that have caused harm, and that, as a regulatory agency that has the authority to take corrective action so that this harm is not caused again, I think we would be remiss not to standardize these food allergens. I feel very strongly about that, and I believe I have support from upper management on that. So yeah, you're voting on action, okay? We didn't come, let me make it very clear, sir. We did not come to advisory committee to ask you if we can think about doing something. We came to advisory committee to ask you that we intend to tell you that we intend to do something and to seek concurrence on that.
Okay. Thank you.
Dr. Monto?
this is very far away from my area of expertise, but I heard something which Dr. Rabin can give a specific answer to, and that is the issue of material in the mass spec assay being denatured and not active, which will show up in that assay. And is that the case?
Well, I'm gonna let Dr. Strader answer that, and then if there's anything he left out, I'll.
Yeah. So first of all, this is a good time for me to make a clarification to an earlier comment. You can calculate absolute concentration using mass spectrometry. You absolutely can. You can also calculate relative abundances. The targeted approach, the PRM method that we're describing, would be the next step where you would calculate absolute concentration and therefore potency. That's one thing. Another thing too is there is this possibility that the peptide that gives you the quant doesn't tell you anything about the intact form. And we realize that. That's why you would do this orthogonally with methods where you look for the epitope.
Yeah.
Yeah. So, I mean, we're not saying replace, we're saying use this new 21st century technology orthogonally to better characterize your potency.
Obviously, if there's a drawback to a particular technology and there's a way to address that drawback within, then we would do that. And so.
And one more thing, there's a cost to it, but remember, you can measure multiple allergens in an assay using the single data acquisition. Once you know what your allergens are, you can find your peptides, provided you do that right. You can calculate the quantity of several allergens in one assay.
Okay. Yeah, I think we've answered that.
Yeah, I think we have.
And I'm very sympathetic to the issue of when you start having false positives to a peanut allergy, that you've got to do something.
Yeah.
Thank you.
False negatives, excuse me.
Can I say?
Dr. Platzmel, unfortunately, you can only answer particular questions to your presentation. That's the rule here. Dr. Greenberger, did you have a question or comment?
My comment is we have to keep safety of the patient and stability in the physician offices important, very important for all of us to keep in mind when we make changes. I've seen modifications in what we bought as extracts when there have been shortages, but that was with venom, and we had standardized product to make the change. So, and that went, at least at Northwestern, I can speak my own patients, it went smoothly. But then we had standardized extract measured on the two enzymes that are used. So that's why I talked earlier about having assays to make sure we have standardized products that we can agree on. And I think the changes can be made with the help of our major organizations. But I still seem to think we would need the data before we can make any major changes. So I asked that earlier of Dr. Rabin about moving
of course,
with the research.
Of course. I mean, if you I would remind you to go, that we made it very clear that, that part of the, we showed you that whole template. You might remember it was a number of hours ago now, but it was on an arrow. And, on the arrow, we had the different stages. And one of the stages are we publish the data before the assay is adopted. So, yes, of course, you would see the data.
Great.
Dr. Portnoy, you have another question?
Actually, I just have a question for Dr. Platts-Mills, and that is, what were you going to tell us that you thought was really important? Because I'd like to hear your answer, and since you can't ask a question. I'm asking you to answer it, please. Hope you're muted.
I apologize. Dr. Rabin brought up the issue of the peanut situation where a peanut extract appeared on the market that had very little peanut in it. And that would have been solved if there had been an assay of RH1 and RH2 in that extract. It would have been picked up immediately. And you didn't need to have assays of 8, 9, 10. You just of those two major allergens would have certainly prevented that problem.
Yeah, and by the way, I'm concerned about both false positive and false negative skin tests with peanut, because if somebody's not allergic to peanut, but the extract's so strong that it elicits a non-specific response, that could be just as harmful.
Yeah.
Yes, we're aware of that. We're aware of that. My conversations with Dr. Lack, we discussed that. And yeah, that's right. I mean, it makes it no different than any other pharmaceutical. There's a range, there's a dosage range in which is optimal.
Mm-hmm.
Dr. Assad.
Yes, I have a question for Dr. Rabin. Your last slide, or one of your last slides in the first presentation, showed that the assay is still not, you said that it wasn't tight enough. Did I understand correctly that you're still working on it?
The FeLD1 assay, as we published it, was not tight enough for regulatory purposes. We are improving it. We've improved it already. Okay. I mean, we've been improving it. We tightened it up. I showed you some preliminary data showing that we basically tightened up the CV from like 25% to 6% or something like that, preliminarily. I mean, we've tightened it up a great deal.
Okay, very good.
And we're not done. Okay.
Okay, great. Yes.
I mean, as obviously, that is why I spent those 4 slides speaking about the steps that we have to go through for validation. We take that very seriously.
Very nice. Thank you. The question I have, though, is after 20 years of doing this, or 30 years, and thinking a lot about it, is what you're proposing as doing the ELISA, and also maybe with or without, I'm not clear where the ELISA will stand versus the mass spectrometry. Are these the best options? And if at some point they do not work, like any grant or any proposal, what's the alternative?
I guess I haven't given that much thought. I guess I have confidence in ELISAs, and I have confidence in the technology. If there are alternatives, I'm sure they're not secrets, and I'm sure we can find them.
Okay.
Okay, thank you. Dr. Carla Davis.
Thank you. I wanted to make a couple of comments and maybe a question at the end. So one comment that I would like to address is the concept that better major and minor allergen detection is going to be better, I believe, for characterization, but in having some standards for release, or quote unquote standardization. We've talked a lot about using, one major allergen or 2 of the major allergens. I just want to bring up the potential downside of having too many allergens for standardization or release that would cause batches to be discarded. And in the case of peanut, that, if there are too many batches that do not have all of the required allergens, right? We want to avoid that. So I really do favor this concept of a simplified release, but then characterization on the back.
I hear you. We get that. I include that in my comments about, perfect being the enemy of the good. We have to do what works. Okay. So we're not going to ask people to do things that are unrealistic or that cause you throw out a lot of lots, because then you end up with shortages because the company, we don't want to shoot ourselves in the foot.
Okay, and that just hadn't been discussed. Wanted to make sure it was. The other comment I would say, or clarification, would be this word potency. So the potency could be utilized as concentration, which means presence or more presence, but it doesn't necessarily indicate function. And so I think we've clarified this, but I just wanted to find out if you agree with the using the word potency for a concentration of a protein, which does indicate presence, but not necessarily function or clinical relevance.
Yeah, I think in the term potency sort of means strength in a regulatory sense, and in terms of unmodified allergens, it is implicit that potency is tied to biological activity. That is the ability of the intact molecule to bind to IgE, which is, of course, the bottom line of what allergic disease is about, right? So, so in that context it is, and sometimes, as is the case with the with a lot of, the potency of the venoms is the enzymatic activity of the, of two venom allergens. And, the enzymatic activity may have something to do with the allergic response. We know that enzymes can, do that, but that's obviously a proxy for an intact molecule that IgE can recognize. So, that's sort of how we think of it in with a broad brush. Does that answer your question?
Yeah, so it's a proxy. I just wanted to clarify that it is a proxy.
Yeah, sometimes it's going to be, sometimes it's going to be a proxy. Yeah, because we can't do ID50s on everybody, and we're not going to ask the manufacturers to do basophil activation tests and so on. We have to, as for your first comment, you have to do what's realistic, and you have to,
Yeah, no, that sounds great. And I do agree that the major allergy organizations would be key in really making a smooth implementation. Thank you so much.
Absolutely. You're very welcome.
Can you hear me? Okay, I have a minor question that I asked earlier, and this would be addressed to Dr. Rabin and Dr. Platts Mills. Is the inclusion of a defined component from the fecal pellet going to improve on our ability to either manufacture the extract, diagnose the allergy, or treat the allergy?
It is our belief. I can't speak to manufacturing because I don't do that, but it is most definitely our belief that it will improve the reagent as a diagnostic and a therapeutic reagent.
Yeah, and I would add that I think that unequivocally the dust mite fecal pellets are the thing that we really know becomes airborne and is most likely to become inhaled and it contains large quantities of DERP1, and that marketing an extract that is dominantly DERP2 and has much less DERP1 seems almost certainly wrong, and that it is better to have a mixture of DERP1 and DERP2. The reason for not going further than that is the practical reasons that many people have proposed, and just the inevitability that allergists are not going to be aware of all those things. The amount of immunology that allergists are now expected to learn is overwhelming, and asking them to know 10 different allergens for every source is absolutely unreasonable.
Thank you.
Not sure that answers the question.
Okay, so I see there are no more raised hands, so we're going to go through the questions for this afternoon. Cicely, you want to put up the slides for the questions?
Yeah, so we should run through those questions one more time like we did before. Just bring them up one by one and have you, Dr. Elsali, read each one.
Okay. Question 1, mass concentration measurements. Does measurement of mass concentrations by ELISA of their major allergens provide a scientifically sound approach for expressing and reporting potencies of cat hair and pelt allergen extracts and of short ragweed pollen allergen extracts? Question 2. Are the revised assays for cat hair, pelt, and ragweed pollen allergen extracts scientifically appropriate templates for expanding CBER's allergenic standardization program to include major food allergens and environmental allergens? Question 3, does LC-MS technology, compared with the currently used analytic technology, provide sufficient fit-for-purpose analytic capability for better characterization of complex allergen extracts to improve product quality? And question 4, do the available data support inclusion of both house dust mite bodies and fecal pellets as source materials for the house dust mite allergen extracts to more adequately mimic clinically relevant allergen exposure?
Thank you, Dr. Elsali. So because we had the general discussion of the 4 questions at the same time, we're going to hold voting of the 4 questions in one voting session. So I'm going to give the instructions for voting, and then we'll move into the breakout room while we, those non-voting members will be moved into the breakout room while we conduct the vote, excuse me. So a voting window will appear. This is for the members where you can submit your vote. There will be no discussion during the vote session. You should select the button in the window that corresponds to your vote, which will be yes, no, or abstain. Please note that once you click the submit button, you will not be able to change your vote. Once all voting members have selected their vote, I will announce that the voting is closed. Please note there will be a monetary pause, and it may be a little longer than usual, as we tally the votes results and return to non-voting members into the meeting room. Next, the vote results will be displayed on the screen. The 4 vote results will be displayed on the screen. And I will read the results from each one as Dr. Elsali handles question 1, 2, 3, and 4 in sequential order. I will start out by reading the poll results, and she will go into the round robin with rationale from each member for the vote. So are there any questions before we begin? Okay, I'm not seeing any questions. All right, so we'll go into voting. Thank you. Okay.
Recording in progress.
Voting has closed and is now complete for the 4 questions. The voting results will be displayed. Okay.
What are we? We're seeing question 1 now. Looks like 2 questions.
Yeah. Okay, this is question 1. So for question 1, we have 12 yeses and 1 abstain. And Dr. Elsali, you can, the question was, does measurement of mass concentration by ELISA of the major allergens provide a scientifically sound approach for, can we move that?
Cut off.
Let me pull it up myself. Let's see. Question 1 was, does measurement of mass concentration by ELISA of their major allergens provide a scientifically sound approach for expressing and reporting potencies of cat hair and pet allergen extracts and of short ragweed pollen allergen extracts? And so we had 13 yeses and 1 abstain. Thank you.
So what we're going to do now is ask each member to give a rationale for their voting, beginning with Dr. Greenberger.
Voted yes, because it is scientifically sound to use this approach and gather the data. And I would urge priority of the FDA to focus on cat and ragweed in the beginning.
Okay, thank you. Dr. Monto.
I agree. I think that ELISA is now and has been for a number of years, a standard. And relying on something like radial diffusion is really not as accurate or precise. So I voted yes.
Thank you. Dr. Meyer.
Hello. So I voted to abstain on this question as well as subsequent questions. I felt like there was great evidence presented about the need for standardization, the need for strengthening the standardization program, for modernizing it. I thought all of the evidence kind of supported voting yes for this question. But I felt like the questions, they're very technical, requiring a certain area of expertise. I think allergy is a new area to the VRBPAC committee, and I did not feel in a position to vote one way or the other today.
Thank you. Dr. Perlman.
Yes, I thought that the changing to an ELISA was an improvement. I think just looking at that radial diffusion apparatus, I don't think there's really a choice, because that looks like it would need repair imminently.
Thank you. Dr. Davis.
I also feel that the ELISA is a standard, and the current way of measuring was really antiquated. And so I'm glad that the FDA is moving forward. I believe starting with the major allergens, especially those who've been very well characterized, is a great approach.
Okay, Dr. Assad.
Yes, I voted yes because I have studied allergy back in the 80s, and radioimmunodiffusion was the thing to be done back then. So it's pretty antiquated. And Dr. Rabin has presented very convincing evidence of the work with ELISA being both scientifically sound and productive.
Thank you. Dr. Dykowitz.
I also voted yes. I think ELISA is a very well-established procedure. Radial immunodeficiency or diffusion rather is well, it's antiquated. I think the data that was presented by the FDA by Dr. Rabin was compelling. It was demonstrating consistency of results, and I think it is going to be ready for prime time and should be a standard.
Thank you. I also voted yes. Modernizing the methods of measuring the specific allergen is a good start, as presented by the FDA labs, and especially when paired with their willingness to take some of the advisement given during the meeting today. Dr. Rubin?
I'm going to answer for actually all the questions because I think that measuring things better and not by 1970s methods is always good. We should know what's in these things. I hear the concerns brought up by some that we don't know what to do with the information, and I think that's fair. We don't know how well the measurement of the major allergen is going to predict the biological effect that you want to either measure or get, and that's fair. But you should start with good measurements before you even worry about that.
Thank you, Dr. Durbin.
Thank you. I voted yes. I don't have a lot to add to what others have said, just to say that I thought the data were very sound and scientifically supported the move. Thank you.
Dr. Portnoy.
I also voted yes, and it's about time that we moved allergen standardization into the 21st century. I've used ELISA in the lab for many years. It's a very well-established technique that's widely used in healthcare. When I get labs drawn, a lot of times the tests that are done by ELISA. So it's well-established. There's no reason why in allergy we can't use this proven technique.
Dr. Omer?
So I voted yes as well, and I think it's high time we moved from RID-based assays to something more advanced or relatively more contemporary. So I think it makes a lot of sense to do that. The case was made pretty convincingly. But I will note something that is relevant to both question 1 and 2, which is that it would be helpful not only to present biological evidence in these kinds of deliberation, especially when it's a new approach being recommended, not only biological evidence, but also quantitative evidence supporting it, or the approach that is proposed. So as I noted in my question as well, and it doesn't have to be any extensive detail of statistical methods, but at least either in the background material that may suffice in a lot of cases, if not in the presentation. So the full range of science should be presented in these kinds of situations. It may not be relevant to other situations, but I felt for both question 1 and 2, that was something that would have been appropriate to have been included.
Okay, thank you, Dr. Bernstein.
Yes, I voted yes as well. A lot's already been said. The need for standardization is there, and this would be a notable improvement. So that's why I voted yes.
Thank you. So to summarize, the first question got an 12 yes, 1 abstain, so mostly yes. Precisely because everyone agreed that modernization of allergen extract measurement is needed, and adopting newer methods would be welcome. The abstention had to do mostly with not feeling comfortable with the expertise around this question that is highly specific. Of note, the need to provide additional statistical analysis around the assay performance was a noted deficiency that should be provided with additional or with subsequent VRBPAC or questions revolving around assay development. Next.
Okay, we can move to question 2, results. Okay, so we had 11 yeses, 1 no, and 1 abstain for the record. And the question that people responded to was, are the revised assays for cat hair / pelt and ragweed pollen allergen extracts scientifically appropriate templates for expanding CBER's allergenic standardization program to include major food allergens and environmental allergens?
Okay, great. Dr. Greenberger.
Voted yes. Similar thinking as question 1, and I would feel that there should be input in interactions with industry along with interested academics. Regarding environmental allergens, I've seen how, with my own eyes, how modifications in how Aspergillus fumigatus is cultured either cause lack of reactivity, IgE binding or not, and lack of T cell stimulation or not. So there needs to be a lot of input with interested parties.
Thank you. Dr. Monto.
I'm in favor of expanding the standardization. Many things that are of importance from what we've heard are not well standardized, and that's the reason I voted yes.
Dr. Meyer, I know you indicated that your answer.
Yes, it's consistent reason across all of my abstention votes.
Understood. Dr. Perman?
Yes, so I voted yes for the reasons that have been mentioned already. I think that expanding the program to include food allergens and environmental allergens is a good idea.
Dr. Assad?
Yes, I voted yes because there is a need to extend the more modern standardization to major food allergens and environmental allergens. Still with 2 issues that I would like to see addressed. When we say major food allergens, does it include some of the components or just the general, overall food allergy? And also encouraging to move on to clinical significance by various means.
Mm-hmm. Thank you. Dr. Davis.
I voted yes because although these assays will start with cat hair, pelt, and ragweed, there are 19 standardized allergens, and then there are also many, many more. And I would hate for there to be any delay in actually using these for the many allergens that are clinically relevant. I agree that there needs to be academic involvement as well as clinical relevance and I would say, some clinical correlation when these assays are moved to other food and environmental allergens. But this is a great step, and I support expansion.
Thank you. Dr. Dykowitz.
Well, of course, echo the comments made by my preceding colleagues. I think the need to move forward, particularly for, as an example, the peanut allergen characterization and standardization, that's one of the most compelling issues that I think the committee has been presented with. And I think moving forward with characterizing the peanut extract and other food extracts is really essential to move forward with assuring clinical reliability of extract. So very much in favor of this.
Thank you. I voted yes. I wanted to vote yes, but however, there is no such option. The issue here is that from moving from question 1 to question 2, I think that particular space is where the issue of clinical utility and implementation questions would need to be addressed before expanding to the full-on portfolio of allergens. At least beginning that work. That was not an option as a vote, but I voted yes with this particular caveat. I do know that the Division of Allergy and Immunology and Transplant within the NIH is always updating their priorities of research, and just like any other division. And I think the discussion we've had today and the direction with which the FDA is going sort of opens the door for a full-on research program to partner on. Dr. Rubin?
I agree entirely with what you said. There is no reason we shouldn't better characterize what we're putting into people. But what you do with the information you get, I think, is a question. So we should measure well, and then we should figure out what we do with those measurements.
Yeah, it's just that I would hate that we characterize all 19 and then realize that could have found out earlier that something needs to be tweaked. But yeah, Dr. Durbin.
Yeah, I voted yes, and I echo my colleagues' comments. And just to say that I think it's critically important that the standardization for these allergens, including food allergens, so that we don't mischaracterize people, which could lead to serious consequences. Thank you.
Dr. Portnoy?
And I also voted yes. If it works for cat and for ragweed, it probably will work for all of the other allergens. We might as well get it done. But as every medical paper ends with the following statement, further research is needed. Thank you.
Dr. Omer.
I voted yes, and I don't have anything additional to add beyond what my colleagues have stated.
You and Dr. Bernstein.
Yes. So I voted no. I was like you, Dr. El-Sali. I was teetering. It ended up being 51-49 in my mind. I think the expansion is appropriate and important, but I had concern for the possible degree of imprecision and how that would translate into clinical relevance. So that's why I said no.
And I will raise the issue at, pertaining here to what you just mentioned, is that when we vote sometimes on vaccine and there are uncertainties, there are always post-approval research requirements versus commitments. And I think here, something along those lines is maybe adequate. So to summarize, this particular question received 11 yes, 1 abstain, and 1 no. The committee members wanted at this stage of the standardization project within the FDA to see more industry and academia engagement. The issue of food allergy, especially peanuts, is a pressing question for which standardization and of product and linking to clinical relevance is needed. And then the issue of partnering with other organizations to set the research priority as these expansions or before these expansions take place. Next.
Thank you. Moving on to the third question posed to the committee, does LC-MS technology compared with the currently used analytic technology provide sufficient fit-for-purpose analytical capability for better characterization of complex allergen extracts to improve product quality? Okay.
Okay, so
we have 8. Oh, sorry.
No, go ahead.
8, just for the record, 8 yes, 3 abstain, and 1 no.
2 no.
2 no. Oh, 2 no. Sorry. 2 no's. 8 yes, 2 no's, and 3 abstain. Thank you.
Dr. Greenberger?
I voted no because in reading the question, I looked at sufficient fit for purpose, which I asked Dr. Rabin about. And I don't think I have information that I can confidently answer the question positively. I'd like to come back in a year and be asked the same question and see some data, and then vote yes.
Dr. Monto?
I voted yes because of the response to my question about mass spectrometry, that a number of different procedures will be used, and there will not be total reliance on one if there are any questions.
Okay, thank you. Dr. Meyer?
Nothing further to add from my prior.
Okay, thank you. Dr. Perman?
Yeah, so I abstained on this one because I thought that using LCMS is a good step forward, but I wasn't convinced that the data was going to be processed appropriately, or not appropriately, but that we were going to be able to use it in a meaningful way. So that's why I just ended up at abstain.
Thank you. Dr. Assad?
Yes, I voted yes because of the data presented, as well as the issue of complex allergen extracts, because many of the allergenic extracts are complex, and the ELISA by itself, as it was proposed to just address the major allergens, is not going to solve the issue of the complexity of the allergenic extracts. And I heard that the LCMS will solve that question.
Okay. Dr. Davis?
Yes, I voted yes. I do have some LCMS experience and research, and I was pretty confident that there is a way to use that technology to identify specific allergens and specific major and minor allergens in an extract, and I felt that the data presented was adequate to say that yes, this could be sufficient for characterization purposes, and as long as it is connected with some other simpler test that would be utilized for release rather than this particular one. But I do believe it is important to characterize all of the allergens, and I don't think ELISA or the other methods would adequately do that, but this would be effective. That's what I
Okay, thank you. Dr. Dakowitz?
I voted yes. And to echo Dr. Assad's comments, I think particularly when we're looking at trying to characterize complex allergen extracts that have many different components, some which may be relevant to some may not, but in terms of best characterizing complex allergen extracts, I think this approach is important to use. Now, I am mindful in terms of a caveat that the statements were made that as part of the preparation process of samples, there could be denaturation of materials that wouldn't necessarily equate when they were detected with allergenic importance. But overall, I think the evidence is quite sufficient to move forward with this.
Okay, thank you. I voted abstain because the data presented did not sort of lend itself to a fit for purpose, assuming the purpose is improving diagnostics and therapeutic approaches. I think it still is very intriguing and worth researching, but probably not enough data to convince that it is ready for prime time and wide usage as proposed. Dr. Rubin?
I'd say that where the immunodiffusion tests are 1970s or 1960s, and the ELISA's 1970s, and this is 2020s now technology. It's something we use in the lab all the time, including LCMS and PRM. And it has the ability to measure very, very precisely many things simultaneously. So especially for complex mixtures, this is the way to go. So technically, it's the right test. I think that the question that Dr. Monto asked is a good one, though. For conformationally specific allergens, it will not be able to detect the difference because the proteins have to be natured and digested before they're put onto the mass spec. So we will not identify those, and other methods will have to be used if we know about that issue.
Dr. Durbin?
Yeah, I voted yes, because I think the data did support this, particularly for complex antigens. Mass spec is known to have, as Dr. Rubin said, is incredibly precise and useful for that. So I think that it really is the needed step forward. Thank you.
Dr. Portnoy?
Actually, I voted no. ELISA is a great way of measuring allergens. Mass spec is a fantastic tool for characterizing complex allergens. However, I'm not sure that that's really something that's needed for standardization of extracts. A lot of the companies, I was told, don't necessarily have it. If this is approved, this could become a required thing. These companies are going to have to do it. And what are they going to do with the results? I just haven't seen any information that suggests that knowing what's in the extract is going to improve the quality of the extract. So I think it's a great research tool, but it's not quite ready for something to be mandated that extract companies must do it for their extracts. And so for that reason, I voted no.
Okay. Dr. Omer?
Yeah, so I voted yes for the reason that it's a scientifically sound and validated approach and more precise than legacy assays. But more importantly, it's capable of detecting clinically meaningful compositional differences. And it is directly applicable to regulatory lot release testing. So that's a sort of practical consideration there. And it is essential for producing allergen extracts that are not only accurate, potent, but also are consistent with modern analytical standards. And so it is for both specific reasons and big picture reasons that I voted yes on this question.
Okay, thank you. And Dr. Bernstein?
Yes, so I voted yes. Certainly the precision is excellent. I was a bit concerned about the expense of using it, but that didn't deter me from voting yes.
Right, thank you all. So in summary, on this particular topic, the committee had a bit more questions. Nonetheless, the vote passed, we should say. There were The pros of the approach, of course, is it's modern, novel, precise, can detect smaller components, which is useful for complex allergens, and maybe helpful for lot release. On the flip side of it, the issue of expense, whether or not it'll be mandated, and if so, is it needed, which sort of leads to the question, is it really fit for purpose or proven to be fit for purpose? Because it might be. It's just that we didn't see the data that it is. The issue of denaturing the proteins that will be measured was brought up earlier in the discussion today and again now, which is a concern with the use of this technology. So the older technologies or complementary technologies will continue to be used for complex allergens because of that. Next question.
Thank you. Question 4. Do the available data support inclusion of both house dust mite HDM bodies and fecal pellets as source materials for HDM allergen extracts to more adequately mimic clinically relevant allergen exposure? We have 11 yes, 1 no, and 1 abstain.
Mm-hmm. Dr. Greenberger.
Voted yes. And as I've said, you don't have a good skin testing reagent or in vitro assay without good starting material. And to get clinically relevant information, you need the relevant allergens present. So I voted yes.
Okay. Dr. Monto.
I think this was a relatively easy one because from what we've heard, the fecal component is really maybe the most important and should be included.
Dr. Meyer.
No further input from prior response.
Dr. Perlman.
Yeah, I also thought that the data showing that the fecal pellets had much of the allergen were compelling, and for me, it was an easy yes vote.
Dr. Assad?
Yes, I voted yes because Dr. Platzmail has ingrained in us that it's the dust mite feces that has the allergen. So it doesn't make any sense to not have the dust mite feces in the dust mite extracts.
Okay. Dr. Davis.
Yes, it is textbook that the major allergen is in the feces, and so the data were compelling, and it did not seem as if it would be that difficult to make it more prominent in the extracts. So I said yes.
Thank you, Dr. Dykowitz.
Yes, again, I think this was an easy question. The fecal particles are very important as the allergenic source and should be included.
I voted yes in agreement with the data we saw today and the pointed questions I asked the experts also, which affirmed that this should be the way to go. Dr. Rubin?
I'm just glad we got to talk about real feces this time. And I agree with everyone else.
Dr. Durbin?
Yes, I voted yes for the reasons others have already stated. I think it was well justified. Thank you.
Dr. Portnoy?
Yeah, we saw data suggesting that we should include it, so I voted yes because the data supports that.
Okay. Dr. Omer?
Yeah, I voted yes based on the data presented. Nothing further to add.
Thank you. Dr. Bernstein?
So I voted no. This was a close one for me again. I thought it more adequately mimicked relevance, but I was concerned again about I wondered about its clinical precision. So I voted no.
Thank you. So in summary, the committee voted mostly yes on this because the allergic components are more represented in the feces than the body, although they do exist in the body as well of the mite, and potentially including the fecal pellet will improve the utility of these extracts. However, I think it sort of goes back to the main point and main thread we've had today, that needs to be confirmed in epidemiologic or other research design studies. I think we answered all 4 questions.
Yes. And if you want, we can invite Dr. Caslow for some closing remarks.
I have a question to Dr. Caslow. We still use RID for flu. we
yes,
kept talking about how bad.
Yes, we know. We can talk about that maybe at a future VRBPAC meeting in general. So thank you.
I was thinking about that same thing.
I know.
All right. So then on behalf of OVR, I'll start by first thanking Dr. Weirs and Condor, if you remember their presentation from earlier today, and VRBPAC members for today's topic 1 on the 2026 Southern Hemisphere formula for seasonal influenza vaccines. So we duly noted today's discussion on the contribution of neuraminidase, the emergent and potential challenges and opportunities of considering more than one H3N2 strain in seasonal influenza vaccines, and the input of keeping a close eye on the influenza B, Austria-like virus and seasonal influenza vaccines. It hasn't changed for a number of years. Next, I'd like to thank the presenters, VRBPAC, and our 4 temporary voting members for discussion and recommendations on topic 2, and that is CBER's effort to modernize our allergen extract standardization program. So with respect to major allergen standardizations, we heard clearly that beyond analytic qualification and validation, there's a need to consider clinical validation and a learning agenda to enhance public trust in these allergenic products. With respect to the complex extracts with multiple major allergens, we heard about the complexities associated with standardization of these complex extracts and the need to recognize that we're on an iterative journey to continuous improvement in product quality while recognizing the incremental costs and implementation complexities associated with those improvements. So finally, let me thank all for another productive convening of VRBPAC. I'd like to specifically thank our CBER Advisory Committee staff, the FDA Advisory Committee staff, our AV staff, and my colleagues in OVRR who willed into existence another flawless VRBPAC meeting on short timelines and in the midst of the ambiguities associated with a lapse in appropriations. So back to you, Chair, with sincere thanks to you as well.
Thank you so much. I want to thank all my colleagues on the committee for a long yet productive meeting, and the meeting is adjourned.
Thank you. It is 5:10 p.m.
Thanks, everyone.
Thank you.
Thank you.